As I mentioned, this course is going to be highly practical. Therefore, you will need a lab, a place where you can practice and experiment with the things that you're going to learn in the course. Not only that, but having a lab is essential for hackers or pen testers, because let's say you discovered a new attack, or you want to experiment with a new attack, or you learned something new online and you want to test it, then the perfect place for you to test this and practice hacking is a hacking or a testing lab. Now, to create a lab, you just need a number of computers with different operating systems, and you'll need a number of networks if you're testing network attacks, and if you're testing website attacks, then you will need to install websites on these computers. Or you can do all of this inside your computer, inside one machine, and install everything else as virtual machines. And this is what we're going to do. So let's say you have your computer right here. This is your main computer that you use every day to check your emails or even to watch this course. This computer might be running Windows, OS X or Linux. It doesn't really matter. It can run any operating system. You can keep all the programs that you love and like, and install a virtualization software such as VirtualBox or VMware. A virtualization software allows us to create a number of virtual computers inside your main computer. So we can have 3 or 4 or 5 or 10 computers all installed inside your main operating system, inside your main computer. The really cool thing about this is you will not need a number of computers. You can do everything inside a single computer. So what we're going to do is we're going to have a hacking machine. This is going to be the machine that we will use in order to hack into other machines. We're going to install Kali Linux on it, and we'll talk about what that is later on. And we're going to have 2 target machines. These are machines that we're going to try to hack into and practice hacking against. One of them is going to be running Windows, and the other one is going to be running an operating system called Metasploitable, and we will talk about that once we get to it. Now, it is very important to understand that you will not lose any functionality when you install an operating system as a virtual machine. You can use that machine exactly as if it's a real physical machine. So the really cool thing about using virtual machines, first of all, you're not going to lose any functionality. Second, all the machines are going to be isolated. So as we go through the course, we're going to be trying to hack into these machines, and we might actually break one of them. But that's fine. It will not affect your host machine. You will be able to easily fix this and go back to a snapshot of when the machine was working without affecting your main computer. The other cool thing is that you'll be able to have a number of different versions of each of these machines, and you'll be able to change the configuration easily, change the network settings, or switch between different states of these machines, and so on. So, by using virtualization, you will not lose any functionality, but you will gain so many cool features. And the main thing to keep in mind is your host machine, your main computer, will never be affected. It's completely isolated. And if we break any of these machines, nothing will happen to your precious computer that you use every day. And this way, you can always use your host machine for daily use, for checking emails, watching the videos, doing whatever you do normally, and then use your virtual machines for hacking and practicing the attacks. And this is what we're going to be doing in this course. So right here, I have a Windows computer that does not contain any hacking tools, so I can't really use it for hacking. But I have a virtualization software called VMware installed on it, and this software allows me to run multiple operating systems as virtual machines within this host computer. So I can use the host computer for my daily use and then use the virtual machines for whatever use I want, for testing or for hacking. So if I zoom in here on the left, you can see that I have Kali Linux installed. This is an operating system that we will use for hacking. You can see I have another Windows computer. You can see that I have Linux, all of it installed as virtual machines. And then we're going to be using these as we go through the course for hacking or for testing without affecting our main host operating system, this Windows computer. Now, don't worry about any of this. In the next lectures, I will show you in details how to install this virtualization software, VMware, on all of the major operating systems, on Windows, Linux, or Apple Mac OS. As we go through the course, I will also show you in details how to install these operating systems as virtual machines within VMware. The first operating system that we're going to install in our lab is Kali Linux. See, throughout the course, we're going to use a number of hacking tools. You can install each of these tools manually, or you can do what most hackers do, including myself, and save time and effort and use an operating system designed for hacking. We're going to use an operating system called Kali Linux. It's a Linux distro based on Debian, and the only difference between Kali and the actual original Debian Linux distro is the fact that Kali has a lot of hacking and penetration testing tools pre-installed and pre-configured in it. Therefore, once you install Kali, you will have access to so many hacking tools without the need to install or configure any of them, which will save you a lot of time and a lot of effort. Now, just like any other operating system, you can install it as a main machine or as a virtual machine. Now, I'm going to install it as a virtual machine because, like I explained in the previous lecture, we will not lose any functionality by using operating systems as virtual machines, and it comes with a lot of benefits because it's completely isolated from our computer that we always use. So if we break the virtual machine or if we want to delete it and reset it, it will not affect our main operating system. Now, the first thing that you want to do is download the virtual image of Kali Linux. So you can download it from the resources of this lecture. To access the resources of the current lecture, we're going to scroll down to the lecture. We're going to click on the resources icon, and then we're going to click on the resource that we want. Now, before going ahead with this, I want to highlight something that is very, very, very important. So please pay attention. This is a custom Kali image that I made for my courses. It is smoother and faster than the original one. It fixes a number of bugs, and it contains a number of extra programs that we need for this course and are not included in the original release. You do not have to use this custom image. You can use the original one. You can even use just a normal Linux distribution, as long as you know how to manually install all of the missing programs and apply the fixes that I did myself. And you can see a full list of them here on the left. Therefore, if you ask us a question in the Q&A section and you're not using the custom image, the first thing that we will ask you is to use the custom Kali image that we made for you, because we know the original one is broken and we will not know the changes you made in order to fix it. So, if you have a 64-bit computer, download it from one of these links. Or if you have a 32-bit computer, then download the 32-bits version from here. While waiting on the download, check out our VIP community right here and our YouTube channel. We actually post hacking content on it regularly, so you'll probably find this very, very useful. So make sure you subscribe to stay updated with the latest stuff that we post in here. Once the download is complete, you'll be ready to install Kali as a virtual machine. I will walk you through that in the next lectures, but before moving on, we need to enable virtualization to run virtual machines. You only need to do that if you're running Windows or Linux. You do not need to do this if you're running Apple Mac OS as Apple computers come with virtualization enabled by default. So skip the rest of this lecture if you're using an Apple computer. If you're using Windows or Linux, then continue with me to see how to enable it. So on Windows, before enabling it, if you want to check if it is already enabled, you're going to have to go to the Start menu. We're going to look for the Task Manager. I have it right here. I'm going to click on More Details. I'm going to go on Performance. And if you look in here, beside virtualization, you can see in my case, it's saying disabled. So we're going to have to enable it. But if it's saying enabled for you, then you can skip the rest of this lecture and move on to the next lecture. If it's saying disabled, then continue with this lecture to learn how to enable virtualization. So to do that, we're going to have to first restart the computer, and as it's booting, as it's starting, you're going to have to press a key combination, usually one of the F keys from your keyboard, to enter the BIOS settings, and from there we can enable it. So let me show you how to do it. Keep in mind you only need to do this if virtualization is disabled. If it's enabled, then you can simply skip this and continue with the rest of the course. Entering the BIOS settings varies depending on the computer that you have and depending on the motherboard. On the right here, I have a table of the most common computers along with the buttons that you need to press in order to enter the BIOS settings. So as soon as you turn on the computer or restart it, you'll need to press the button relevant to your computer in here in order to enter the BIOS settings. Once you're there, you want to make sure you enable virtualization. So let me show you how to do this on a real computer. This is a Lenovo computer. Therefore, based on the table that I just showed you, I will need to press F2 as soon as I turn on this computer in order to enter into its BIOS settings. So first, I'm going to hit the power button to turn it on, and as it's being turned on, I'm going to keep pressing F2 to enter the settings. And perfect, as you can see, I am in the BIOS settings right now. Now keep in mind, depending on your computer, the settings might look different than what I have in here. The main thing you need to keep in mind is to enable virtualization. This option can be found in a different window in any of these windows or tabs, but the main thing you want to keep in mind is to look for an option called virtualization, VTX, AMDV, or any of the options in here and enable it. So as you can see, for me, the first window that I see is just an information window. It doesn't really allow me to modify anything. Now you can use the keyboard to navigate between these windows or these tabs. So I'm going to press the right arrow to go to the configuration window. And in here, the only thing that I want to modify is Intel virtualization technology. So I'm going to use the down arrow to navigate to that. And I'm going to hit enter to change the setting, press down to set it to enabled, and hit enter again to select it. Now, if you're not sure about how to use this interface, because like I said, you might actually get a different interface, keep an eye on the instructions that you see at the bottom as they tell you exactly how to navigate and modify the settings. Now, I'm done with the configuration window. I'm going to press the right arrow again to go into the security tab. We're going to go to the exit. So again, I'm going to press the right arrow again, and I'm going to select the first option, exit saving settings. It's going to ask me, do I really want to do this? I'm going to say yes. The computer will restart with virtualization enabled. So in the next lectures, when we get to installing virtual machines, these virtual machines will run with no issues. If you've done everything properly, now if you go again to the Task Manager, go to Performance, you should see that virtualization is enabled. If you couldn't do that, please ask us in the Q&A section and we'll be happy to help you. Keep in mind that you only need to do this if you're running Windows or Linux as the host computer on your main computer. If you're running Apple, Mac OS, then you do not need to do this and you should have skipped this part. In this lecture, I'm going to show you how to install Kali Linux as a virtual machine inside Windows. Skip this lecture if you're running Apple, Mac OS or Linux, as I will cover that in the next lectures. Now I already have it downloaded in here, and as you can see, the file has a .7z extension. This is an archive that contains the actual virtual image of Kali. We did that to compress its size so that it doesn't take a long time to download. So now that we have it downloaded, we're going to need to install a program that can uncompress 7-zip archives and show us the contents. To do that, we're going to go to Chrome, and you want to go to 7-zip.org. I will include that in the resources of this lecture, and you want to download the version that is compatible with your operating system. I have a 64-bit operating system, so I'm downloading the 64-bit. One click in here will download it for us. And once the download is complete, we can simply click on it to install it, give it permissions, and click on install. Once the install is complete, we're going to click on close, and we're going to go back on our downloads directory. And right now, because we installed 7-zip, this program, we're going to be able to uncompress this archive and see the contents inside it and see the virtual image inside it. So I'm going to right click. And as you can see, I have an entry called 7-zip now. And if I hover over it and click on extract here, it will uncompress that image and reveal its contents. And perfect. As you can see now, we have a new directory, and you can see the extension now is .vmware VM. So as mentioned in the previous lecture, VMware is the software that we're going to use to run different operating systems as virtual machines. And this file right here is designed to run inside VMware as a virtual machine. So in order to run it, we're going to have to go ahead and install VMware. Now again, I'm going to include the link in the resources. I have it opened in here, and all you have to do is click on the download for Windows. Give it some time to download. Perfect. Now the download is complete. We can view it in our downloads, or we can simply just click on it here to run it. Give it permissions. And similar to installing any software on Windows, you really don't need to do much. We're simply just gonna click on next, 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 accept the agreement, next, 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 and let it install. The installation is complete. We're gonna click on finish. And now we should be able to run this virtual machine file that we downloaded, the .vmware VM file, using VMware Workstation Player. So we're going to double click it to start it, and I'm going to minimize this. We're going to click on Open Virtual Machine in here, or you can go on the Player, File, and Open. We're going to navigate to the location where we downloaded the virtual image of Kali in my downloads. And as you can see, we have it in here. Keep in mind, it's the .vmware VM file. So it ends with .vmware VM. We're going to click on it. We're going to click on open. And inside it, we have another file. The only one file that we can select. We're going to select it and click on open. And if you get no errors, as you can see in here in my case, that's it. The machine is now installed and ready to be used. Now, before running it, I'm going to click on Edit Virtual Machine Settings, or right click and Settings, just to give you an idea of what the settings look like so you feel more comfortable with VMware. Because modifying virtual machine settings is always the same regardless of what type of virtual machine it is. So, as you can see in this window, first of all, we can modify the amount of memory that the virtual machine has. And this machine is set to 2 GB of memory by default. That is enough, but you can increase it up or down using this slider. You can also modify the amount of processors that the machine has. So as you can see, this one has 2 processors assigned to it. That is plenty. It's enough, as you'll see, but you can give it more if you want to give it more. Another really important option is the network adapter. And as you can see, this is set to NAT. And this setting will basically create a virtual network where my host machine is going to be the router for this network, and then all the virtual machines are going to be clients connected to this network. So they're going to get internet connection from my host machine. And at the same time, all of my virtual machines will be connected to the same virtual network. This is very handy because my virtual machines will be able to communicate with each other, and therefore will be able to use the Kali machine to hack into the others, will be able to test network attacks, and do much more. So this setting will first allow my virtual machines to have internet connection, and it will also allow them to communicate with each other through this virtual NAT network. Now this virtual network will rely on the connection of your host computer. So it will not need any extra interfaces, it will not need any extra adapters, and as far as the virtual machines are concerned, they are connected to an Ethernet network, but in reality they are connected through the host machine. You can also modify the display settings in here if you have a bigger screen or a smaller screen. And I usually like to tick this box in here, the accelerate 3D graphics. So we're going to make sure that it is ticked. And that's pretty much it. So we're going to click on OK. And like I said, you actually don't need to modify any of these settings. I just wanted to show you what kind of settings we can set for these virtual machines. But once you're ready to run the virtual machine, we're just going to click on the green play button to start it. Now I'm going to click on inside and click enter to start Kali. And I know it's starting very small. This is because I have a high resolution screen. It's probably going to start in the normal size for you. I'm just going to zoom in for you. And perfect. We have the login screen here for Kali. So the username is ROOT and the password is TOOR, the reverse. We're going to hit enter. And perfect, as you can see now we are running this Linux operating system as a virtual machine inside my Windows operating system in here. And we're going to use this Linux operating system for hacking as we go through the course. Now before we wrap it up, I want to go into full screen. So we're going to click on the player and we're going to click on full screen. And as you can see, this will automatically go in full screen. So again, I'm still using Kali within my host operating system, which is Windows. And in most cases, Kali will look normal. But as you can see, in my case, the icons are very small and the text here on the top is very small. And that's because I have a 4K display. So we're going to need to manually modify the display settings. And to do that, we're going to right click, go to settings. Click on display in here from the left, and we're gonna set the scale to 200. I'm gonna click on apply. We're gonna keep the changes, and perfect. Now Kali looks normal for me. You don't have to do this if Kali looked normal from the start. Only if you have a high resolution screen, you might have to do this. Now I know this operating system might look a little bit confusing and scary, but don't worry about it at all. I will teach you how to use it step by step as we go through the course. If you face any issues while installing Kali, check out the featured questions first, and if you don't see your answer, feel free to ask us in the Q&A or in the forums, and we will respond to you within a maximum of 15 hours. In this lecture, I'm going to show you how to install Kali Linux as a virtual machine on Apple Mac OS. Skip this lecture if you already have Kali and VMware installed, or if you want to install it on Linux. I will cover installing it on Linux in the next lecture. Anyway, I already have this downloaded in my downloads, and as you can see in here, we have the virtual image, but it is inside an archive. So you can see the file type is 7Z and it's an archive, and we did this to compress the actual virtual image so that it takes less time to download. So in order to use this virtual image, we have to uncompress this archive. And to do that on Apple Mac OS, it's very easy. All we have to do is simply double click this file. Give it its time. This might take some time. Once done, you're gonna get a directory, as you can see in here, .vmware VM. Using the right software, we can use it to run Kali Linux inside our current operating system. To do this, we're gonna need to use a virtualization software. As mentioned, virtualization software allow us to run a number of operating systems as virtual machines within our current operating system. And the virtualization software that we're going to use to run this virtual image is called VMware. So I have its download page open here already. I'm going to include it in the resources of this lecture. And don't worry about the buy now button. It's actually free for educational and non-commercial use. So we're simply going to click on download now. We're going to scroll down and we're going to download the Fusion player. This is the free one. So we're going to click on register for a personal license. I'm going to click on create a new account. I'm going to put my first name and last name, put my email, and we're going to say no, we're not a partner, and we're going to continue. It's going to ask us for more information. So you want to verify your email, put a password, fill company details if you have any. If you don't, you can fill blank stuff. We're going to agree to the terms. We're going to fill the CAPTCHA and register. Perfect. Now it's telling me that a verification email has been sent to my email. So I'm already logged in here to my email. We're just going to refresh it. We have a message there from them. And we can click on this link to activate my account. I'm going to input my password that I just said. We're going to continue to the customer connect. And perfect. We have my license in here that I can use to use the program for free. And we can also download the program from here. So I'm going to click on download and give it its time to download. And perfect. Now the download is complete. So we can go back to our downloads directory and we can see VMware Fusion downloaded in here. So to install it, we're simply going to double click it, just like installing any other application. We're going to double click the installer. We're going to say yes, we want to open it, put the password. We're going to allow it to access my system events. And perfect, now it is installed and we're getting a wizard that will help us install a virtual machine for the first time. So I'm going to click on cancel to get rid of this and close this installer. We're done with everything. And if you notice here on the top right, you'll see that we have a little icon to indicate that VMware is working on this machine. So what I'm actually going to do is, if I go in here, we'll see it running. I'm going to right click and quit, because I want to show you how to actually use it from zero, from scratch. So let's assume this is a new machine and you want to use it. We're going to go to Launchpad. We have VMware in here. We're going to click on it, start it. Now you'll notice we got the same window, but when that happens, you'll see that this virtual machine file now has the icon of VMware Fusion. So now we can simply double click this file, the .vmware VM file, and you'll see that it'll automatically run inside VMware. Now we're going to say OK for this warning message. We're going to say that we copied it. And perfect, now we are ready to use this virtual machine. And as you can see, it's actually automatically starting Kali Linux for me. Now it's asking us to log in. The default username is root, R-O-O-T, and the default password is toor, T-O-O-R. I'm gonna hit enter. And perfect, right now I am running Kali Linux as a virtual machine inside my main operating system, which is this Mac OS computer. Now to view this in full screen, you're simply going to have to click on the green button for the full screen, and it'll automatically resize, as you can see, and you'll be able to use this virtual machine, like I said, inside your main operating system. I know this might look a little bit scary, but don't worry about it. I'm gonna walk you through it step by step throughout the course, and you will learn how to use it, and you'll see how easy it is to use it for hacking. For now, if you wanted to exit the full screen, you can simply just go to the top and keep the mouse there, and then click on the green button again to exit the full screen. And to turn off Kali, you can simply click here, go to power off and power off. Click on power off one more time and the machine will shut down. Now in here on the top right, you can see we have the VMware icon like I said, and if you click on it, the first time you click on it, you'll actually be asked to give it permissions. We're going to say that's okay. And let's click on it again. And as you can see, you're going to have a list of all of the virtual machines that you installed in here. But right now we only have one, which is the Kali machine. You can also click on the virtual machine library to see a list of all of the virtual machines in here laid out nicely. And if you want to edit the settings of any of these machines, we're going to click on it one click, and we're going to right click it and go to settings in here. Now, as I mentioned, this machine is already configured to run well, so you don't really need to modify any of this, but I'm just showing you how to modify the settings, because modifying the settings for virtual machines is always the same. So it's good to know. The main settings that you want to know is the processor and memory. Here you can adjust the amount of memory that you're given to the virtual machine by moving the slider, and you can adjust the amount of processors given to the virtual machine again in here. But that's both set to 2 processors and 2 GB of memory. It's enough to run Kali smoothly. If you go back to everything else, we have the network settings in here for this specific virtual machine. And as you can see, this is set to use a NAT network. This setting will basically create a virtual network where my host machine is going to be the router for this network, and then all the virtual machines are going to be clients connected to this network. So they're going to get internet connection from my host machine. And at the same time, all of my virtual machines will be connected to the same virtual network. This is very handy because my virtual machines will be able to communicate with each other, and therefore will be able to use the Kali machine to hack into the others, will be able to test network attacks, and do much more. So this setting will first allow my virtual machines to have internet connection, and it will also allow them to communicate with each other through this virtual NAT network. Now this virtual network will rely on the connection of your host computer. So it will not need any extra interfaces, it will not need any extra adapters, and as far as the virtual machines are concerned, they are connected to an Ethernet network, but in reality they are connected through the host machine. Again, you can click on Show All to see the rest of the settings. But like I said, you don't really need to modify anything. Everything should be configured properly for this to run with no issues at all. If you face any issues, then check out the featured questions, and if you don't find your answer, feel free to ask us and we will respond to you within a maximum of 15 hours. And like I said, don't worry about using Kali. I will cover that in details in the next lectures. In this lecture, I'm going to show you how to install Kali Linux as a virtual machine inside Linux. Skip this lecture if you have it already installed and revise the previous lectures to see how to install it on Windows or Apple Mac OS. Now I already have it downloaded in here in my downloads, and as you can see, this is an archive with a 7Z extension. The actual virtual image is compressed inside this archive. We did this to reduce its size so you can download it quicker, but in order to use this virtual image, we're going to have to uncompress the archive. To do that, you simply have to right-click it and click on Extract here. You're going to need to give it some time to fully uncompress the archive and reveal its content. Perfect. Once this is done, you're going to see a new directory in here that contains the actual image, and you'll notice that this folder ends with .vmware.vm. So in order to run this virtual image of Kali Linux, we need to install a virtualization software. And the software that we're going to use is called VMware. I'm going to include its download link in the resources of this lecture. And all you're going to have to do is simply scroll down and click on the Linux version in here. We're going to save it. Once the download is complete, we're going to be able to see it here in our downloads. This is the installer for VMware, the software that we're going to use to run virtual machines inside our current operating system. And to install it, we're first going to need to open our terminal and navigate to the location where we have this installer downloaded, which is in my downloads. So I'm going to use the cd command to change my working directory to downloads. And if I do ls to list all of the files, you'll see we have the file in here. And before running this file, we need to change its permissions to an executable. So to do that, we're going to do chmod plus x followed by the file name. I'm going to hit enter. And now if I do ls, you'll notice that the file name is listed in green, meaning that this is an executable. Now, before running this executable, we're going to have to install the Build Essentials package because it is required by this installer to install VMware for us. Now, I'm doing all of these steps on Ubuntu, but installing VMware should be pretty much the same on most Linux and especially Debian-based distributions. So, in order to install the Build Essentials, I'm first going to have to update the list of sources that I can download packages from. And to do that, we're going to do sudo apt-get update. I'm going to input my password. Once the sources are updated, we're ready to install the Build Essentials. So we're going to do sudo apt-get install build essential. We're going to hit enter. I've already installed this, that's why it's automatically installing it for me. But in your case, it's going to ask you to confirm. And all you'll have to do is simply hit enter to confirm that you want to install it. If you don't see any errors at all, it means everything got installed properly. So I'm going to clear the screen and I'm going to do ls one more time just to show you what we want to run. We want to run this executable, which is the same file as this one. And to run executables in Linux, you simply have to do // followed by the executable name. Now also we need to run this as admin, therefore I'm going to type sudo before the command. I'm going to hit enter and we're going to give it some time to extract the installer. And once it's done, we're going to go to all of our software and we're going to run VMware Player. We're going to accept the agreement and click next, accept the license, next. We're going to say we don't want to share data and we click on finish. We're going to put the password and perfect, here we go. During the installation, you might also get an option to either use the free or the paid version. Make sure you select the free one because we're using it for non-commercial use. So right now we're ready to create or open ready virtual machines using VMware. So I'm going to close my terminal window and the virtual machine that we actually want to run is the customized version of Kali that we just downloaded at the start of the video. So to do that, we're simply going to click on open a virtual machine or go to file and open virtual machine. We're going to navigate to the location where we downloaded this virtual machine. And as you can see, it's in the downloads. So we're going to go to downloads. We're going to double click it in here and select the only file that we can select, which is the .vmx file. We're going to double click it. And here we go. We have it imported in here in VMware and we can easily start it now by clicking on power on in here. Now, before doing that, I just want to show you how to modify the virtual machine settings. You do not need to do this. I'm simply showing you how to do that so you get an idea on how to modify the settings, because modifying virtual machine settings is always the same regardless of what type of virtual machine it is. So we're going to click on Edit Virtual Machine Settings in here to modify the settings. And as you can see, the first thing that you can modify is the amount of memory that the virtual machine has. And you can increase it or decrease it by moving the slider. It's set to 2 GB by default, and that is good. So I'm going to keep it at that. Next, you can modify the number of processors that the machine has. Again, it's set to 2 by default. I'm going to keep it at that because that's pretty good. You can also modify the network settings, and as you can see right now it's set to use a NAT network. We're also going to keep this as NAT. This is great because this setting will basically create a virtual network where my host machine is going to be the router for this network, and then all the virtual machines are going to be clients connected to this network. So they're going to get internet connection from my host machine. And at the same time, all of my virtual machines will be connected to the same virtual network. This is very handy because my virtual machines will be able to communicate with each other, and therefore will be able to use the Kali machine to hack into the others, will be able to test network attacks, and do much more. So this setting will first allow my virtual machines to have internet connection, and it will also allow them to communicate with each other through this virtual NAT network. Now this virtual network will rely on the connection of your host computer. So it will not need any extra interfaces, it will not need any extra adapters, and as far as the virtual machines are concerned, they are connected to an Ethernet network, but in reality they are connected through the host machine. Finally, you can also modify the display settings in here, and I usually like to tick this option to accelerate 3D graphics. If you get issues with it, you can untick it, but usually it gives you nicer and smoother animations with virtual machines. So we're gonna save the settings, and we can go ahead and start this virtual machine by selecting it and clicking on Power On in here. We're gonna say I copied it, and we're just going to give it some time to load. Now this custom image of Kali already comes with VMware Tools, which is a set of plugins that improve the experience of using virtual machines. If you get a pop-up like this, you can click on Download and Install to install the latest one, or you can simply click on Remind Me Later to install it later. And as you can see, if everything goes as expected, you should get the default login screen for Kali. So I'm going to click in here and I'm going to put the username as root, R-O-O-T, hit enter, and the password is the reverse of that, so it's T-O-O-R. We're going to hit enter and give it some time. And great, as you can see, now we have another operating system, Kali Linux, installed as a virtual machine inside our own main host operating system. Now we can put this in full screen by going to Virtual Machine in here and clicking on Enter Full Screen. The screen should automatically resize, as you can see in here, and in most cases the icons should look normal, but in my case they look small because I have a 4K display. So we're gonna need to manually modify the display settings, and to do that we're gonna right click, go to Settings, click on Display in here from the left, and we're gonna set the scale to 200. I'm gonna click on Apply. We're gonna keep the changes, and perfect. Now Kali looks normal for me. You don't have to do this if Kali looked normal from the start. Only if you have a high resolution screen, you might have to do this. Now I know this operating system might look a little bit confusing and scary, but don't worry about it at all. I will teach you how to use it step by step as we go through the course. If you face any issues while installing Kali, check out the featured questions first, and if you don't see your answer, feel free to ask us in the Q&A or in the forums, and we will respond to you within a maximum of 15 hours. Okay, now that we had a quick overview of Kali Linux, I want to spend some time talking about the Linux terminal. So you can access the terminal through this application right here. So if we click on that, it will open the terminal window for us. And as you can see, all it is a black screen where you can type commands. Now, the Linux terminal is actually very, very powerful because it can be used to do anything that you can think of, really. A lot of the applications in Linux that have a graphical interface were command prompt programs first, and then people made a graphical interface for it. So a lot of the time, maybe the graphical interface will be buggy or crash, and the terminal program will still work. Also, a lot of the penetration testing tools do not even have a graphical interface. A lot of them can only be used throughout the terminal. Not only that, but in many scenarios, you might only have an SSH or a command prompt access to a machine. So you need to know how to use this command prompt in order to achieve your goals. So throughout the course, we're going to be using the terminal a lot, and that's why I want to spend some time just showing you the basics of it and making sure that you're going to be comfortable using it. Now, the basic idea is you type a command and the result will be displayed for you on screen. So let's have a look on a very, very simple command, which is pwd. Now, this command prints the current working directory, hence the name pwd. So if I hit enter, you can see it's printing /root, which means right now I am in the root directory. So basically I am in here. This is the root, it's home. So if I do ls, which is a command to list all the directories and files in the current working directory, we should get all of these directories that we see in here. So if I hit enter, as you can see, I can see all these directories in the current working directory. Now, another very useful command is the cd command. This command allows us to navigate into another directory. So for example, let's say I want to navigate into the downloads. All we have to do is type cd, followed by the name of the directory that I want to navigate to. So I'm going to type downloads. Now if I hit enter, I should be inside the downloads now. So if I do pwd to see my current working directory, you'll see that it's saying I'm in root /downloads. So if I do ls here, it should show me all the directories and files inside downloads. So if I do enter, as you can see, I have a directory and a file in here. And these are the exact same files that you'll see if you double click the downloads here. Now, if you want to go back one directory, so similar to pressing the back button in here, all you have to do is do cd, again the command to change the working directory, followed by ... And now if I do pwd, you'll see I'm back in root. And if I do ls, you'll see all the directories and files in root. So that's all good. And there's actually a huge number of commands that you can use. So I'm going to include a link in the resources of this lecture of all the Linux commands that you can use. You don't need to know them by heart. We're actually going to be using a lot of them throughout the course. So you're going to naturally learn them as you go through the course. Now, if you are using a command and you're not sure about how this command works, you can just use the man command to display the manual of this command. For example, we've used the ls command here to list the files and directories in the current working directory. But if I do man followed by ls, this basically means I'm requesting the manual of ls. So I'm asking, how can I use the ls command? So if I hit enter, you'll see I'll get a screen similar to a text file. And basically, it's giving me a lot of information on how to use the ls command. So you can see that it's telling us that this command will list the directory contents. You can see the way it works by typing ls, followed by the options, followed by a file if you want to run it on a file. You can see a longer description of the command. And then you can see all the options and the arguments that we can use with this command. Now, in Linux, most of the time, the options will always follow the same syntax. So you either use -letter or -- a word, to specify the argument. For example, in here, the -a and --all will ignore entries starting with dot. So if you keep going down in here, you'll see all the options and arguments you can use with the ls command. And we have another example here. We have the -l, which means it's going to use a long listing format, which will display more information about the files in the current working directory. So let's have a look on that. I'm going to press Q to exit this, and then we're going to do ls as usual. And since we read the manual, we know we can do -l to see more information about the files. And if I hit enter now, you can see I'm still getting the same directories, but it's also showing me the permissions, the users, the date created, and so on. So you can use the man command on any command you want, not only on the ls. So you can use it on the pwd, you can use it on the cd, or any other command, and it'll show you full description or the manual page of how to use this command. Now, I'm going to clear the screen by typing clear. And the next thing that I want to show you is the --help. So this is something that you can use again in almost all commands and all programs in Linux. So you can just type the program name or the command name followed by --help. As you might think, this will show you a help message telling you what this command is or what this program is, the arguments that it takes, how to use these arguments, and examples at the bottom. Now, another useful thing with the terminal, so I'm going to clear this again, is the arrows. So you can press up to go up to see all the commands that we executed before, and again you can go down to navigate between the commands that you executed previously. You can also use the tab for autocomplete. So again, let's do ls, and you can see all the files, and let's say we want to go into documents. So we can do cd followed by documents. You can type documents, or if you're lazy like me, you can just do doc and press tab, and as you can see, it's automatically completing the rest of the word for me. So this is something that comes very, very handy when you're using the terminal for a long time. Now, what I also want to show you is how to install programs in Kali from the terminal. So first I'm going to clear this. And the first thing that you want to do is update the sources where Kali can search and download programs from. So we're going to do apt-get update. Now, apt-get is the name of the application that allows us to download and install programs. And we're saying update because I'm saying that I want you to update the list of all the programs that I can install. So I'm going to hit enter. And you want to make sure that you have internet connection when running this. And as you can see, it's telling me that it's done. And now we can go ahead and start installing applications. So the first program that I want to install is actually a terminal program, so similar to this one, but it allows us to have multiple terminal windows open in the same window. So in order to install a program through the command line, we're going to do apt-get, which is again the name of the program that allows us to install programs on the system. We're going to say that I want to install, and the program that I want to install is called Terminator. So very, very simple. First of all, we're typing the name of the command, which is apt-get. We're saying that I want to install, and the program name that I want to install is called Terminator. So I'm going to hit enter. And this is going to download and install Terminator for me. So you can use the same command to install any program that you want. You just need to replace Terminator with the name of the program that you want to install. Now, I've already downloaded and installed this before, so it didn't ask me to confirm. But if you're running this for the first time, it might ask you to confirm whether or not you actually want to install this program. So all you'd have to do is press Y from the keyboard and hit enter. Now, as you can see, it's done. So if I go to my all applications in here and just type Terminator, you can see that I have it here. So I'm actually going to drag it and put it in my dock so I can access it easily in the future. So now I can just click it in here and that will open Terminator for me. Now this is another application that allows me to run commands. So it's exactly the same as this. So again, I can do ls and pwd. The only difference is with this one, I can actually right click and click on split horizontally, for example. And this will split the same screen into two screens where I can run commands at the same time. So I can have some commands in here and I can run commands in here. And then I can even split this more if I want, again, vertically or horizontally. And as you can see, I can have as many terminal windows as I want. And this will be very helpful in the future when we'll be running a number of programs and a number of commands at the same time. Now, before I let you go, I just want to show you two websites that I'm going to include in the resources of this lecture. First of all, we have a website here that includes the most common Linux commands, if not all. So you can go through them and familiarize yourself with them. But keep in mind, you don't need to know them all by heart. Like I said, as you go through my course and as you continue on with your journey, you will learn the commands that you need as you go. Another really useful resource that I'm going to include is explainshell.com. This website is designed to explain Linux commands to you. So all you have to do is type the commands in here. So for example, if you just type ls and hit explain, it'll explain that ls will list directory content. You could make it more complex and do ls-la, and if we hit enter now, it'll break all the arguments and explain every single argument. So again, ls lists contents. If we highlight the L, as you can see, it's telling us that it's going to use a long listing format as we seen earlier. And the A at the end is the same as -A, which is all, which means that we do not want to ignore entries starting with a dot. So we do not want to ignore hidden files. So you can do any command in here. You can do apt-get install, for example, and it'll actually explain it to you. So it'll explain apt is a package manager, install can be used to install packages, and so on. So if you ever see a Linux command that you don't understand, you can always just come in here, put the command, and it'll break it down to you and explain it really nicely. Okay, now that we have Kali Linux installed, I want to give you a basic overview of this operating system in this lecture so that you're comfortable with it, and we're going to be using it throughout the whole course, so everything is going to become easier for you as we go through the course. Now the first thing that I want to talk about is the status bar in here. So you can see we have an applications menu in here, and inside it you can see all the applications are categorized. So we have information gathering applications, vulnerability analysis, web application analysis, reverse engineering, and so on. So you can go on each one of these entries and just select any program that you want to run. And the next menu that we have is the places, which shows you the most common places in the file system. So we have home, we have the desktop, we have the documents, downloads, and so on. So you can access the places from here and then you click on home, or you can just click on the files icon in here on the left, and both of these will bring you to the home directory, which is actually the root directory. So it says home in here, but the actual location of this, if I do Control L, you'll see it is /root. So inside this, you can see we have our downloads, music, pictures, similar to the way that you'd have it in Windows and OS X. We also have the time in here, and in here on the right, we have more controls. So the first thing that we have in here is the workspaces. So Linux comes with multiple workspaces by default. Basically, what this allows us to do is we can have this desktop in here. For example, we can open the places, and we can, for example, navigate to downloads and do some work in here. But if we go here to workplaces and go to the second one, you can see that I have an empty desktop that I can do whatever I want. And for example, I can launch Firefox in here. And then again, if I want to go back to the first workspace, all I have to do is click on here, click on number 1, and I'm back in here. And because I've already used up 2 spaces, the system is already creating a third empty space, so I can click on that, and as you can see, I'm in the third space where I can do more stuff. Now you can also navigate between the spaces by pressing Ctrl-Alt up or down to go up and down in the spaces. The next part of the status bar is this last part in here. And if you click on it, basically the first thing it'll allow you to do is control the sound. Next, you'll see your connections. So as you can see right now, and as I showed you before, this is showing up as if we're connected to a wired network because I configured this network to use a NAT network. If you have a wireless adapter connected to this computer, you should be able to see it here. If you don't see it, then follow the link in the resources of this lecture to see how to properly connect your wireless adapter or any USB device to a virtual machine. Now I should note, you can only use external USB adapters in order to access Wi-Fi networks from Kali. You cannot use the built-in Wi-Fi card. But Kali should have internet connection anyway because it is configured to use a NAT network, and as you can see in here, it's telling me my wired is connected. So if I actually go down to Firefox, I'll close this. And if I just go to google.com, you can see it is connected to the internet. So let's go back to where we were. And if we click here, we also have the battery settings, the user settings. You have this button to turn off the machine. This is to lock the machine, and this will show the preferences where you can modify the preferences of the machine. So you have Bluetooth, Wi-Fi, change the background, change the languages, and so on. So you can spend some time getting familiar with this. It's very easy and very intuitive. Same goes to the file manager in here, very intuitive, double click to go in. You can right click and archive and extract here to uncompress it. You can navigate throughout these files by clicking them, and then you have the trash here, which contains the deleted files. Now we also have the dock in here, which contains the favorite applications, and you can also access all the other applications by clicking on this icon right here, the show applications, and this will show you a menu with the most frequent applications, and then if you click on all, it will show you all the available applications. The first penetration testing section in this course is going to be the network hacking section. The reason why I chose to start with this, because everything, if you think of it, is connected to a network. So whether your target is a personal computer, whether it's a server, whether it's a company, or even if it's just a website, all of these systems are actually connected to a network. Literally, when you just connect to the internet, you're connecting to a network because the internet is just a really, really big network. So it is very important that you understand how networks work and how devices communicate with each other before we actually move into the next sections. So this section is actually going to be divided into 3 subsections. In the first subsection, we're going to talk about all of the attacks that you can do before connecting to a network. So you literally just have a computer with a network interface, possibly a Wi-Fi adapter, and we're going to see what can you do now before even connecting to anything. In the second subsection, I'm going to show you how to crack Wi-Fi keys and gain access to Wi-Fi networks, whether they use WEP, WPA, or WPA2. Once you have the access, you can move to the third section, which will apply for both Wi-Fi and wired networks. All of the attacks that you will learn in the third subsection apply whenever you are able to connect to the network, once you're able to gain access to the network. And here is where the real fun starts, because you're going to learn a number of powerful attacks that will allow you to intercept the connections in the network and capture everything sent in it, including usernames, passwords, URLs, chat messages, and so on. Not only that, but you'll also be able to modify data as it's being sent in the air. So you'll be able to control requests, serve people fake updates, inject evil code into the pages that they load, and so many other cool things. So everything in the third section will apply for both Wi-Fi and wired networks. Now, before we start talking about network hacking, you need to have a basic understanding on how networks work. Now, we all know that a network usually contains a number of clients connected to each other, and clients usually connect to a network in order to share data or share a resource. A really good example of a resource that we all have connected to networks in order to access is the internet. So we connect to Wi-Fi networks and even wired networks all the time just to access the internet. Now, all networks, whether it's Wi-Fi or wired, work on the same principle. They have a device that is considered a server. Now, in many cases, for example, in your home network, this server is your router. This is also referred to as an access point. Now, this router or server or access point is the only device that has access to the resource. So none of these clients have direct access to the resource even after connecting to the network. The only way they can access the resource is through the access point. So let's say, for example, you're client number 1 and you connected to your home network over Wi-Fi or over Ethernet over a cable, and then you opened your browser and you typed google.com. What happens is your computer will send a request to the access point asking for google.com. The access point has access to the resource, which is the internet in this example, so it's going to go and look for google.com. It will receive google.com and it will forward that response to your computer, and as a result, you will see the website loading on your browser. So if you actually go to your router at home and look at it, you'll see at the back it's connected through a cable to the wall, and this is how it's getting its internet access. Therefore, it is the only device in your network that has direct access to the resource, and none of your computers, none of the computers connected to the network can access the resource or can access the internet without the router, without the access point. So the only way for all of the connected clients to access the resource is to go through the router. Now the data is transferred between the clients and the access point as packets. So you can think of all of these arrows as a series of packets being transmitted between the client and the router as requests and responses. Now in Wi-Fi networks, these packets are transmitted in the air. Therefore, if you have a wireless card and you're within range, you'll be able to capture all of these requests and responses. So basically, you'll be able to see anything that any computer connected to the same network as you does on the internet. Because they will have to send all of this data to the access point, and because they're sending this data in the air because you're in a Wi-Fi network, you'll basically be able to capture these requests and responses, and you'll be able to see the URLs they visit, the usernames, the passwords they enter, the chat messages, anything they do on the internet will be sent as packets, and therefore you'll be able to capture it and analyze it. We'll talk more about that and more about how networks work as we go through the course, but this is enough to get you going through the next few lectures so that you can sniff data, analyze it, and start launching some cool pre-connection attacks. In this lecture, I'm going to show you how to connect a USB device to a virtual machine. As an example, I'll be connecting a wireless adapter to the virtual Kali machine, but this method can be used to connect any type of USB adapter. As mentioned in the course requirements, you need a wireless adapter for the cracking sections of the course. These two sections account for less than 8% of the course. So, if you don't have a wireless adapter and can't afford to buy one, then that's completely fine. You could simply skip these two sections, continue from the network hacking post-exploitation section, and you'll be able to do everything else in the course without a wireless adapter. Now, what we mean by a wireless adapter is simply a USB device that you connect to your computer, and it allows your computer to communicate with Wi-Fi networks. Now, most modern computers come with built-in wireless cards. The only problem is these built-in wireless cards are not good for hacking. The Wi-Fi or wireless adapter that we need needs to support monitor mode, packet injection, and AP mode. I will include a video in the resources to help you pick a good wireless adapter. And don't worry about what we mean by these modes. We will talk about this as we go through the course, but basically you need to get a wireless adapter that supports all of these three modes, and it should be supported by Kali Linux. The main thing you want to keep in mind is the brand does not matter. What you need to look for is any adapter that uses any of these two chipsets. The chipset is the brains of the wireless adapter. It's what does most of the work, and therefore if you get any adapter, regardless of what brand it is, if it uses any of these two chipsets, it should support all of these modes, and it should work with everything that I'm going to do and you'll learn in this course. So anyway, check out the video in the resources for more information on how to pick a good wireless adapter. I'm also going to include a link in the resources for our own shop where we sell supported wireless adapters, but you do not have to buy it from us. You can buy it from anywhere as long as you get an adapter that uses one of the recommended chipsets. The wireless adapter that I'm going to be connecting to this computer is actually going to be this one that uses the Realtek 8812AU chipset. You can follow the same instructions for whatever wireless adapter as long as it's supported by Kali. So what we need to do is simply run VMware. We're going to click on the Kali machine. We're going to right click it and go to its settings. We're going to click on add in here to add a USB controller. We're going to select that we want to add a USB controller in here. We're going to click on finish. And in the settings for the USB compatibility, I'm going to set this to 3.1. I'm going to click on show all USB input devices, and we're going to click on OK, and we're done. Now, before starting Kali, make sure that you disconnect the wireless adapter. So if you already have it connected to your computer, physically disconnect it from the USB port from the computer. Make sure you do that before starting Kali. So I'm going to go ahead and start it. I'm going to log in. Once logged in, let's go and open up our terminal. And I'm going to run ifconfig. This command is used to list all of the network interfaces connected to this computer. And if I hit enter, you'll see right now I have two interfaces. One of them is called ETH0. This is a virtual Ethernet interface that is actually created by VMware in order to connect this machine through the virtual NAT network. You'll also have LO, which is the virtual loopback interface used in Linux. So both of these are virtual interfaces. None of them is our wireless adapter. But that is normal because I haven't connected my wireless adapter yet. So I'm going to go ahead and connect it to my computer. And as you can see, as soon as I do that, we're going to get a pop-up. The pop-up is asking us, what do we want to do with this? Do we want to connect it to the host? So the host is the main computer, the Windows computer, or do we want to connect it to the virtual machine? Now we obviously want to connect it to the virtual machine, so I'm selecting this option. This is the virtual machine that we're connecting it to, which is my Kali machine. That is perfect. And we're gonna tick this box so that it always connects it to this machine in the future. It won't show me this pop-up message. Once we do that, we're going to see another pop-up that simply tells us that we can always connect and disconnect USB devices using the USB icon in here on the top right. So that's fine. I'm going to say thank you. Don't show me this either. We're going to click on OK. And now, if we run the exact same command, ifconfig again, you'll notice that I have another interface. So we still have ETH0, which is, like I said, the virtual interface that is used to connect to the virtual NAT network. We also still have LO, the loopback interface, and we have a new interface right now called LAN 0, which is my wireless adapter that I just connected to Kali. So now we can go ahead and use this adapter to discover wireless networks around us and hack them. And we will talk about that in details in the next lectures. And as mentioned, you only need this for 10% of the course, only for the cracking section. Also, now if we look here on the top right, you'll notice that we have an option for Wi-Fi. And if we click on it, we can select a network and connect to a Wi-Fi network. Now, I don't want to do that, and you should not do that because we don't need to do this. We don't need the wireless adapter to connect to Wi-Fi networks. We already have internet access in here through the virtual NAT network through ETH0. We're only using the wireless adapter to actually discover wireless networks and hack them, not to connect to them. When it comes to networking, you probably heard of the term MAC address a lot. So in this lecture, I'm going to cover what do we mean by MAC address, what it's used for, and how to change it. MAC address stands for Media Access Control. It's a permanent physical and unique address assigned to network interfaces by the device manufacturer. So whether you have a wireless card or a wired or Ethernet card, each one of these network cards come with a specific address that is unique to this card. So there is no two devices in the world that would have the same MAC address, and this address will always be the same to this specific device. Even if you unplug it from your computer, connect it to another computer, then this network device will always have the same address. So you might already know that the IP address is used in the internet to identify computers and communicate between devices on the internet. The MAC address is used within the network to identify devices and transfer data between devices. So each piece of data or packet that is sent within the network contains a source MAC and a destination MAC. Therefore, this packet would flow from the source MAC to the destination MAC. So, because this is a physical unique address to each interface, to each network device, and because it is used to identify devices, then changing it will make you anonymous on the network. Not only that, but the MAC address is often used by filters to prevent or allow devices to connect to networks and do specific tasks on the network. So being able to change your MAC address to another device's MAC address will allow you to impersonate this device and allow you to do things that you might not be able to do. So you'd be able to bypass filters or connect to networks that only specific devices with specific MAC addresses can connect to, and you will also be able to hide your identity. Now, changing the MAC address is very simple. So let me show you how to do that. First of all, I'm going to use the ifconfig command to list all the network interfaces available on my Kali machine. What I mean by network interface is any device that allows us to connect to a network. So an example is a Wi-Fi card or an Ethernet card and so on. So you can see, first of all, we have ETH0, and this is a virtual interface created by VirtualBox when we set Kali to use a NAT network. So you can see the interface name is ETH0. You can see it has an IP address because, like I said, it's connected to a network. So if we go here, we can see it's saying wired connected. So this is the interface that represents the wired network that Kali is connected to, which is actually a virtual NAT network. You can also see the net mask, the broadcast, and a really important piece of information, which is the other. This is the MAC address of this virtual interface. Now you can see similar information for my other two interfaces, the LO and the LAN 0. The only thing is, you can see for both of these interfaces, we do not have an IP address. And the main reason for that is because none of these interfaces is connected to a network. Now LO is a default interface created by Linux, and LAN 0 is my real wireless adapter, so I can use it to connect to Wi-Fi networks. But if I go on the network in here, you'll see Wi-Fi is not connected because I actually didn't connect to any network, and that's why it does not have an IP address. Now this doesn't matter because what we want to do is to just change the MAC address, which again is shown here under the other part. So similar to what you're seeing here for ETH0. Now, in order to change any of the values that you see in here, you have to first disable the interface. So, in this example, we want to change the MAC address. So that is represented by the other, and the value is right here. So, in order to disable an interface, we're gonna do ifconfig, followed by the interface name, which is LAN 0 in my example, followed by down to disable it. Now, if I hit enter, you'll see the command runs with no errors, so it means that it got executed properly. And the next thing that we need to do is to change the option that we want to change. And in this example, we want to change the other, which is the MAC address. So, first we're gonna type ifconfig. We're gonna type the interface that we want to change one of its options. Then we're gonna type the option that we want to change. And what we want to change is the hardware address. So we're gonna do HW ether. Then we're gonna give it the address that we want to change the MAC address to. So for example, I'm gonna use 001122334455. Very simple command. We're doing ifconfig LAN 0 to select the interface that we want to change its option. We want to set the hardware address, and we want to set this address to this specific address. So you can use any address that you want following the same format shown here. Just make sure your address starts with 00. So I'm gonna hit enter, and again we don't see any error messages, so it means the command got executed properly. And finally, we just need to enable the interface because we disabled it by doing ifconfig LAN 0 down, so we just need to do ifconfig LAN 0 up to enable it. Now the interface is enabled, and if we do ifconfig again and look at the other part in here, you can see that it is changed to the MAC address that we specified. Now this is done and your MAC address is changed. Now you can go ahead and start using the interface, and it will appear to have this MAC address instead of its original MAC address. And like I said, this can be useful in so many scenarios. Now keep in mind, the MAC address will revert back to the original one once you restart the computer, because we're only changing the MAC address in memory. We're not really changing the physical MAC address. But if your MAC address is resetting to the original one without restarting, then something is going wrong, and it's probably happening because your network manager is resetting the MAC address. Not everybody will face this issue, so I'm not going to cover it in this lecture. But if you face this issue, if your MAC address goes back to the original one without restarting the computer, then check out the YouTube video in the resources of this lecture. It will show you how to fix this issue. From the previous lectures, we learned the basics of how networks work. We learned that devices on the same network communicate with each other using packets. So regardless of what you do on the network, whether you're watching a video, whether you're logging into a website, sending chat messages, sending emails, regardless of what you're doing, all the data is sent as packets. Now in the network, devices ensure that these packets go in the right direction using the MAC address. So each packet has a source MAC and a destination MAC, and it flows from the source to the destination. So in this example, we have the client, it has this MAC, we have the access point, which has this MAC, and as an example, if this client wanted to send a packet to the router, it will set the destination MAC to the router's MAC address. Therefore, by default, each device only receives data that has the destination MAC as its own MAC address. But if you remember, I said in wireless networks, if you're within range, then you'll be able to capture all of this communication because these packets are literally sent in the air. So we can just capture them even if they do not have our MAC address as the destination MAC. To do this, we need to change the mode of operation of our wireless interface so that it operates in monitor mode. So let me show you what I mean. If I go to my computer here and run iwconfig this time, so we see an ifconfig which lists all the interfaces, we can use iwconfig to see the wireless interfaces only. And you can see we have LAN 0 right here, which is my external wireless adapter. And you can see the mode of this adapter is set to managed. What this means is basically this is the default mode of all wireless devices. And what it means is this device will only capture packets that has the destination MAC as the MAC address of this device. So basically, it will only capture devices that are directed to my Kali machine. But this is not what we want. What we want is to be able to capture all the packets that are within our range, even if they are sent to the router and even if they are set to another device. So to do this, we need to set the mode to monitor mode instead of managed mode. So, as usual, before you can change the options of your interface, you have to disable it. And previously, we've seen we can do that by doing ifconfig, the device name, which is LAN 0 in my case, down. Then we can enable monitor mode. But before we do that, I'm actually going to run a command to kill any process that could interfere with using my interface in monitor mode. So the command that I'm going to run right now is not mandatory, but running it will actually give you better results when you come to running the attacks that you will learn as we go in the course. So this command is going to be airmon-ng check kill. Now you'll notice when you run this command, it will actually kill the network manager that usually runs in here. So you'll completely lose your internet connection. But this is no problem because we will only need to be in monitor mode when we are running pre-connection attacks. So attacks that do not require us to connect to any network. So we actually do not need internet connection to run any of the attacks that require monitor mode. Now we're going to enable monitor mode. So we're going to do iwconfig, followed by the interface name that we want to enable monitor mode on, which is LAN 0. We're going to say that I want to change the mode, and I want to change that to monitor. So very, very simple command. we're using iwconfig to change the mode. We're given the name of the interface that we want to change its mode. We're saying I want to change the mode and I want to set it to monitor mode. Now if I hit enter, you'll see the command will run with no errors, which means the command got executed properly. And finally, we'll need to enable the interface, again similar to what we did when we changed the MAC address. So we just have to do ifconfig LAN0 up. That's done. Now if I run iwconfig again, you will see that the mode is set to monitor now. So basically, this interface now can be used to capture any packet that is within our range, not only the packets that are directed to this computer. That's why in the future, you'll see how we can use it to sniff packets, to analyze them, and even break into networks. So in the future, if I say use your interface in monitor mode, this is what I mean. You'll basically have to enable monitor mode as shown in here. Now, I've also included a YouTube video in the resources of this lecture to show an alternative method to enable monitor mode. Just in case you got errors with this method, or you tried to follow something that I do in the next lectures and it didn't work, then you can come back and try the alternative method. But if this worked and if monitor mode is enabled successfully, then you don't need to watch that video, you can just continue with the course. One more thing to keep in mind, not all wireless adapters support monitor mode. So for this to work, you need to make sure that your actual adapter supports monitor mode. There are a number of adapters that support that, and I've included another video, again in the resources, of me talking about wireless adapters, how to pick the best one, and which ones that I recommend and use when I'm testing the security of networks. Now that we have enabled monitor mode on our wireless interface, we are able to capture all the Wi-Fi packets sent within our range. Even if the packet is not directed to our computer, even if we're not connected to the target network, and even without knowing the key or the password to the target network. So all we need right now is a program that can capture these packets for us. The program that we're going to use is called AeroDumpNG. It's part of the AirCrackNG suite, and it's a packet sniffer, so it's basically a program designed to capture packets while you're in monitor mode. So it'll allow us to see all the wireless networks around us and show us detailed information about its MAC address, its channel, its encryption, the clients connected to this network, and so on. So let me show you how we're going to use it. First of all, you need to enable monitor mode on your wireless adapter as shown in the previous lectures. So if I go to my Kali machine and run iwconfig to list all the wireless devices on this computer, you'll see that I have an interface called Mon0, and this interface is in monitor mode. Now, depending on the way that you enabled monitor mode, this can be called LAN0, it can be called LAN0 Mon. It doesn't really matter. You just want to make sure you enable monitor mode using one of the methods shown before, and then use the name of the adapter that is in monitor mode when you run AeroDumpNG. Now, to run AeroDumpNG, we're just going to type the name of the program, which is AeroDumpNG, followed by the name of my wireless adapter in monitor mode, which is Mon0, as you can see in here. So the command is very simple. We're typing the program name, which is AeroDumpNG, followed by the name of my interface in monitor mode. If I hit enter, you'll see it'll start working, discovering all the wireless networks around me and displaying useful information about them. This program will continue working unless you quit it, and to quit this program, you have to press Ctrl+C from your keyboard. you can actually use Ctrl+C to quit any running program in your terminal. Now that we stopped the program, let's analyze the output so we understand what it's showing us. So first of all, if we look at this column, the ESSID column, it should be a little bit familiar to you. And basically, this shows us the names of the wireless networks around us. So if I just go to my Mac machine and look for wireless networks, you'll see the same names that we see in here displayed under the ESSID. Now, all of the other columns show us more information about the network name that you see in here, and this information will actually be very useful to us as we go through the course. The first column, the BSSID, shows us the MAC address of the target network. Next, we have the PWR, so this is the signal strength or the power of the network. Now, the higher the number, the better signal we have. So, for example, the network with the best signal right here is this one. Next, we have the beacons. These are frames sent by the network in order to broadcast its existence. So every network, even if it's set to be hidden, always sends these type of frames, basically broadcasting its existence and telling all the wireless devices around it that I exist, I have this BSSID, I work on this channel, I use this encryption, and my name is this. Next, we have the number of data packets or data frames, and these are the useful packets that we'll talk about later on once we get to the cracking section. This column represents the number of data packets that we collected in the past 10 seconds. Next, we have the channel, which is the channel that the network works on. So for example, this network right here, the test AP, works on channel 6. This network works on channel 1, and so on. Next, we have the maximum speed supported by the network. The encryption is a very important column, and it shows us the encryption used by the network. So we can see that the test AP network is using WPA. We can see we have a network that uses web. We can see this network right here is an open network, so it doesn't use encryption. We don't even need a password to connect to it. And we can see we have a WPA2 network right here. Cipher is the cipher used in the network. So we can see here we have CCMP, we have web, and we have CCMP again here. Auth is the authentication used on that network. And in here we can see it's PSK, pre-shared key, and MGT for this network. Now don't worry about the INC, the cipher, and the auth. We will talk about breaking into all these networks into web, WPA, and WPA2 in the gaining access section. And finally, you can see we have the ESSID section, which shows the name of the network. So this is what you see when you look for networks in your network manager. So that's it for this lecture. I just wanted to give you a quick look on how to discover all the networks around us using AeroDumpNG. Don't worry about AeroDumpNG too much now. We're going to be using it a lot in the next lectures, and you'll get very comfortable with using it as we go through the course. In this lecture, I'd like to talk about Wi-Fi bands. The band of a network defines what frequency it can use to broadcast the signal. This means it also defines the frequency that the clients or the computers need to be able to support and use in order to be able to connect to this network. The two main frequencies used in Wi-Fi networks are 2.4 and 5 GHz. Now, previously, when we used AeroDumpNG, we were only sniffing on the 2.4 GHz frequency. You can see, first of all, my wireless adapter is in monitor mode, Mon0 in here. So if I just do AeroDumpNG Mon0, you'll see that I can get the wireless networks around me. But you might have noticed that you won't actually see all the networks around you when you run aerodump-ng. I'm going to Control-C this, and if I go here to my normal host machine, and it actually has a built-in wireless adapter, so it's not as strong as my alpha adapter, but if I look for networks, you'll see I actually have much more networks in here. And mainly I have networks ending here in the name by 5G. Now the network doesn't have to necessarily end in 5G, but here in Ireland, if a network broadcasts over 5 GHz, the service provider adds 5G to the network name. But we also have other networks broadcasting over 5G that don't end in 5G. But basically the main point that I want to talk about is I'm not able to see all the networks around me in here in aerodump-ng. And the reason for this is because aerodump-ng is only sniffing on 2.4 GHz frequency. So if you do this and you don't see all the networks around you, or if you're sniffing on your own network, but you don't see all the clients in your network, it's possible that your router is broadcasting over two bands, over 2.4 and 5 GHz. And if you're not seeing the router at all, if you're not seeing the network at all, like what's happening here for me, then the router is probably just broadcasting over 5 GHz. Now, this doesn't mean that your wireless adapter is not good. It just literally means that this adapter is not able to see 5 GHz frequency. It's just outside of its limit, outside of its reach. The main problem with 5 GHz is that there are a lot of wireless adapters that can see it and can communicate with it, but not many of them support monitor mode and packet injection. So you might see me and other people recommending wireless adapters like Alpha AWUS 036NHA. This is my most favorite wireless adapter. I use it all the time, even now. But the problem with that adapter is it doesn't pick up 5 GHz frequency. So it doesn't mean that that adapter is bad, it just means that it can't see 5 GHz frequency. Like I said, there aren't many wireless adapters that support 5 GHz, but I have an adapter here. It's Alpha AWUS 036ACH, and this adapter supports both 2.4 GHz and 5 GHz frequencies. It's not as good as the Alpha, but it does the job. Now, if you want more information about wireless adapters, check out the link in the resources. I'm not going to talk a lot about what wireless adapters do. But in this lecture, I want to show you how to sniff and discover 5 GHz frequency networks, and then so that you can use all the attacks that you've learned in my other lecture and in my previous videos with 5 GHz networks. So, the adapter that I'm using right now supports 5 GHz, but as you can see, I still can't pick up these networks. That's because I need to specifically tell aerodump-ng that I want you to listen on 5 GHz frequencies and 5 GHz channels. To do that, all we have to do is just do aerodump-ng, like we always do. And then we're going to use a new argument that we haven't seen before, and this argument is called band. And we're going to tell it that I want you to sniff on band A, and that's the band that supports 5 GHz frequency. And then I'm just going to give it the name of my wireless adapter in monitor mode, which is Mon0. So the command is very simple. It's very similar to what we've used before. And all we have to do is just type in aerodump-ng, followed by the band. And the band that we want to use is A. And we're following that with our wireless interface. So I'm going to hit enter. And as you can see, as soon as we hit this, I'm actually just going to do Control-C now because you can see the results. You can see that we got much more networks right now. And we have the 5 GHz network. So we have this network and this network that we weren't able to see. We have the Jameson Whiskey network as well. And basically we're able to capture all the networks that use the 5 GHz frequency. Now what you can also do, let me clear the screen. You can specify multiple bands using the band argument. So again, using the same command, instead of just saying band A, we can do band A, B, G. And what this will do is it'll tell AeroDumpNG to capture data on both 2.4 and 5 GHz frequencies at the same time. So let me show you. So as you can see right here, we're capturing some 2.4 GHz networks and we're capturing 5 GHz networks as well at the same time. And we'll also be able to discover clients connecting to both bands. The only problem with using AeroDump like this is, first of all, you need a powerful wireless adapter to do this. Also, it'll be slightly slower than only sniffing on one band, because when you're sniffing on two bands, you have a lot of channels that AeroDumpNG has to hop on all of them and discover clients and networks broadcasting on these channels. So, if you want quicker results, then you're better off just specifying the band A when you want to sniff on 5 GHz frequencies and just not specify the band when sniffing on 2.4. But as you can see, you can just run the command like so with band ABG, and this way you'll be able to capture data sent over 2.4 and 5 GHz frequencies. Also keep in mind, in order to sniff data on 5 GHz frequency, like I said, your wireless adapter needs to be able to support this band. So simply adding the band argument will not work unless your wireless adapter can support and can sniff data on this band. One more thing that I want to note, I've actually said this before. If you run AeroDumpNG against a network and you see some devices missing, then there is a high chance that these devices are connected over 5 GHz. So again, use the band A and then you should be able to see these devices. In the last lecture, we've seen how to use AeroDumpNG to list all the networks around us and display useful information about them. Usually, we do this in order to see our target network, see the signal strength, see how far we are from it, and then start targeting this target network. Now, in this example, I'm going to assume that my target network is this one right here. This is actually the network that my host machine is connected to. And now that I have my target network and I have some basic information about it, let's see how we can run AeroDumpNG against this network only, not against all networks. And this way we'll be able to gather more information about it. So to do this, first of all, I'm going to have to write the name of my program, which is AeroDumpNG. Then I'm going to specify a specific BSS ID or a specific MAC address for AeroDumpNG to sniff data from. So my target network has a BSS ID of this. We can see it here under the BSS ID. So I'm going to copy it. And then I'm going to do --BSS ID. And I'm going to give it the BSS ID that I just copied. Next, I'm going to specify a channel for AeroDumpNG to sniff on. Again, if we look under the channel column in here, we can see my target network is on channel 2. So I'm going to do --channel 2. So now we're telling AeroDumpNG that I want you to sniff data on channel 2 and only from a network that has this BSS ID. I'm also going to tell AeroDumpNG that I want you to store all the data that you're gonna gather for me in a file. So I'm gonna say --write, and then I'm gonna type a file name, and let's call this test. And at the end, as usual, I need to give it the name of my wireless adapter in monitor mode, which is Mon0 in my case. So, very simple command. Let's go over it one more time. We're doing AeroDumpNG, that's the name of the program that I want to use. I'm telling it that I only want you to sniff data from a specific BSS ID. Then I'm giving it the BSS ID of my target. Then I'm telling it I want you to only sniff data from a specific channel, and I'm giving it the channel that I wanted to sniff data from. Again, we can get it from here, it's number 2. Finally, I'm telling it that I want you to write all the data that you're gonna capture in a file that we're gonna call it test. And then I'm giving it my wireless adapter in monitor mode, which is mon0. Now I'm gonna hit enter. And as you can see, unlike the last time, aerodump-ng is only showing me one network in here. This is the network that I wanted it to sniff data on. And we can also see we have a completely new section right now. So when I ran aerodump-ng in the previous lecture, you seen I only had the networks in here and I had nothing here at the bottom. But now you can see we have more entries in here at the second section of aerodump-ng, and basically anything that you see here in the second section, these are the clients or the devices connected to this network. So right now we can see this network has 3 devices connected to it, and you can see the MAC addresses of these devices under the station. So you can see all of these devices are connected to the same network. So the BSSID is still the same. This is the MAC address of the network. And under the station, we have the different clients or different devices connected to this network. We can also see the power. So this is the signal strength of each of these devices. We can see the speed. We can see the amount of data lost. We can see the amount of frames or packets that we have captured. And we can see if any of these devices are still probing for networks. So sometimes when you run aerodump-ng against all networks, you'd still see this section and you'd see that some devices are not connected and they're literally trying or looking for networks. So you'd see the name of the networks that they're looking for under the probe. Now, if I hit Ctrl+C, aerodump-ng will quit, it'll stop working, but I should have new files in my current working directory that contain the data that we just captured. Because remember, when we ran the command, we used the right option in here to store the data in a file called test. So if I just do ls to list all the files in my current working directory, you can see I have 4 files. All of them start with test, but they all have different extensions. So we have a CSV, we have a netxml, we have a cap, and we have a Kismet CSV. Now also notice that aerodump-ng automatically appended -01 to each of these files. So in the future, when you go and try to use the capture file, make sure you append -01 to the file name that you specify in the command. Now, the main file that we're going to be using is the cap file. Again, this file contains the data that we captured during the period that aerodump-ng was working on in here. And basically, this file should contain everything that was sent to and from my target network. So it should contain URLs, chat messages, usernames, passwords, or anything that any of these devices did on the internet. Because anything that they have to do will have to be sent to the router, as we've seen before. The only problem is, if you look at the encryption in here, you can see that my target network uses WPA2 encryption. So all of the data sent between the router and the clients is encrypted. So let me show you what I mean. I'm going to use a tool called Wireshark to analyze the data. And don't worry about how to use Wireshark. We will talk about it in details later on. Right now, I just want to make sure that you understand the idea that now we're able to capture all these packets. The only problem is these packets are encrypted. So I'm going to do Wireshark to run Wireshark. And then I'm going to open my capture file. So I'm going to go to File, Open, and it's already in my root directory. So I'm just going to scroll down and select my test1 cap. I'm going to open it, and I'll just put this in full screen. And as you can see, if we click on any of these packets, you can see we really have no useful data. You can see everything looks like gibberish and we can't read anything, even though these packets might contain usernames, passwords, or URLs. The only useful thing that we can see here is the device manufacturer. So we know one of the devices connected to the network that has this specific MAC address. So it's the one that ends with E8. And if we go up, we can see that it's this specific device. We know now it is an Apple device. So it could be an Apple computer, it could be an iPhone or an iPad. And this is actually my MacBook computer that is the host machine. Again, we can see we also have a device that's using a Huawei chipset. So this can be a phone or it could be the router. And if you look at the MAC address here and compare it to the MAC addresses that we have here, you can see that this is actually under the BSSID. So this is the MAC address of the router. So now we know that the brand of my router is Huawei. So we can gather more information by opening this file in Wireshark, and we can kind of guess what computers are there and what operating systems they use. But this is not detailed enough. And the main problem with this is the fact that the network is using encryption. Now, in the next section, we're going to be talking about how to break this encryption. And once we do, you'll see how we can see the passwords, the usernames in plain text. And you'll also see how we can map all of the computers on the same network, gather detailed information about them, hack into them, and do some really, really cool stuff. Now, you should guess by everything that I said so far, if this network was an open network, if it was a network that does not use any passwords, then you would have been able to actually see all the URLs and everything that they do in here. But again, if you can't connect to the network without a password, then you'll automatically be at the PostConnection section. And in that section, like I said, we're going to talk about some really, really cool attacks that you can do once you have the password or once you can connect to the network. So don't worry about Wireshark for now. I just wanted to make sure that you understand why encryption is useful and why it's used and why we can't see much now because we don't know the key. We will talk about Wireshark and all of that later on in the next section. Now, before leaving this section and moving to the gaining access section where I'm going to teach you how to break the different encryptions and gain access to networks, I want to spend one more lecture talking about a really useful attack that still falls under the pre-connection attacks under this section. The attack that I want to talk about is the deauthentication attack. This attack allows us to disconnect any device from any network before connecting to any of these networks and without the need to know the password for the network. To do this, we're going to pretend to be the client that we want to disconnect by changing our MAC address to the MAC address of that client and tell the router that I want to disconnect from you. Then we're going to pretend to be the router again by changing our MAC address to the router's MAC address and tell the client that you requested to be disconnected, so I'm going to disconnect you. This will allow us to successfully disconnect or deauthenticate any client from any network. Now, we're actually not going to do this manually. We're going to use a tool called AirplayNG to do that. From the previous lecture, we know that this MAC address right here belongs to an Apple computer. And like I said, this Apple computer is actually my computer right here. And as you can see, this host machine is connected to this network right here, which is the same as the one that you see in here. And it actually has internet access. So if I just look for test, you'll see that I'm connected and I can look for things. I can use Google. So I have a proper working internet connection. Now, we're going to come back here and we're going to use a tool called AirplayNG to launch the deauthentication attack and disconnect this Mac computer from the internet. So we're going to type the name of the program, which is AirplayNG. we're gonna tell it that I want to run a deauthentication attack. Then I'm gonna give it the number of deauthentication packets that I want to send. So I'm gonna give it a really large number so that it keeps sending these packets to both the router and the target device. Therefore, I'll disconnect my target device for a very long period of time, and the only way to get it back to connect is to hit Ctrl+C and quit areplayng. Next, I'm gonna give areplayng the MAC address of my target network. So I'm gonna do -A and give it the MAC address, which I'm gonna copy from here. Then I'm gonna use -C to give it the MAC address of the client that I want to disconnect. And the client that I want to disconnect is this client right here, which is the Apple computer, like we said. So I'm gonna copy it and paste it here. If your target network runs on the 5 GHz frequency, then you'll have to add -D to the command in here. But my target, as you can see, it uses 2.4 GHz. Therefore, I don't need to do this. And I'm simply just gonna add my wireless card in monitor mode, which is mon0. Now, it's very important to understand that this command will only disconnect the target client from the specified network. So if there are other networks that the target client can connect to, it will automatically connect to them. So in many cases, it might connect to the 5 GHz version of the network, or it might connect to a completely different network that it already knows the password to. And if it's a mobile device, it might even continue to have internet access through its mobile data plan. So it might seem like the attack did not work, but it actually worked, and the client just disconnected from this network and is using another network. To solve this, all you have to do is simply open up a new terminal window and run the exact same command, but this time target the new network that the client connected to. I actually covered that along with more advanced topics in my advanced network hacking course. Check out the bonus lecture, the last lecture of this course, for more information about my advanced network hacking course and all of the other courses that you can take along with this course. So a very simple command. We're typing areplayng. This is the name of the program that we're going to use. We're doing --deauth to tell areplayng that I want to run a deauthentication attack. I'm giving it a really large number of packets so that it keeps sending the deauthentication packets to both the router and the client and keep the client disconnected. I'm using -A to specify the MAC address of the target router or the target access point. Then I'm using -C to specify the MAC address of the client. Finally, I'm giving it mon0, which is the name of my wireless adapter in monitor mode. Now you can run this command like this, and in most cases it would work. But in very rare cases, this command will fail unless aerodumpng is running against the target network. So what I'm going to do now is I'm going to go back to my first terminal in here, and I'm going to run aerodumpng using the command that we've seen before. And I don't want to write anything to a file, so I'm going to remove the write argument. So I'm just doing a normal aerodumpng command. I'm literally just giving it the BSS ID of my target network, and I'm giving it the target channel. And then I'm just going to hit enter. We've seen how to do this. We spent a full lecture on it. That's why I did it really quick. And then I'm going to go back to the command that we wrote so far, and I'm going to hit enter. Now, as you can see, areplayng, it's telling me that it's sending the deauthentication packets. And if we go back here and look up, you can see that I actually lost my connection and I'm trying to connect back. So obviously, if I try to look for anything, so let's say test2, you'll see I'll get stuck and nothing will load for me. So the only way for me to connect back is if I go back here, if I quit this by doing Ctrl+C, quit this again, and now my machine should be able to connect back and restore its connection. This is actually very handy in so many ways. It's very useful in social engineering cases where you could disconnect clients from the target network and then call the user and pretend to be a person from the IT department and ask them to install a virus or a backdoor, telling them that this would fix their issue. You could also create another fake access point and get them to connect to the fake access point and then start spying on them from that access point. And we'll see how to do that later on in the course. And you can also use this to capture the handshake, which is what happened in here actually. And this is vital when it comes to WPA cracking. And we'll talk about this once we get to the WPA cracking section. So, like I said, this is a small attack that can be used as a plugin to other attacks or to make other attacks possible. Everything we've done so far can be done without the need to connect to the target network. Now, once we connect to the network, we can do so many cool things. We'll be able to gather so much more info. We'll be able to intercept the connections and see everything that the people send, whether it's usernames, passwords, URLs, or anything really. We'll also be able to modify the data, and you'll see all of this in the next section of this course. Now, if your target does not use encryption, then you can just connect to it. If your target is a wired network, then you can just use a cable and connect to it and move to the next section. The only problem is if your target is using encryption. So, in this section, I'm going to show you how to break that encryption and gain access to Wi-Fi networks, whether they use WEP, WPA, or WPA2. Once we get the key, we'll be able to connect to the network and you'll be able to do all of the things that you'll learn in the next section, in the post-connection section. The first encryption that we'll learn how to break is called WEP, or Wired Equivalent Privacy. This is an old encryption that can be easily broken. The reason why I'm still covering it in this course is, first of all, because, like I said, it's very simple, so it's a good starting point. Also, it's still used sometimes in some networks. Therefore, you can't really call yourself a hacker, and then if you see a network that uses web, you'll get stuck and you won't even be able to break into it. So, in this lecture, I'm going to explain how web works and what's the weakness that we can use to break it. And in the next lecture, you'll see how we can use this weakness in order to break web and get the key for any network that uses WEP. So basically, WEP uses an algorithm called RC4 to encrypt its data. So the way this works is basically, if a client wants to send something to the router, and let's say it wants to send this text data to send to the router, it'll first encrypt this using a key. Therefore, this normal text will be converted into gibberish, as you can see here. This encrypted packet will be sent into the air. So if a hacker captures this packet, as we've seen before, if we open this packet, we'll see that it's full of gibberish. Even though it actually contains useful information, we won't be able to read it because it's encrypted. The access point will receive this encrypted packet and it'll be able to transform it back to its original form because it has the key. Therefore, it'll actually be able to read the contents, which is data to send to the router. The same happens if the router wants to send something back to the client. It'll first encrypt it using a key, send it to the client. The client will be able to decrypt it because it has the key. So the concept is always the same. The transmitter encrypts the data using a key, sends it to the receiver. The receiver is able to decrypt it because it also has the key. Therefore, anybody who captures the packet in the middle, they will get the packet, but they won't be able to see the contents because they do not have the key. So, the algorithm and the way RC4 works is actually fine. The problem is with the way that WEP implements this algorithm. And to understand this, let's zoom in a little bit more on each step. So, going back to the first step, we have the client trying to send data to the router, and the data that it wants to send is data to send to the router. So in order to encrypt this, WEP tries to generate a unique key for each packet. So literally each packet that's sent into the air, it tries to create a new unique key for it. To do that, it generates a random 24-bit initialization vector. The initialization vector is then added to the password of the network, to the actual key that people use to connect to the network. This generates a key stream, and then this key stream is used to encrypt this packet and transform it into gibberish. So basically we have the key stream plus the data that we need to encrypt gives us the gibberish, and then the gibberish is sent into the air. But before sending this into the air, WEP will also append the initialization vector. This is the 24-bit random number that I said it creates in order to make sure that each packet has a unique key. The reason why it adds the initialization vector to the packet is because once the router receives this packet, it needs to be able to decrypt it. And to decrypt it, it needs the key and the IV. But the router already has the key, so there is no need to send that. Therefore, we just need to send it the IV. So, when the router receives the packet, it has the IV, it has the password or the key, so it can generate a key stream and then use that key stream to transform this gibberish into its original form and read the packet. So, if you think about what I said, you can probably guess what the weakness is. Basically, the IV is sent in plain text. So if you look at this, you can see the packet content is encrypted. So if someone captures this packet, they won't be able to read this, but they will be able to read the IV in plain text. Also, the size of the IV is only 24 bits. Now, considering the huge amount of traffic that can be generated on a Wi-Fi network, this number is not big enough, and the IVs will start getting repeated in a busy network. This makes WEP vulnerable to statistical attacks, so we can use a tool called aircrack-ng to determine the key stream once we have enough repeated IVs, and from that it will also be able to crack WEP and give us the key to the network. So from the previous lecture, we know in order to crack WEP, we need to first capture a large number of packets. This means that we'll capture a large number of IVs. The IVs, because they are short, they will be repeated. Therefore, we'll be able to use a tool called aircrack-ng to run statistical attacks and crack the web key. So we're using aerodump-ng to capture the data, and we've seen how to do this before. Then we're using aircrack-ng to analyze this data and break the key. Let's see how to do this in practice. So I already have my wireless adapter in monitor mode, and it's called Mon0. I've also already run aerodump-ng to list all the networks around me. And as you can see, I have only one network using WEP. This is called test AP3, and this is my actual network that I use every day. I've just configured it to use web to make this lecture. The main reason why I'm targeting the network that I use daily, because like I said, for this to work, we need to capture a large number of packets, and therefore we need a busy network, a network that gets used constantly to capture a large number of packets. If the network is idle, then the process is a little bit complex, and I will cover that in the next lecture. So for now, let's focus on the simplest form, which is how to break into a busy network. So I'm going to copy the BSS ID of this network, and I'm going to run aerodump-ng against this network only. So I showed you how to do this before. I'm going to do aerodump-ng. I'm going to do --BSS ID to specify the BSS ID of the network. Then I'm going to do --channel to specify the channel of the network, and we can see it's running on number 1. And I'm going to do --write to store everything that we capture into a file. And let's call this file basic web. And then I'm going to specify my wireless adapter in monitor mode, which is mon0. So we ran this command before in the targeted sniffing lecture. All we're doing is we're running aerodump-ng against a specific network with this MAC address, with this channel, and we're storing everything in a file called basic web. I'm going to hit enter, and as you can see, aerodump-ng is working against my target network. And if you notice, you'll see the data in here is increasing really fast. So this is something that I told you I'll talk about it later when we were talking about aerodump-ng, because I didn't want to talk about IVs at that early stage. So basically what you see under the data column is the number of useful packets that contain a different IV that we can use in order to crack the key. So the higher this number is, the more likely we will be able to crack the key. As you can see, this number is increasing very fast because, like I said, this is a busy network that is being used at the moment by my own computers and my own devices. If yours isn't increasing fast, then don't worry, we will tackle this problem in the next lectures. So for now, we're capturing a lot of data, and this should actually be enough to crack the key. So what I'm going to do, I'm going to go down to my other terminal in here, and if we actually list the files, you'll see that we have the capture file that we specified in the right argument, and like I said, we're always interested in the .cap file. So all we have to do right now is do step 2 in here, run aircrack-ng against the file that we captured in order to crack the key. So I'm going to do aircrack-ng, followed by the file name, which is basicweb01.cap. I'm going to hit enter, and as you can see, it's telling us that the key is found. So let me cancel this here. And right now, we can connect to the target network, which is called test AP3, using this ASCII password. So you can literally just copy this and paste it, or you can connect using this key. Now, in some cases, you will not see this ASCII password. That's why I'm going to show you how to connect using this key right here, because you'll always get this. So I'm going to copy this, and I'm just going to paste it here. You can paste it anywhere in a normal text editor or anywhere you want. And all you have to do is remove the columns that we see in here between the numbers. So I'm going to remove this one, going to remove this one, and this. And now we can just copy this. And just to show you, I'm actually going to connect from my host machine. You can connect from Kali, but when we enabled monitor mode, we killed a lot of processes, and sometimes even after you restart these processes, getting connected to your target will be a little bit buggy. So it's best to literally just restart Kali and connect again. So just to save all of this time, I'm going to connect from here. I'm just going to click here. I'm going to connect to test AP3, and I'm going to paste the password. So I'm just going to click on show the password to show it to you. Again, the same password, we just removed the columns. I'm going to click on join. And as you can see, we managed to connect, and we can test this connection by going to Google. And perfect. As you can see, it's working, and we managed to break the WEP encryption. In the previous lecture, we've seen how easy it is to crack WEP. All we had to do is capture enough data and then run aircrack-ng to crack the encryption and give me the key. Now, one problem that we could face is if the network is not busy. If it's not busy, then the number of data will be increasing very slowly. Therefore, we're going to have to wait for a while before we have enough data to crack the key. So let me show you an example. I'm just going to run aerodump-ng here and list all the networks around me. And you can see I have my test network, my test AP in here. It's using web. And if you look under the data, you'll see that it's at 0 and it's not increasing. And even if it's going to increase, it's going to increase very, very slowly, which means that I'm going to have to be waiting for hours before I can crack this network. So a solution to this is to force the AP to generate new packets with new IVs. Now, before doing this, we need to associate with this network. So what I mean by associate is we need to tell this network that we want to communicate with it, because by default, access points ignore any requests they get unless the device has connected to this network or associated with it. So don't get this mixed up with connecting. We're still unable to connect to the network because we need the password to be able to connect to the network. But what we're doing right now is literally just telling the target network, look, I want to communicate with you. Don't ignore my requests. That's all we're doing. So it's something similar to what happens when you just click on the network when you want to connect to it. You still haven't put the password. You're just telling the target network, I want to communicate with you. Please don't ignore me. So in this lecture, I'm going to show you how to associate with the target network so we can communicate with it. And in the next lecture, I'm going to show you how, once associated, we can inject packets into the network and force the number of data to increase very, very quickly. First, I'm going to run aerodump-ng against my target network, which has this BSSID. So I'm going to copy it. And we're going to use the exact same command that we've been using so far. So we're going to do aerodump-ng --BSSID, followed by the MAC address of my target, --channel, followed by the channel which my target is running on, which is 6. And we're going to store all of this. So we're going to do --write, and we'll call this file ARP replay because that's the name of the attack. And then I'm going to put my wireless adapter in monitor mode, which is mon0. So a very simple command that we done before. We're using aerodump-ng to capture data from a network with this MAC address running on this channel. We're storing everything in a file called ARP replay. I'm gonna hit enter, and as you can see, it's running against my target. And notice the data is increasing really, really slow, or it's actually not increasing at all right now. Now, to associate with this network, we're going to use a program called areplay-ng. So we're going to type areplay-ng, followed by --fake auth, because we want to do a fake authentication attack. We're going to put 0 because we only want to do this once. We're going to do -a to specify the MAC address of the target network. So I'm going to paste it. I've already copied it. Then we're going to do -h to specify the MAC address of my wireless adapter. And to get the MAC address of my wireless adapter, I'm going to do ifconfig. And it's the first 12 digits of the unspec field. Usually you'd see it after the ether, but when you enable monitor mode, it'll show up like so. So I'm going to copy this. And I'm going to paste it here. And I'm going to replace the minuses with colons. And that's it. It's done. And finally, I'm just going to give the name of my wireless adapter in monitor mode. So a very simple command. We're using areplay-ng, which is a tool that can be used to run a number of attacks. And we've seen using this with the deauthentication attack. We're telling it that we want to run a fake authentication attack. We want to do this once. We're giving it the MAC address of my target network after the A. Then I'm giving it the MAC address of my wireless adapter after the H. And finally, I'm giving it my wireless adapter in monitor mode. Now, before I run this, notice in here under the auth, we have nothing, and we don't have any clients showing up in here at the bottom. Now, if I hit enter, you can see under the auth, it's showing up as open, and you can see we have a new client here associated with the network. If you look in here, you'll see this is the MAC address of my target network, and right here is the MAC address of my wireless adapter. So right now I am associated with the target network, and if I send it anything, it's going to accept it and it's going to communicate with me. Again, I am not connected to the network. I still can't use the internet. I'm literally just associated with the network so I can communicate with it. Now, in the next lecture, I'm going to show you how we can communicate with this network in a way to force it into generating new packets with new IVs, which will allow us to crack the key very, very quickly. Now that we have associated with our target network, we can start communicating with it and it won't ignore us. So now we can go and start injecting packets into the traffic to force the access point to generate new packets with new IVs. This will increase the number of data really quickly, allowing us to crack WEP networks in minutes, even if the network was not busy like the one that we are targeting right now. Now, there are a number of ways to do this, but in this course, I'm going to explain the most reliable method, which is using an ARP request replay attack. I actually explain other methods in my network hacking course, but they are a little bit more complex and have less success rate. So this is the most reliable method, and it should work against most networks if you have a good signal and a good wireless adapter. So the idea behind this method is to wait for an ARP packet, and I'll talk about ARP in more details later on. So for now, just think of it as a special type of a packet that we're going to be waiting on. Once this packet is sent in the network, we're going to capture it and retransmit it. Once we do this, the router is forced to generate a new packet with a new IV. So, by repeating this process, we will be forcing the router to continuously generate new packets with new IVs. Then, once we have enough data, once we have enough IVs, we can run aircrack-ng exactly as we seen before and crack the key. So let me show you how to do this in practice. Now, as you can see, I'm already running aerodump-ng against my target network, and I have already associated with it as shown in the previous lecture. So the only thing that's left right now is to run the ARP replay attack in order to inject packets into the traffic and force the router to generate new packets and increase the number of data. To do that, we're going to use areplay-ng again, and the command is actually going to be very similar to this command right here. So I'm actually going to copy all of this because I'm lazy, and I'm going to clear this and paste the command here. Now, there are only a few things that I need to modify. First of all, I don't want to run a fake authentication attack, so I'm going to remove all of this. And I want to run an ARP replay attack. Also, this attack does not take a number, so I'm going to remove this number. And I'm also going to replace the A with a B. And we're done. So, if you look at it, you'll see it's actually very similar to this command right here. We're using areplay-ng, but instead of doing a fake authentication attack, we're doing an ARP replay attack. We're giving it the MAC address of my target network after the B instead of the A. Then we're giving it the MAC address of my wireless adapter after the H, which is identical to this. And then we're giving it my wireless adapter in monitor mode. Now, I'm actually going to associate again before I do that. And then I'm going to hit enter here. And what's happening right now is my wireless adapter is waiting for an ARP packet, once there is an ARP packet transmitted in this network, it's going to capture it and it's going to retransmit it. Once it does that, the access point will be forced to generate a new packet with a new IV, and will keep doing this, forcing the access point to continually generate new packets with new IVs. So you should just wait for it right now. We're literally just waiting for an ARP packet to be sent in the air. And as you can see, the number of data is increasing now very, very quickly, which means that we actually managed to capture an ARP packet. This ARP packet got retransmitted, forced the router to generate a new packet with a new IV, and we are continually doing this process, forcing the router to generate new packets with new IVs. So right now we can go ahead and run aircrack-ng to crack this network. And before I do that, I'll actually just associate one more time, and then I'm gonna do aircrack-ng and give it the name of the file which we're storing the data in, which is called arpreplay01.cap. So I'm gonna hit enter, and you'll notice the cracking process right now will actually require more data packets. The reason for this is I've actually modified the settings of this network so that it uses a 128-bit key, because in web you can either use a 64-bit or a 128-bit key, and obviously the 128 key is longer. Therefore, I actually modified the key length for this lecture to make sure it's the longest key possible, and as you can see, we still managed to get it within about 47,000 packets. We have the key right here in ASCII, and we have the key in here in hex, where we can use after we remove the colons. So perfect, now we managed to crack the target network. It was idle, as you could see, there was no data being sent, and we managed to do this by forcing the target access point to generate new packets with new IVs. In the previous lectures, we've seen how to crack the WEP encryption in minutes, even if the target network is not busy. Now, in the next lectures, we will talk about cracking WPA and WPA2. First of all, before we start talking about how to crack these encryptions, it is very important to understand that both of them are very, very similar. The only difference between them is the encryption used to ensure message integrity. WPA uses TKIP and WPA2 uses an encryption called CCMP. In any case, this does not affect the methods that we're going to use to crack WPA and WPA2. Therefore, all of the methods that I'm going to show you from now on will work on both WPA and WPA2. Now, both of these encryptions came after WEP, and they were designed to address the weaknesses in it. Therefore, both of them are much more secure, and cracking them is more challenging. So, before we start talking about how to crack them, I want to cover a feature that, if enabled and misconfigured, can be exploited to recover the key without having to crack the actual encryption. The feature is called WPS. It allows devices to connect to the network easily without having to enter the key for the network. So it was designed to simplify the process of connecting printers and such devices. You can actually see a WPS button on most wireless enabled printers. If this button is pressed and then you press the WPS button on the router, you'll notice that the printer will connect to the router without you having to enter the key. This way, the authentication is done using an 8-digit PIN. So you can think of this as a password made up of only numbers, and the length of this password is only 8. So this actually gives us a relatively small list of possible passwords, and we can try all of these possible passwords within a relatively short time. Once we get this PIN, it can be used to recover the actual WPA or WPA2 key. So as you can see, with this method, we are not exploiting WPA or WPA2. We are actually exploiting a feature that can be enabled on these encryptions. So for this to work, first of all, we need WPS to be enabled on the network because it can't be disabled. Also, it needs to be misconfigured, so it needs to be configured to use a normal pin authentication and not a push button authentication. If push button authentication is used, then the router will refuse any pins that we try unless the WPS button is pressed on the router. Therefore, the method will not work if push button or PBC is enabled. So in most modern routers, PBC comes enabled by default or WPS will be disabled by default, so this method might not work. But because WPA and WPA2 are so secure and so challenging, it is always a good idea to check if WPS is enabled and try the method that I'm going to show you to crack the network. If it fails, then you can try the other methods that I'm going to show you after the next lecture. Okay, now that we know what WPS is and how it can be used to recover the password for WPA and WPA2 networks, let's see how to do that in practice. So, right here I have my Kali machine. I've already enabled monitor mode on my wireless adapter on Mon 0. Now usually we use AeroDump-ng to see all the networks around us. But right now we want to see the networks that have WPS enabled, but because like I said, it's just a feature and people can turn this feature off. So first of all, I'm going to use a tool called Wash to display all the networks around me that have WPS enabled. So we're going to do wash --interface and give it my interface in monitor mode, which is Mon 0. So all we're doing is wash is the name of the tool, interface to give it the interface, and Mon 0 is my wireless adapter in monitor mode. If I hit enter now, you'll see it'll list my network straight away. Now I pressed Ctrl C to cancel this, similar to AeroDump-ng, because it'll keep running unless you cancel it. And you can see this is my target network. It's called test AP. It's giving us the vendor of the hardware used in this network, in this access point. The LCK tell us whether WPS is locked or not, because sometimes WPS locks after a number of failed attempts. So right now this says no, which means that we can actually go ahead and try to guess the pin. It's giving us the version of WPS. It's using version 1. The signal strength is in here, the channel, and the BSS ID. Now I explained the meaning of all of these things before in my AeroDump-ng lecture, so I'm not going to talk about them now. If you forgot the meaning of any of these terms, please go back to the AeroDump-ng lecture. Now this network actually uses WPA2, so just to confirm this to you, if I go here to my host machine and just try to connect to it, you'll see that it's telling me that this uses a WPA2 password. But like I said, we don't care if it's WPA or WPA2 because we're going to be exploiting a feature in these encryptions, which is the WPS feature. So now that we know our target network uses WPS, there is a good chance that this attack will work against it. The only reason it might fail is if the target uses PBC or push button authentication. Like I said, if the target uses PBC, then it will refuse all the pins unless the button is pressed on the router, and therefore this attack will fail. The only way to know is to literally try this attack and see if it works. So I'm going to copy the MAC address of this network or the BSS ID. And the first thing that I'm going to do, similar to what we did with WEP, I'm going to associate with the target network using a fake authentication attack. So basically, I'll be saying, I want to communicate with you. Please don't ignore me, so that when I run the attack, the network will start accepting the pins and not ignore me. So to associate, we're going to use the exact same command that we used when we did it with WEP. So we're going to use a reply-ng. We're going to tell it I want to run a fake authentication attack. We're going to give it the delay. So this is the time to wait between association attempts. Previously we set it to 0 and we had to do this manually every now and then. Right now I'm going to set it to 30 so that we associate with the target network every 30 seconds. Then I'm going to do -A to give it the MAC address of my target, and -H to give it the MAC address of my wireless adapter in monitor mode, and we've seen that we can get this by doing ifconfig and copy it from here. We said it's the first 12 digits, and I'll just replace the minus with the colon. And finally, I'm going to give it the name of my wireless adapter in monitor mode, which is mon0. So I explained this in details before. That's why I did it quickly. If you don't remember how I did this, please go back to the fake authentication attack lecture. So the command is ready now, but I'm not going to execute it. I'm going to go down to the bottom terminal and run Reaver, which is the program that will brute force the pin for me, and only then I will associate with the target, because otherwise areplay-ng will fail to associate with my network. So I'm going to move to this terminal right here, I'm going to clear the screen, and we're going to run Reaver, which is the program that's going to brute force the pin. So it's going to try every possible pin until it gets the right pin. Once it has the right pin, it'll use it to compute the actual WPA key. So using Reaver is very simple. It's very similar to everything we've been doing so far. So first of all, we have to type the program name, which is Reaver. Then I'm going to do --BSSID to give it the MAC address of my target network. So I'm just going to paste it. Then I'm going to do --channel and give it the channel of the target network, which is 1. Then we're going to do --interface and give it my wireless adapter in monitor mode, which is mon0. So a very simple command. We're using Reaver. This is the name of the program that will do the brute forcing for us and give us the key. We're giving it the BSSID, the MAC address of my target. We're doing --channel to give it the channel that my target is running on. And we're doing --interface to give it the name of my wireless adapter in monitor mode. I'm also going to add 2 more options. I'm going to add -VVV to show us as much information as possible. This is really helpful. If it fails or things go wrong, we'll be able to know what's happening, why things are going wrong. And I'm also going to do --no associate to tell Reaver not to associate with the target network, because we're already manually doing that in here. So Reaver can automatically do this step right here for you, but I've seen that it fails a lot. Therefore, it's actually better to do it ourselves manually here and then tell Reaver not to associate. So now I'm going to hit enter to get Reaver to work. And I'm going to go up to the top terminal and I'm going to hit enter to associate with the target network, telling it please don't ignore us, so that Reaver at the bottom here can brute force the pin and try every possible pin until we get the correct pin, which we'll use to get the password. And as you can see right now, Reaver is trying the pin 1, 2, 3, 4, 5, 6, 7. And perfect. You can see the pin was actually 1, 2, 3, 4, 5, 6, 7, 0. So it's a simple pin. It actually came with this pin. So I didn't manually set this pin. My router came from the factory with WPS enabled with this pin. So like I said, this still works, but again, not against all routers. From that, it was able to discover the WPA key, which is UAU RWSXR, and the name of the router is testap. So I can literally go ahead and connect with this password, and I'll be able to connect to the network and see and decrypt all of the packets sent in the air. Now, if WPS is disabled on your target network, or if it's enabled but configured to use push button or PBC, then the method that I showed you in the previous lecture will not work. Therefore, you will have to go and crack the actual WPA or WPA2 encryption. And like I said, when these encryptions were designed, The developers knew about the weaknesses in WEP and they made sure that they properly fixed these weaknesses. They actually did a pretty good job at this. Therefore, we cannot use the same method used in WEP to crack WPA and WPA2. So in WPA2, the keys are unique, they're temporary, they're much longer than what they were in WEP. Therefore, the packets sent in the air contain no information that is useful for us. So it doesn't matter, even if we capture 1 million packets, we can't use them to crack the key. The only packets that contain useful information are the handshake packets. These are 4 packets transferred between a client and the router when the client connects to the network. So, in this lecture, I'm going to show you how to capture these packets, and in the next lectures, we'll see how to use them to crack the WPA or WPA2 key. First of all, as usual, you'd want to run aerodump-ng against all the networks around you. I've already done that, and as you can see, this is my target right here. It's using WPA2, and this is the MAC address. I'm going to copy it. And the first thing we'll do is just run aerodump-ng on this network and store the data in a file, exactly the same way that we used to do it with WEP. So we're just going to do aerodump-ng --bssid and give it the bssid of my target, --channel, and give it the channel of my target, which is 1, --write, to specify a file name to store all the data that we're going to capture in. And let's call this WPA handshake, because we're going to capture the handshake. And finally, we're going to give it my wireless adapter in monitor mode, which is mon0. So, very simple command. We've done this multiple times by now. We're using aerodump-ng. We're giving it the MAC address of my target after the BSSID. I'm giving it --channel to specify the channel of my target. I'm using --write to store all the data in a file. This file will contain everything that we capture. So if we capture the handshake, it will be in this file. And finally, I'm giving it the name of my wireless adapter in monitor mode. So now I'm going to hit enter. And as you can see, aerodump-ng is working against my target network. And right now, all we have to do is literally sit down and wait for the handshake to be captured. Like I said, the handshake is sent when a client connects to the network. So we'll literally have to sit down and wait until a new client connects to the network. Once a new client connects, we will capture the handshake, and you will see in here aerodump telling us that the handshake has been captured. Alternatively, we can use something that we learned before, which is a deauthentication attack. We know using that attack, we can disconnect a client from the network. So we can do this for a very short period of time. We can disconnect this client from the network. He will automatically connect once we stop the attack. Therefore, when he automatically connects, the handshake will be sent in the air and we will be able to capture it. This way, we will not have to sit down and wait for someone to voluntarily connect to the network. So, we've seen how to do this before, and it's going to be exactly the same command as we did it before. We used areplay-ng, we did --deauth, then we specified a really large number of packets to keep the client disconnected for a long period of time. This time, I'm going to set this to 4 to only send 4 deauthentication packets. This way, my client will be disconnected for a very short period of time. They won't even feel that they got disconnected, but this is enough for the handshake to be sent because they will be disconnected, they will automatically connect, and when they do that, we will capture the handshake. Now, the next argument we want to set is the MAC address of my target. So we're going to do -a followed by the MAC address of my target. Then we're going to do -c followed by the MAC address of the client that we want to disconnect. So it's this client right here. I'm going to copy, paste it here, And finally, we're gonna give it the name of my wireless adapter in monitor mode, which is mon0. And we are done. Again, I've spent a full lecture on this command explaining what a deauthentication attack is, so if it's a bit confusing, please go back and revise that lecture. Basically, all we're doing is we're using AirPlay-ng to run a deauthentication attack to disconnect this device for a very short period of time. That's why I'm setting this to only number 4. Then I'm using -A to specify the MAC address of my target, -C to specify the MAC address of the client connected to this network, and then I'm giving it my wireless adapter in monitor mode. Now I'm gonna hit enter and keep an eye on this side right here. You'll see the handshake will be captured in here. So we're gonna hit enter, deauthentication packets are being sent, and perfect. As you can see, once the client connected again, we received the handshake. So now we can quit aerodump-ng, so Control-C, because we have the handshake now. It is stored in the file that we set after the right option, which is called WPA handshake. And in the next lecture, I'll show you how this handshake can be used to get the key for the network. From the previous lectures, we learned that when it comes to WPA and WPA2, the only packets that contain some information that can help us with cracking the key are the handshake packets. And in the last lecture, we learned how to capture the handshake and store it in a file. Now, the handshake does not contain any information that can help us to recover or recalculate the WPA key. The information in it can only be used to check whether a password is valid or not. Therefore, what we're going to do is to create a word list, which is basically a big text file that contains a large number of passwords. Then go through this file, go through the passwords one by one, and use them with the handshake in order to check whether this password is valid or not. You can actually download ready word lists from the internet, but in this lecture, I want to teach you how to create your own word list, and in the next lecture, I'm going to explain to you how the word list and the handshake are used in order to recover the password, and we'll see how to do that in practice. So in this lecture, we're going to learn how you create your own word list using a tool called Crunch. This is a really handy skill to have under your belt if you want to be a penetration tester, because you're going to face a lot of scenarios where a word list attack can become very handy. So using the tool is very simple. All you have to do is just put the name of the tool, and then you specify the minimum number of characters for the passwords to be generated. Then we're going to specify the maximum number of characters for the password. Then you specify the characters that you want to generate passwords from. For example, you can put all lowercase characters, all uppercase, you can put numbers, digits, or you can just specify a smaller number to make the word list smaller. You can also use the option T, which is an optional, to give a pattern. So for example, let's say that you were looking at the person while they were typing their password, and you've seen that the password will start with an A. So you can tell Crunch that the password will start with an A, and then give me all possible combination of passwords that start with an A. And after that, we use the -O option to specify the file name where the passwords are going to be stored. So we have a small little example here that will generate a list of passwords that start from 6 characters to 8 characters. And contain these characters right here. So it's going to create combinations of 1, 2, 3, ABC, and the $sign. And it's going to store it in a file called word list. And these passwords are going to start with an A and end with a B. And it will generate passwords based on all possible combinations between the A and the B. So all of the generated passwords will always start with A and end with B. So let's have an example of the tool. Now the tool actually have a lot of options other than what we've seen so far. So if you just type in man crunch, you'll see all the options that you can set, and you'll see detailed description about all of these options. So it's actually really good. You can go ahead and spend some time to get familiar with the tool. Now I'm going to show you the example, and based on the example you'll be able to run all of these commands. But if you want to run or create some advanced word lists, then I highly recommend that you go over this. One of the really cool options that I want to highlight is the -p option. The -p option tells Crunch to generate passwords that don't have repeating characters. For example, when you specify all lowercase characters, you specify A, B, C, D, it will start by generating passwords made of A, and then A, B, 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 and all of that. So when you do this, Crunch will actually ignore these type of passwords, and it will only create passwords that don't have any repeating characters. And that will reduce the size of the word list from the number of characters to the power of the length to the number of characters factorial. If you scroll down, you'll actually see more examples of commands and the type of word lists that will be created. So again, you can have a look on these and get yourself familiar with. Once you're done looking at the man, you can just press Q and you'll be out of it. And we're going to run our command here. So we're going to use Crunch. And I want to generate passwords of minimum of 6 characters and maximum of 8 characters. And I want them to contain combinations of A, B, C. And let's say the digits 1, 2. Now in here you can actually keep listing things. You can list characters, you can list uppercase characters, or even symbols if you wanted to. Once you're done with listing the characters, we're going to specify the file to save it to, and we're going to save it in a file called test.txt. So the command is very simple. It's Crunch, minimum length of the password, the maximum length of the password, followed by the characters that we want to use to generate passwords from, and then O to the file that the passwords are going to be stored in. I'm going to hit enter. And as you can see now, it's telling us that it generated 448,000 passwords approximately, and they're all stored in a file called test.txt. Now, the size of the file is 4 megabytes. And now I can open this file by doing cat test.txt, and as you can see now, we can see all the passwords that have been generated. I'm going to Control-C out of it because it's a huge file, and as you can see, it actually contains all possible combinations of ABC 1, 2. I also want to show you an example of using the -t option. So I'm going to set this to only 6 to 6, so it's only 6 characters, and we're going to use the -t option, which is the pattern option. And I'm going to tell it that I want the password to always start with an A. And then I want you to fill all possible combinations of characters between the A and the B. So I want passwords that start with an A and end with a B. And in the middle, at the @ you can fill all possible combinations of ABC 1, 2. Gonna hit enter. As you can see now, the number of passwords is much less. It's only 625 passwords because I've narrowed down the possibilities of passwords. Again, if I do cat test.txt, you'll see that I have all the passwords right here. So this is it. Tool is really useful, can be used in many scenarios. I highly recommend that you spend some time with it, and also have a look on some of the existing word lists out there on the internet. Now, from the previous lectures, we learned in order to crack WPA or WPA2, we need to first capture the handshake, and second, have a word list which contains a number of passwords that we're going to try, and hopefully one of them will be the password for the target network. So right now I have both of these components, and we are ready to go and crack the password. To do this, aircrackng is going to unpack the handshake and extract the useful information. The MIC right here, or the message integrity code, is what's used by the access point to verify whether a password is correct or not. So it's going to separate this and put it to the side, and then it's going to use all of the other information right here, combined with the first password from the word list to generate an MIC, another message integrity code. And then it's going to compare this MIC to the one that's already in the handshake. If the MIC generated using this information plus the first password is the same, then the password used to generate this MIC is the password for the network. Otherwise, this password is wrong and it'll move to the next password. Again, it'll do the same. It'll use all of this information combined with this password, generate a new MIC, compare this new MIC to the one that's already in the handshake. If it's correct, then this is the password. If it's not, then it's going to move on to the next password. And it'll keep doing this through all of the passwords in my word list. If any of them generates the right MIC, then this is the password for the network. Otherwise, we won't be able to get the password. That's why the success of this attack really depends on your word list. So, let's see how to do this in practice. Right now, I have my word list right here. It's called test.txt. And I've actually manually added my password to the end of the list right here, just so that when I run the word list against the handshake, I will actually find the password, because the word list did not contain my password by default. I also have the handshake file right here, as you can see, and all of this is in my home directory, which is my root directory. So if I do ls in here, you'll see I have the word list and the handshake file. So we're ready to run aircrackng. So we're going to type the name of the program as usual, followed by the name of my capture file, which is wpa-handshake01.cap. So far it's identical to the way that we used to use it with WEP. The only difference right now, because this is a WPA2 network, we have to specify a word list with the -w option. And the name of my word list is test.txt. So very, very simple. Aircrack is the name of my program. wpa-handshake01.cap is the name of the file that contained my handshake. And I'm using -w to specify my word list file. I'm going to hit enter. And as you can see now, aircrackng is running through the word list, testing each word in the word list one by one, as shown in this diagram, calculating an MIC based on this information and the word list, and then if the MIC is correct, it's going to tell me that this is the password. Now, the speed of this depends on your processor and the size of your word list file. So if you have a huge file, obviously it will take you longer time. There are also online services that you can try where you upload the handshake and they have huge word lists and they have supercomputers to run through these word lists and try to give you the password. Unfortunately, I can't share their links with you, but you can easily find them on Google if you search for them. And perfect, as you can see, we managed to find the key. It's telling us the key is found, and this is the key to the network. And this is the correct key because, as you know, this is the same key that we got when we exploited the WPS feature. So now we can go ahead and connect to the network, and we'll be able to run all of the cool stuff that I'm going to teach you in the post-connection attack section. Now, this is the only practical way known so far to crack WPA and WPA2 keys. There are methods to speed up this process, so you can use the GPU for cracking because it's much faster than the CPU. That's if you have a GPU. You can also use rainbow tables. You can also pipe the word list as it's being created in Crunch to aircrackng. This way you can create bigger word lists without using any storage on your computer. There are also methods so that you can pause your cracking process and then come back after a while without losing your progress. But the main idea is the same. The only way right now to crack WPA and WPA2 is through a word list attack. You can use social engineering, however, to get the password using an evil twin attack where you trick one of the users to give you the password. This is actually all covered in my advanced network hacking course. The cracking using the GPU, piping crunch to aircrack NG, getting the password using an evil twin attack, and much more advanced network hacking techniques. If you're interested in that, then I highly recommend you have a look on my advanced network hacking course. Check out the bonus lecture of this course, the last lecture of this course. It contains links to all of my other courses and a comparison between them. So far, we learned a number of techniques that hackers can use to gain access to networks, even if they use WPA and WPA2. If this happens and a hacker manages to gain access to your computer, it's game over. They'll be able to run so much more powerful attacks to spy on every single connected device and potentially even gain full control over these devices. We will be covering all of that in the next section of this course, but before getting to that section, I want to spend one more lecture showing you how to implement the security settings that I recommended in the previous lecture to stop hackers from gaining access to your network and being able to do all of the attacks that I'm going to show you in the next section. So, to implement the changes that we discussed in the previous lecture, we will have to first access the router's settings page. And to do that, you're gonna first need to go to your terminal, and we're gonna run the IP route command. This is a very simple command that will simply show us the default gateways in our current network. So as you can see, the first default gateway is 10.0.2.1. This is the one for ETH0, and the default gateway is basically the router because as we know, the router is used as the default gateway to the internet. So this is the default gateway for the virtual NAT network that this machine is configured to connect to. And below it, we can see the default gateway for the real Wi-Fi network that LAN 0 is connected to. It's saying that the default gateway for LAN 0 is this specific IP address. Now, for you to see this, obviously LAN 0 needs to be connected to your wireless network. So if I look here on my networks on the Wi-Fi and select network, you'll see that I'm actually connected to this network, which is my current Wi-Fi network. Now, if you're being de-authenticated and you're not able to connect to your own network using Wi-Fi, then you can connect to your network using an Ethernet cable. That way, the de-authentication attack will not work against you, and you'll still be able to see the default gateway IP in here and use it to access the router settings and modify them to improve your security. Once you see the default gateway, this is the IP of your router, and this is the IP that we're going to use to access the router's settings page to modify its settings. So I'm going to copy this, and I'm going to go to my web browser, and we're simply going to put it in the address bar and navigate to it. It's going to ask you for a username and a password. Now, in many cases, you'll find this written under the router or at the back of the router on a sticker. If you can't find it there, then look at the manual for the default password. A lot of the time it's admin, or it could be the actual network key, the default network key. So I already have my password copied in my clipboard, and I'm just going to paste it here and log in. And as you can see, we have access now to the router settings page. In this control panel, you can modify any setting that is related to the router. Keep in mind that your control panel might look different. This control panel looks different depending on the router that you have, but the settings that we want to modify are the same. So you're just going to have to look through it, through the different tabs or the different layout that you have to find the settings that I'm going to modify. Now, as you know, the main thing that we want to modify is the Wi-Fi settings. So in my case, I have it in here under this cog on the right. In your case, it might be in a different tab or in a different window or in a drop-down menu. You just want to make sure you find the Wi-Fi settings. So I'm just going to click on it in here. So in the basic settings in here, you can see you have the different bands that the router is running on. That's okay. You can see we have the network name, so you can modify it from here. You can see that it is set to visible, so you can untick this box to make the network invisible so it doesn't broadcast its name. The main thing that we want to modify in here is the security, and you can see in my case it's already set to WPA2 personal. So make sure you're using WPA2 for maximum security, and you want to make sure, as mentioned in the previous lecture, that you use a long password that is made of small and capital letters, special characters and numbers, and make it at least 14 characters. That way it's very difficult to crack. Once you're done with your settings, you can click on apply to apply the settings, but in my case I haven't changed anything, so that's fine. The next thing we want to do, as you remember, we were able to crack networks regardless of what key they used, even if the key was complex, if WPS PIN authentication was enabled. So you're gonna need to find where your WPS settings are. In my case it's in here in a different tab. We're gonna click on it and we're gonna make sure that it is disabled. So in here, as you can see, WPS is on in my case. So I'm going to click on it one click to disable it. And we're going to click on apply to apply the changes. In some routers, this will disable it for both bands. In my case, I need to manually also go to the settings of the 5 GHz by clicking in here and disable it manually for that. I got disconnected for a bit of time because when you change settings within the router, it'll need to restart. So you need to give it some time once you click on apply or save for the router to restart with the new settings. We're going to refresh now just to see if we have it back. As you can see, we still don't have it back. So we need to give it a bit of time. Okay, so I'm being asked to log in again because the router restarted. And we're going to go back to the Wi-Fi settings, WPS. And as you can see, it's off now. So we also want to go to the 5 GHz. And we want to make sure it's off as well. You might not have to do this on your router, but in my case, I have to do it manually for the 5 GHz and for the 2.4 GHz. Another feature that you might find useful is the MAC filtering or access control. You might find it under different names. This allows us to define a list of MAC addresses that can connect or should be disconnected from the network. So from here, you can select to create an allow or a deny list. So if we go on the allow list, we're going to be specifying the MAC addresses that are allowed to connect to the network. All you have to do is simply put the MAC address here, add it and save it, and then only the specified MAC addresses will be allowed to connect to the network. So that's pretty much it. You just want to make sure that you're using WPA2, disable WPS, and use a long password made up of small letters, capital letters, numbers, and special characters. You can also use the access control or MAC filtering to prevent or allow certain MAC addresses. Also, keep in mind, if you were being de-authenticated from your own network, so if you're not able to connect to your own network using the Wi-Fi settings in here through Wi-Fi, then you can connect to the router using an Ethernet cable, and that way the de-authentication attack will not work against you. Then you'll be able to come in here, modify the network settings to prevent the attacker from launching attacks against you without being de-authenticated. In this section, we're going to talk about post-connection attacks, so attacks that you can do after connecting to your target network. Now, it doesn't matter whether the target network is a Wi-Fi network or a wired or an Ethernet network. It really doesn't matter. As long as you gained access to this network, as long as you're able to connect to it, you'll be able to do all of the attacks that I'm going to show you in this section. Now you'll notice once connected, you can do so many cool things. So you'll be able to gather detailed information about all of the clients connected to the same network. You'll also be able to intercept data and see any usernames, passwords, or any information they use on the internet. You'll be able to modify data as it's being sent in the air. So you'll be able to inject evil code and do so many cool things on the network. Now, to do all of the attacks that I'm going to show you in here, you have two options. The first option is to run the attacks against the virtual NAT network against the Windows machine. You just need to make sure that the virtual Windows machine is connected to the same NAT network as the Kali machine. Or you can run the attacks against real computers connected to your real Wi-Fi network, and you need to make sure that you have a wireless interface connected to the Kali machine, and the Kali machine needs to be connected to your target Wi-Fi network. Now, throughout this section, I'm actually going to be using both options. So I'm going to be running some attacks against the Wi-Fi network, and I'll be running some against my virtual NAT network, just to make sure that you're comfortable with running all of these attacks in different environments and in different networks. Because like I said, it doesn't really matter how you gained your access to the network. The network type doesn't really matter either, as long as you are able to connect to the target network. Now, to practice some of the attacks that we're going to learn in the future lectures, you need to have a target machine or a victim machine. So this is a computer that you're going to target and try to hack and test the attacks that we're going to learn against. So you can do this against any machine, but I highly recommend installing target machines as virtual machines. This is great because it won't break a real computer for you if you actually break something. It's also very easy to fix. Even if you have a computer that you don't care about, it's very easy to fix virtual machines. You can just remove it and reinstall it, or store a snapshot and go back to it. Now, as we all know, Windows is a very common operating system. It's used by a lot of people. So in this lecture, I'm going to show you how to install Windows 10 as a virtual machine so that we can test some of the attacks that we're going to learn in the future against it. So we'll target this machine when we want to test attacks against Windows or a target user that uses Windows. Now, Microsoft has released ready virtual images for people to test Windows, so we can actually download a virtual image of Windows for free from Microsoft. I'm going to include the download links in the resources of this lecture, but I have the page opened here. So the first thing you want to do is select the type of virtual machine that you want to download. As I said, we want to download Windows 10, so we're selecting MS Edge on Windows 10. Next, we need to choose the virtualization platform, and we're using VMware. That's why we're selecting VMware, but you have other options if you're using other virtualization software. Once you select VMware, you're going to see a download button in here. Clicking that will download a zip archive that contains the virtual image for Windows 10. Now, I've already done that, and I already have it in here in my downloads. As you can see, we have it here, MS Edge Windows 10 VMware. And as you can see from the icon, this is a zip archive. Therefore, in order to use the contents inside it, we have to uncompress this file. So to do that on Windows, simply we're going to have to double click it, copy the content, go back one directory and paste it here. We're going to give it some time to uncompress the content. On Mac, you can do the same. Simply double clicking it will uncompress the content. And on Linux, you'll have to right click and click on extract here. Now I'm doing these steps from a Windows host computer, but you should be able to follow them on Apple, Mac OS and Linux because we are essentially using the same virtualization software, which is VMware. Once this is done, we're going to have another directory in here with the contents of the virtual Windows image. To import this to VMware, we're going to first of all run VMware. We're going to click on Open Virtual Machine or go to Player, File, Open. We're going to navigate to the location where we have this file in here. So it's going to be in my downloads, in MS Edge Windows 10 VMware. And we're going to select the only file that we can actually select from the list. We're going to click on Open, and we can set the name of the machine in here. So for example, I can set it to Windows 10. You can change the path where it's going to be stored, but we're going to keep that the same. And we're going to click on Import to import it. You're going to have to give it a bit of time to import this machine into VMware. And perfect, as you can see now, it's imported in here. And as usual, we can simply start it by clicking on the green play button. But before doing that, I actually want to modify the amount of memory it has. So we're going to right click and go to settings. And as you can see, by default, it's set to have 4 GB of memory. I think that's a little bit too much. It doesn't need that much. So we're going to set that to 2 by dragging the slider down to 2. We're going to click on OK and start it by clicking on the green play button. And perfect. As you can see, now the machine started. We're going to click inside and click again to log in. The default password in here is capital P A S S W 0 or D exclamation mark. I'm going to hit enter. And here we go. We have a fully working virtual Windows 10 computer installed inside our main machine. And we did that so we can test attacks against this virtual machine without affecting our host computer. Now we can go in full screen by clicking here and going into full screen. The screen should automatically resize. If it doesn't, right click, display settings, and you can set it to the right resolution for your screen. I'm going to set it to 3840 by 2160 because I have a 4K screen. You can see that the icons are actually really small because I have such a high resolution screen. In your case, you'll only face this issue if you have a 4K screen. So you'll also probably need to set the scaling in here to 200. And as you can see now, the icon size has changed to the normal size. Now, if you face any other issues, check out the featured questions. And if you don't find an answer, feel free to ask us and we will respond to you within a maximum of 15 hours. Information gathering is one of the most important steps when it comes to hacking or penetration testing. If you think of it, you can't really gain access to a system if you don't have enough information about it. So for example, let's say you're connected to a network and one of the devices connected to this network is your target. Now for you to hack into that target, first you need to discover all of the connected clients to this network, get their MAC address, their IP address, and then from there try to maybe gather more information or run some attacks in order to gain access to your target. Now, there are a number of programs that will do this for you. Examples are NetDiscover and Nmap, which do this job really well. So in this lecture, we'll start with the simpler one, which is NetDiscover, and see how to use it to quickly map the network we're connected to. And in the next lecture, I'm going to show you how to use Nmap to gather detailed information about all of the clients connected to the same network. So I have my Kali terminal in here, and if I do ifconfig, you'll see I have ETH0, it has an IP address, and like I said, this is the virtual interface created by VirtualBox when we set the Kali machine to use a NAT network. Now, I also said that this NAT network behaves exactly like an Ethernet network, and as far as the Kali machine is concerned, it thinks that it is connected to a real wired network. And as you can see in here, it's telling me that wired connected. Now, I have my virtual Windows machine right here. It is configured to use the same NAT network as the Kali machine. Remember, we're still in the network hacking section, so both you and the target machine need to be connected to the same network. So as far as these two computers are concerned, they think that they are connected to the same network. So what I want to do right now is use NetDiscover and see how we can use it to discover all devices connected to the same network. Now, the method that I'm going to show you will work exactly the same whether you're using it against a virtual network like I'm doing right now or against real network, and even if your target is a Wi-Fi or a wireless network. So all you have to do is type the name of the program, which is NetDiscover, and then type -R to specify an IP range to search for. This needs to be a range that can be accessed by you. So right now you can see that my IP is 10.0.2.16, and I can only access IPs on the same subnet. So IPs on the same subnet start at 10.0.2.0 and they would end at 10.0.2.254 because 254 is the last IP that a client can have. So my range is going to be 10.0.2.1 and I want to search for clients that might have an IP of 10.0.2.1, 10.0.2.2, 10.0.2.3, all the way up to 10.0.2.254. So instead of manually typing all of these IPs, I can just type over 24 and NetDiscover will automatically know that I'm trying to search for all of the IPs that start at 10.0.2.1 and end at 10.0.2.254. So this is a way of specifying an IP range for the whole subnet. So if I hit enter now, you'll see that NetDiscover will show me all the IPs of the devices connected to the same network, and note that the first three parts of the IPs are always the same because they are on the same subnet. And I also have the MAC addresses of these clients, and NetDiscover is also attempting to guess the device vendor. Now if I press Q, this will quit the program, and right now we have a list of all the connected clients to the same network. Now, like I said, you can also use this method to discover clients connected to the same Wi-Fi network. The only thing is, right now, if I do ifconfig, you can see that my Kali machine does not have a wireless adapter. It's not connected to a Wi-Fi network. And like I said before, you cannot access the built-in wireless card from a virtual machine. Therefore, if you want to do this or run any of the wireless attacks that we're going to see in the future against a real computer and a real wireless network, you're going to need to use a wireless adapter. Now, I'm going to include links in the description that will help you pick a good adapter that works with Kali Linux. But right now I actually have one, and I'm just going to connect it and use it just to prove to you if things work on the virtual machines connected to the virtual network, they will work exactly the same against a real network with real machines. So I'm going to connect my adapter now, and if I do ifconfig, it's still not showing up. Let's see if it shows up now. Perfect. As you can see, I have an adapter now called LAN 0. And what I'm going to do is I need to connect this adapter to a Wi-Fi network first before I can discover all the connected clients to this network. So I'm going to go to my network manager. I'm going to click in here, and you want to click on select network. And as you can see, automatically now it actually connected to a network. But in your case, you'd want to select a network and click on connect, and then it will ask you for the password. So now I'm actually connected, and you'll see if I do ifconfig again, right now LAN 0 has an IP address. So this means that it is connected to a network, and this means that we can use it now with NetDiscover. So again, I'm going to use the exact same command that I used before just to show you and prove to you that if this works against virtual machines, it will work against real machines. And the only difference is going to be the IP. So I'm going to remove this IP. And as you can see right now, my IP is 192.168.1.8. So therefore, the range that I'm going to look for is going to start at 192.168.1.1. And I'm going to leave the over 24 here because this will tell NetDiscover that I want to start at 192.168.1.1 and finish at 192.168.254. So if I hit enter now, as you can see, it's discovering all the connected clients, all their IP addresses, all their MAC addresses, and it's guessing the manufacturer. And you can see it's also discovering some Apple devices here. So as you can see, it's working perfectly using the exact same command. Now, I only did this just to show you that if things work against virtual machines and against virtual networks, then they will work against real machines, because these virtual machines and virtual networks are modeled over real machines. And as far as the machines are concerned, they actually think they are real computers and real machines. The second program that we'll use for network mapping is Nmap. Now, in the previous lecture, we used NetDiscover, and we've seen how nice it is to quickly discover all the devices connected to our network, see their MAC address, and maybe get the vendor. Nmap takes scanning to a whole new level. It might be a little bit slower than NetDiscover, but it will show you much more information about the target. So you'll be able to see the open ports, you'll be able to see the running programs or the running services on these open ports. You'll be able to determine the computer name, the operating system running on that computer. If you're in a network, you'll be able to discover all of the connected clients. You'll be able to bypass security, bypass firewalls, and so much more. Nmap is actually a huge tool, and there are books and complete courses done just to teach Nmap. The Nmap book would actually be a really good read once you're done with this course. Now, because this tool is huge, we're not going to be able to cover all of its uses, but in this lecture, I'm going to show you the basics of this tool, how to use it to discover all the connected clients and see useful information about them, and we'll actually use it more when we get to the gaining access section. We're actually going to be using ZenMap, which is the graphical user interface of Nmap. So to run it in terminal, you just have to type ZenMap, or you can find it under your applications menu. Now, as you can see, it has a very simple interface. The first thing that we see is the target input box. In here, you can put your target. You can scan any IP that you can reach, whether it's a personal computer, whether it's a server, whether it's an IP for a web server, for a website, for example, that you want to discover all the open ports and all the running services on it. Or, like what we're going to do right now, we can put a range similar to what we did with NetDiscover, and it'll scan this whole range, discover all the live IPs, all the IPs of the connected machines on the same network, and display information about them. Now we'll have a look on how to scan servers in the gaining access section. So for now, since we are still in the network hacking section, we're gonna put a range to discover all the connected clients and see useful information about them. So right now I'm actually connected to my wireless network. That's why I'm gonna specify the whole range on that network, and we've seen how to get that in the previous lecture. So it's 192.168.1.1 over 24. At the bottom, you can see the command. This is actually the Nmap command that will be executed when I hit the scan button. So like I said, ZenMap, what we're using right now, is just a graphical interface that will run this Nmap command in the background and show me the results. So if you know a custom Nmap command, you can put it here, or if you just want to see Nmap in terminal, you can literally copy this command, paste it in terminal, and it'll give you the same results that you would get if you run it here. Alternatively, if you don't really know much about Nmap and its commands, you can use one of the ready profiles in here. So in this lecture, we're actually going to be using a number of these profiles, and we'll see the difference between them in terms of speed and the information gathered. So I'm going to start with the ping scan. This is a very quick scan. It literally just pings every possible IP in the range, and if it gets a response, it'll record this response and it'll show me the devices that gave me a response, which means that these are the devices connected to the network. Now, a lot of devices do not respond to ping requests even if they are alive, so the list that you'll get in this scan might not include all the devices connected to your network. Now, once the scan is done, as you can see, we can see the list of all the connected devices in here. And in here, we can also see the MAC addresses for each of these devices. We also can see the vendor. So for example, we can see that the device at 192.168.1.1 is a Cisco device. This is actually my router. and it is made by Cisco, so this is correct. So we can go ahead and start looking for exploits in this device. We can also see the 192.168.110 is a HTC device, and again, this is a HTC phone, this is correct. And since it's HTC, then we know that it's probably running on Android. So as you can see, we're getting more information about the connected clients. Again, we can see the 192.168.112 is an Apple device. So it could be a phone, a tablet, or a Mac. We can see the next device is a Dell. So again, it was a very quick scan, but as you can see, it still gave us much more information than what we got from NetDiscover. The next scan that I want to show you is the quick scan. Now this is going to be slightly slower than the pink scan, but it's going to show us more information. So right now you can see that the scan is showing us the same information that we've seen before with the pink scan, but it's also showing us the open ports on each one of the discovered devices. So it's able to discover the following ports in the router, and we can see that port 80 is open. This is actually the port used for the router settings page because it runs on a web server, so this is correct. Again, we have our Apple device here that we said it might be a phone or a computer or a tablet, but we can see now it has port 22 open, so this is a port for a service called SSH, which is designed to allow remote access to the system it's running on. Again, if you go on all the other devices, you can see all the open ports and the services running on each one of these ports. Now, in the next lecture, we'll build up on this. We'll see how to gather even more information, and you'll see how important information gathering is because we're going to use the gathered information to hack into an iPhone that is connected to the same network. Now, in the previous lecture, we had a quick look on ZenMap and how it can be used to gather information. So in this lecture, we'll build up on that. And the main scan that I want to show you right now is the Quick Scan Plus. This scan takes the Quick Scan one step further. So first of all, it'll be slower, but it's going to show us even more information. So first, we're going to be able to see the operating system running on the discovered devices. We will also be able to see the device type, whether it's a phone or a laptop or a router. And we'll be able to discover the program and the program version running on the discovered ports. So before, for example, we were able to discover port 80 is open, but we didn't know what program is running on this port or what version of this program. Getting the exact program version is really helpful when we get to the gaining access section, and you'll see then how we can use that to exploit vulnerable services and gain full control over the computers that have these services installed. Now, straight away, when you look at the results, you'll see that we got much more information than all of the scans we ran so far. So the first thing you'll notice is the icons beside the IPs of the discovered devices. These icons represent the operating system running on these devices. So right now we have the operating system for all of the connected devices. And now it's showing us the programs running on each of the discovered ports and the versions of these programs. So for example, if we look at the 192.168.112, the Apple device, on the last scan, we knew that port 22 open and we knew that SSH is running on it, but we didn't know what version of SSH was running. Right now we can see that it's running Open SSH version 6.1. So we can go on Google and look for exploits and vulnerabilities in this specific version, and we might actually find something. We'll actually talk more about that in the gaining access section. Now, if you look at the device type, you can see that it's a media device, it's a phone. So before, we knew this is an Apple device, but we didn't know whether it's a tablet, a phone, or a MacBook. Right now, we know that it is a phone. It's also discovering that it's running Apple iOS 4, 5, or 6. Now it's actually running a newer version of iOS. I'm not entirely sure. I think 9 or 10, but still it's close enough. It's telling me that it's an Apple. It's telling me that it's a phone, it's running iOS, so this is really, really good. Now if we go to the next device here, the 192.168.120, this is a Linux device, and when we ran the quick scan, we were able to identify port 80 and port 49152 open, but again, we didn't know the program running or the service version running on this port. So right now we know it's Apache HTTPD 2.2.22. It's running on Ubuntu. So again, now we have the operating system, the exact version of the service running, so we can go and look for weaknesses and exploits in this specific version. And this port, we didn't even know what service was running on it. Right now we know it's a UPnP service, and the server is MediaTom UPnP. We have the exact version again. So again, we can go ahead and look for exploits in these specific versions, and if we discover any, we'll be able to gain full control on this computer. Again, if we go down to the 192.168.122 machine, we can see that it's running a Microsoft HTTP API on port 5357. You can also browse by the services. So from here on the left, if you click on services, you'll be able to categorize the discovered clients based on the services. So if we click on HTTP, we'll see all the clients that have a HTTP service running. If you click on SSH, we can see the Apple device here. It's the only device that has a SSH service running. So let me actually show you a quick and fun example. If we go back here to the hosts and go back to the Apple device, the 192.168.112, as I said, we know it's a phone, we know it's an Apple phone, we know that it has an SSH service installed on it, running on port 22, and we know that SSH is a service that allows you to remotely execute system commands on the computer that has the SSH service installed. Now, obviously, before you can use this service, you have to use a username and a password. Once you authenticate, it'll allow you to execute system commands remotely on that computer or on that phone. Now, by default, iOS devices do not have an SSH server. Usually, when you jailbreak the phone or the device, it'll automatically install an SSH server, and the password for that server is set to Alpine by default. That's ALPINE. Now, since we know that this is an iPhone and it has port 22 open with open SSH server, we know that this phone has been jailbroken. Now, since the phone is jailbroken, we know the password to log into SSH is Alpine unless the user changed it. Now, most users do not even know about this, and even the ones that know about this, like myself, are too lazy to change it. So it's always worth a try if you discover a phone like this in the same network. It's always worth a try to go and try to connect to it with the default password. So I'm just going to go to my terminal, and I'm going to try to connect to this phone using SSH. So I'm going to type SSH root, which is the username for the admin in Linux, at 192.168.112. This is the IP of the phone. I'm going to hit enter. It's asking me if I should trust this connection. I'm going to say yes. And now it's asking me for the password. And like I said, when the phone is jailbroken, the password is set to Alpine. So I'm going to type ALPINE. I'm going to hit enter. And as you can see, I logged in as root. So right now I have the highest privileges on the phone, and I can do whatever I want on the system. And now we can use system commands to completely control the phone. Now this is a little bit ahead of time. We are still in the network hacking section. So don't worry too much about this. We'll talk more about it in the gaining access section, but it's just a quick example that I wanted to show you of how powerful information gathering is, because we literally did not exploit anything right here. We just relied on the information we gathered, and we were able to hack an iPhone that is connected to the same network as us. Now, like I said, Nmap is a huge tool. I highly recommend you go ahead and try the other profiles in here. And like I said, once done with the course, I think the Nmap book would be a really, really good read. We'll also use Nmap much more in the gaining access section, and we'll see how we can use this information to gain full control over the computers using code execution vulnerabilities and so on. But in this lecture, I just wanted to give you a quick overview, and we'll build up on this as we go through the course. Now, in this lecture and the next few lectures, I want to start talking about man-in-the-middle attacks. These are attacks that we can launch only if we are able to intercept the communication between two devices. Hence the name man-in-the-middle attacks. So a normal communication would look like this, where the device is directly communicating with the entity that they want to communicate with. In a man-in-the-middle attack, the hacker would be able to place themselves in the middle of the connection, allowing them to intercept and see anything that is being transferred between the two devices. Now, there are a number of ways to achieve this. The first method that we'll cover in this course is using an ARP spoofing attack. ARP spoofing allows us to redirect the flow of packets, so instead of it flowing as shown in this diagram, it would flow through my own computer. So any requests sent and any responses received by the target computer will have to flow through the hacker computer. This means that any messages, any websites, any images, any usernames, any passwords entered by the target will have to flow through my computer. This allows me to read this information, modify it, or drop it. So as you can see, this is a very serious and very powerful attack. And the reason why it is possible is because ARP is not very secure. Now, for us to understand how this works, you need to have a basic understanding of what ARP is. ARP stands for Address Resolution Protocol, and it's a very simple protocol that allows us to link IP addresses to MAC addresses. So, for example, let's say we have a network here. We have devices A, B, C, and D. They're all connected to the same network. And we have the router here for this network. We can see that each device has an IP and a MAC address. And let's assume that device A needs to communicate with device C. Now we're also going to assume that device A knows the IP of device C, but as we know so far, in order for these devices to communicate within the same network, device A needs to know the MAC address of device C, because like we said before, the communication inside the network is carried out using the MAC address and not using the IP address. So this is a perfectly normal situation where we have a client that needs to know the MAC address of another client so that it can communicate with this client. So what this client does, it uses the ARP protocol. What do I mean by that? Basically, it sends a broadcast message. So it sends an ARP request to all the clients on the network saying, who has 10026? Now, all of these devices will ignore this packet except the one that has this IP address, which is 10026, which is device C. So all devices will not do anything, and the only device that will respond is device C, sending an ARP response. In this response, device C is gonna say, I have 10026, my MAC address is this MAC address. This way, device A will have the MAC address of device C, and now it will be able to communicate with device C and do whatever task that it wanted to do initially. So all of this communication is facilitated using the ARP protocol. Like I said, the ARP protocol is a very simple protocol. As you can see, all it has is requests and responses, and the whole point of it is so that we can link IP addresses to MAC addresses or translate IP addresses to MAC addresses. So a device can send a request asking for a MAC address, and then the device that has the MAC address would respond with its MAC address. So each computer have an ARP table which links IP addresses on the same network to their MAC addresses. So if I go on the Kali machine and do ARPA, you can see my ARP table here, and as you can see, it's linking the router's IP to the router's MAC address. Now same if I go to the Windows machine and run my CMD and do ARPA, you'll see again it's linking the router's IP to its MAC address. So this machine, anytime it needs to send any request to the internet, it will direct that request to this MAC address, to the MAC address that's associated with the IP of the router, which is 10.0.2.1. Now, this value in here can be easily modified by exploiting the ARP protocol. So let me go back to my diagrams. And right here we have a diagram of a typical network. And you can see that normally any device that's connected to the network, if it wants to send requests, it will send them to the router. The router will go and send that request to the internet, wait for the response, and then forward the response to the device that requested it. So if the hacker or the victim or any other computer on the network wanted to send a request, they will send that request directly to the router. Now what we can do is we can exploit the ARP protocol and send two ARP responses, one to the gateway and one to the victim. We're gonna tell the gateway that I am at the IP of the victim. So the access point will update its ARP table and it will associate the IP of the target with my MAC address. We'll do the same with the victim, so we'll send it an ARP response. We're gonna tell it that I am at 10.0.2.1. So it's going to update its ARP table and associate the IP of 10.0.2.1 with my own MAC address. So the result of this, the victim is gonna think that I am the router, and the router is gonna think that I am the victim. So anytime the victim wants to send any requests, the requests will have to flow through my computer, and I'm gonna forward them to the router. And then anytime the access point or the router wants to send responses, they're gonna go to my machine because it thinks that I am the victim, and then I'm going to forward it to the victim. So as you can see, this puts me in the middle of the connection and it gives me so much power, and we'll see all the things that we can do once we become the man in the middle. Now the main reason why we can do all of this is because ARP is not secure. Because first of all, clients can accept responses even if they did not send a request. So as I said before, we're gonna send a response to the access point and a response to the victim, telling them that I am at a specific IP, without them asking who am I, or without them asking for this IP. I'm just gonna send a response and they're gonna accept that response anyway. Not only that, but they're also not going to verify who I am. So when I say that I am at 10.0.2.7, I am clearly not at that IP because this computer is at this IP. But the access point will trust this and it'll actually update its ARP table based on the information that I send. Same goes to the victim. I'm gonna tell it that I am at 10.0.2.1. It's gonna trust and believe this, even though I am clearly not at this IP because the access point is at this IP. So these are the two main weaknesses with ARP protocol that allow us to run ARP spoofing attacks. Now that we know how ARP spoofing works, let's see how we can run this attack and redirect the flow of data so it flows through our device. This will allow us to intercept data and see everything sent to and from a target computer, including usernames, passwords, and so on. Now there are a number of tools that can be used to run an ARP spoofing attack. You can even build your own tool, and I cover this in my Python programming course. But in this lecture, I want to show you how to use a very simple yet reliable tool called ARP spoof. Then, in the next lectures, we'll use a tool called BetterCap because it has more features. Basically, the main reason why I want to cover ARP spoof in this lecture because it is a very simple tool, but it's very reliable. It's also ported to many operating systems, including iOS and Android. Therefore, if you learn how to use it here, you'll be able to use this tool on all of the other operating systems. So, you can only use this tool to redirect the flow of data and make it flow through your computer. And then you'll have to use another tool like a packet sniffer like Wireshark to analyze this data and do more stuff with it. And we'll cover all of this later on in the course. Now, using ARP spoof is very simple. First, we're going to have to type its name, so it's ARP spoof. Then we're going to do -I to specify the interface that is connected to the target network. And in my case, it's ETH0 because that's the interface that's connected to the network. So if I do ifconfig, you'll see ETH0 is the interface that's connected. Now, as you can see, I'm going to be running this attack against my virtual NAT network. You can run this attack against any type of network, even Wi-Fi networks, and I will cover that later on in the course. But for now, just until you properly understand how this works, I highly recommend you do like I'm doing right now and test the attack against the virtual NAT network. So all you'll have to do is make sure the Kali machine and the target Windows machine are both configured to use the same NAT network. So we're going to do -T to specify the target, and my target is at 10.0.2.7. As you can see in here, that's the IP of my target. And I'm going to have to give it the IP of the gateway, which is at 10.0.2.1, as you can see in here. Now this will spoof the target, telling him that I am the router. We'll also need to run this command once more in here. So I'm going to clear the screen. And again, I'm going to do ARP spoof IETH0. And the target this time is going to be 10.0.2.1 and 10.0.2.7. So right now we're going to be telling the router that I am the victim. So the first one will fool the victim, the second one will fool the router. Now keep in mind, this attack will work against both Ethernet and Wi-Fi or wireless networks. I'm running it right now against the virtual network, which acts as an Ethernet or a wired network, but the attack can be executed exactly the same against wireless networks. All you have to do is connect a wireless adapter to the Kali machine, connect the adapter to the target network, and use it. So the same concept as the network scanner applies. You need to have a wireless adapter that works well with Kali, and you need to have that adapter connected to Kali and connected to the target network. So I'm going to hit enter here, and I'm going to hit enter here. And now if we go to the target machine and run the same command, ARPA, you're going to see that the MAC address now for the router is different than what it was. And this is actually the MAC address of the Kali machine. So right now, this Windows machine thinks the router is at this MAC address, and every time it needs to send requests, it will send it to this MAC address, which means that they will be sent to this computer right here. Now, this computer is not a router, so when it gets requests, it's actually going to stop them from flowing and going to the router. This is a security feature in Linux. So you need to enable port forwarding so that this computer would allow packets to flow through it just like a router. Now to enable port forwarding, we're going to do echo 1 to proc sysnet IP version 4 IP forward. And as you can see, this command gets executed with no issues. And right now, this computer will still have its internet access, so we can go and browse any website we want. But all these requests are not going directly to the router, but they are going to this computer first, and then this computer is forwarding them to the router as shown in this diagram, and then when the responses come back, they're gonna go to the hacker first, and then they go to the victim. So, as you can see, a very simple tool. It allows us to redirect the flow of data so it flows through our computer, allowing us to become the man in the middle. And once we're the man in the middle, we can inject code in the browser of the target. We can steal usernames, passwords, see all the information that the person sends and receives, replace downloaded files with Trojans, and much more. Previously, we learned what ARP spoofing is and how to use it to intercept connections in our network using a tool called ARP spoof. I covered this tool because it is simple, reliable, and available for a number of operating systems. Therefore, learning how to use this tool can be useful in so many scenarios. However, in this lecture and in the next lectures, we're going to be using a tool called BetterCap. BetterCap can be used to do exactly what we did with ARP spoof. So we can use it to run an ARP spoofing attack to intercept connections. And it can be used to do so much more. So we can use it to capture data and analyze it and see usernames and passwords. We can use it to bypass HTTPS and potentially bypass HSTS. We can use it to do DNS spoofing, inject code in the loaded pages, and so much more. For now though, I'm going to show you how to install the tool and give you a quick overview on how to use it, and we'll go over all of that in the next lectures. So I'm going to go to my Kali machine here, and to run BetterCap, all I have to do now is just type its name, BetterCap. Now, as usual, if you want to get more information on this command and how to use it, you can do --help, and this will give you a complete help menu. But you don't really need to worry about this now because we will be using the tool a lot throughout the course and you will learn a lot as you use it. So I'm going to clear the screen again. And to run the tool now, I'm going to type BetterCap, the name of the tool, followed by -iface to specify the interface that is connected to the network that I want to run the attacks against. And as you know, to get my interface, we can just do ifconfig. And I'm going to be running this against my NAT network, which is ETH0 is connected to. So I'm going to set my interface to ETH0. I'm going to close this. And I'm going to hit enter to run the tool. And as you can see now, we're inside the tool. We have a different prompt now in which we can use the commands of BetterCap. Now, as you can see here, it's telling us that we can type help to get a list of all of the commands that we can use with BetterCap. And since we don't know how to use it, I'm actually gonna type help. And perfect. As you can see, we get a full list of all of the commands that we can use. Again, I'm going to use it with you now as we go through the course, so you can have a quick look on them, but don't worry too much about them. What's really important and you need to pay attention to right now is the modules. So these are all of the modules that we can use, or all of the things that we can get BetterCap to do. And as you can see right now, none of them is working except for the event stream, which is basically the module that runs in the background to handle all the events. Now, you can type help followed by the name of any module you want. And this will show you a help menu that shows you how to use this specific module. For example, I want to show you in this lecture the net.probe and the net.recon modules. So, since I don't know how to use them, I've typed help and I'm going to follow it by the name of the module, which is net.probe. I'm going to hit enter, and as you can see, you'll get a description of what this module does. So basically, it keeps sending UDP packets to discover devices on the same network, and we can do net probe on to turn on the module and net.probe off to turn it off. You can also see all the options that you can modify for this module, and I'm gonna talk about options and how to modify them in the next lecture. So for now, I'm gonna keep all these to the default option, and I'm just gonna do net.probe on to turn it on. And as you can see, this will automatically start discovering clients connected to the same network. So the 10027 right here is actually my Windows target machine. So if I go to the target Windows machine right here and do ipconfig, you'll see its IP address is 10027. So this is just another way of discovering connected clients quickly using BetterCap. And what you didn't notice right now is when we started the net.probe, it automatically started the net.recon. To confirm this, so if we go up right here, you can see the only module that was running is the events.stream. And now, if I do help, you'll see I actually have two modules running, the net.probe, which we just saw and we turned on manually, and the net.recon, which got turned on automatically by BetterCap. The reason for this is because the net.probe sends probe requests to all possible IPs, and then if we get a response, the net.recon will be the one detecting this response by monitoring my ARP cache and then adding all of these IPs in a nice list so we can target them. So now, because the net.recon is actually running, we can do net.show to see all of the connected clients. And as you can see, we get a nice list of all of the connected clients. We can see their IPs. We can see the corresponding MAC addresses for these clients. And it can also show you information right here about each one of these IPs. For example, it's telling us that this IP right here is the IP for ETH0. So this is the IP of this computer. It's also telling us that this IP right here is the gateway. This is the IP of the router. And you can also see at the vendor in here, it's attempting to discover the manufacturer of the hardware used in each of these clients. So as you can see for the gateway, it thinks that it uses a Realtek chipset. Now you can also see here the 10.0.2.7 device. Like I said, this is my target Windows device right here. So that's it for this lecture. I just wanted to give you a quick overview on how to get help about a specific module, how to run a specific module, and analyze the results that it returns. And in the next lecture, I'm going to show you how we can run an ARP spoofing attack using BetterCap to intercept the data and read usernames and passwords that flow through the network once we become the man in the middle, once we intercept the connection. Now, in this lecture, I want to show you how to run an ARP spoofing attack using BetterCap. This will allow us to place our computer in the middle of the connection and intercept data. Not only that, but we're also going to see how we can read this data so we can see all the URLs and all the websites that the target visits, and we'll see everything that they post. So anything, any usernames, any passwords they send to any websites, we're going to be able to capture them and see them. So first, we need to become the man in the middle, and we're going to do this using a module called ARP Spoof. So if I scroll up to the help menu, you can see we have a module here called ARP Spoof. So as usual, if we don't know how to use this module, we're going to do help arp.spoof because we want to see how to use this module and see all the options that we can set for it. So as you can see, as usual, we can do ARP spoof on to turn this module on. we can do ARP.ban on, and this will literally just cut the connection of the target. This is very simple. You can try it on your own time. I'm not going to do it here. You can do ARP spoof off to turn it off, and ARP.ban off to turn the ban off. Now, in the previous lecture, I also said anything you see under the parameters are the options that we can set for this specific module, but I didn't show you how to modify that. So in this lecture, we're actually going to be modifying some of these options. Now, as you can see, the tool is actually very helpful because first of all, it's giving us the option name in yellow here. So these are the options that we can set, that we can change. And then it's also telling us a description of what this option does and the default value. So for example, we can see we have an option called arp.spoof.fullduplex. You can see the description for this option, and basically what this option will do, if you set it to true, it will spoof both the router and the target. So it's similar to what we did with ARP spoof when we executed the command twice to spoof both the router and the target. So if you set this to true, both the router and the target will be spoofed and you will be in the middle of the connection. If you leave it to the default, which is false, you will only spoof the target machine. Now this can be useful if the router has some sort of protection against ARP spoofing attacks, because you won't be interacting with the router at all. But it's also limiting because we won't be able to do what I'm gonna do in the next lectures, because the router will communicate with the target device directly, so we won't be able to inject stuff in the responses that the router sends to the target device. Now I actually want to change this to true, and the method I'm gonna do this can be used to change any option in any module in BetterCap. So not only in the arp.spoof, if you're using any module, you can do help followed by the module name to get help about that module name. You can see all of the options that you can set in here. And then if you want to modify the value of any of these options, all you have to do is copy the option name, which is what I have right here, and type set followed by the option that you want to modify. And in my case, it's called arp.spoof.fullduplex, and I want to set this to true. So very, very simple. And like I said, you can use this command to change any option in any module in BetterCap. All you have to do is type set, followed by the option name, followed by the value that you want to set. So I'm going to hit enter, and that's done. If you don't see errors, that means it got executed properly. The next option that I want to change is the targets. So again, in the description, it's telling us that these are the targets that I want to run the attack against. And I can use a comma if I wanted to target more than one IP at the same time. So again, just like what I did before, I'm going to do set, followed by the option name, which is arp.spoof.targets. And you can actually use the tab to autocomplete. So if I just type TA tab, it will autocomplete the targets for me. And after this, I'm going to put the value that I want to set this option to, which is the IP of my target. And we can get this using NetDiscover, using ZenMap, or using the result that I got in here after I run the recon module. I did net.show, and we got all of this, which is the list of all of the computers connected to the same network. And my target right now is this particular device, the 10027. This is my Windows virtual machine right here. So I'm going to put the IP 10027. And again, we don't see any errors, which means that everything got executed as expected. Now we're ready to run the tool. And again, based on the help menu that we got, we can do ARP spoof on to turn this module on. So we're going to do arp.spoof on. And perfect, as you can see, we see no errors. It's telling us that the module is running. And if I do help, again, we're going to get a list of all of the modules that are running right now. And as you can see, we can see that ARP spoofing is on. Also, it is very important that you make sure that the net.probe and the net.recon are running. We did this in the previous lecture. That's why I didn't do it now. So right now, BetterCap should be doing what ARP spoofing was doing, fooling both the router and the target device and putting me in the middle of the connection as shown here. So let's go to the Windows machine right here, and I'm going to do ARPA. And as you can see, the router's MAC address right here is the same as the MAC address for this device, which is the 10.02.15. And if I go back here to the Kali machine and do ifconfig, you'll see this is the same MAC address as the MAC address of the Kali ETH0 interface. So basically what this means is this Windows machine, every time it wants to send something to the router, it'll send it to the Kali machine. And because we set the full duplex option on in BetterCap, the router also thinks that this Kali machine is the target machine. Therefore, anytime it needs to send a response to the Windows machine, it'll actually send it to BetterCap right here. And like I said before, this means every username, password, URL, anything the target computer sends or receives will have to go through the Kali machine, where we're going to be able to read it, modify it, or drop it. And I'm going to walk you through that in the next lectures. In the previous lecture, we learned how to use BetterCap to run an ARP spoofing attack and place ourselves in the middle of the connection between a computer and the access point. And every time I do this, I keep saying this means that all the requests and all the responses will flow through our computer, which means that we'll be able to see anything a user does on the internet. So we should be able to see the URLs, the images, the videos, the passwords they log in with, or anything they send or receive. So right now, we are already in the middle of the connection, and this data is already flowing through our computer. So all we have to do is just use a program to capture this data and analyze it. Now we can use Wireshark to do that, and I will cover this later on in the course, but for now, I'm going to use a really nice module that comes with BetterCap that will automatically capture all of this data, analyze it, and show me the interesting stuff. So all we have to do now is to tell BetterCap to capture all of the data that is flowing through this computer and analyze it for me. And to do this, we can use the net.sniff module. So you can do help followed by net.sniff to see all of the options that you can set for this module. But I showed you how to read options and change them. So for now, I actually want to run it without modifying any of the options. So I'm just going to do net.sniff on. So now everything that's going to flow through this computer will be captured and analyzed by the net.sniff module. So I'm going to close this terminal window and let's go to the target Windows computer. I'm going to open my web browser and we're going to generate some traffic and see if that's going to be captured by BetterCap. What we're doing right now will not work against HTTPS, but don't worry, we'll talk about how to bypass HTTPS later on and why this won't work. But for now, for testing, I'm just going to go to a website called VulnWeb, and I'm going to include its link in the resources of this lecture. So as you can see, this is a normal website that doesn't use HTTPS. It also has a number of links here. So if I click, for example, on this link, everything is loading fine, as you can see here. But if we go to the Kali machine, you'll see that every request that we sent was actually captured by this computer. So you can do this to any computer that is connected to the same network as you, whether it's a wired or a wireless network. So you can see there were requests sent to Google. If we scroll down, you'll see we made a request for this website, vulnweb.com. You can also see all of the other files that this website loaded. So you can see we have a logo loaded here. You can see we have a styles file being loaded here. Again, if there were more images, you'll actually see links to all of the images that are being loaded. You can see here, this is the second link that we clicked on, the testphp.vulnweb.com. So this is what we have right here in the top. Now also, let me just go back and maybe click on the first one. And as you can see, this is another website. It has a login functionality in here. And let's try, for example, log in with a username. Let's set the username to my name, Zaid Sabi. And let's put the password as 12345678890. I'm gonna click on log in. Again, as you can see, we got logged in, no issues at all. But if I go back to the Kali computer and scroll up, as you can see, we captured a login that was sent to this website, testhtml5.vulnweb.com. Again, this is exactly the website that we have here. And if you look in here, you can see that the username was Zaid Sabi and the password was 123 all the way up to 90. So basically the idea that I'm trying to get across right now, anything that the target computer sends or receives right now will be captured by the Kali machine. And like I said, we can do this to any computer or any phone that is connected to the same network as us, whether it's a Wi-Fi or a wired network. In the previous lectures, we learned how to use BetterCap to discover all clients on the same network, run an ARP spoofing attack to intercept the data, and then sniff data to see the usernames, passwords, and everything that's getting sent over the network. Now, in order to do this, we actually had to run a number of commands. So first of all, we had to do net.probe on to turn on the probe module. We had to set the settings for the ARP spoof module, turn that on, and then turn the sniffing module on. Now, every time you want to do this, every time you want to intercept data and see it on screen, you're going to have to do all of the steps that I showed you in the previous lecture. Or, if you're lazy, like myself, you can use a caplet to do all of that automatically, which is exactly what I want to show you in this lecture. So, what do I mean by a caplet? Well, basically, a caplet is just a text file that contains all of the commands that you want to run. So, I'm going to resize this menu. I'm going to open a text file. And I'm just going to organize this a little bit to make it easier to follow. And I'm going to clear this window here. And I'm going to go to the first command that we had to run in order to do this. So again, scrolling up, the first thing we did was net.probe on. So in my text file here, I'm going to literally type this command, net.probe on. And as we saw, this will automatically start the net.recon module. Again, we enabled both of these modules in order to discover the connected clients and keep automatically discovering any new clients that connect to the network. The next thing that we did was modify the settings for the ARP spoof module. So we did set ARP spoof full duplex to true. I'm going to actually copy this and paste it here. Then we set the target IP. So again, I'm just going to copy this and paste it here. And keep in mind, this is very important. You want to make sure that you change the IP here to the IP of your target all the time. And if you are targeting multiple computers, you can just use the comma and type the next IP after the comma. Next, we turned on the ARP spoof module. So again, this is what I'm going to do here. I'm going to do ARP.spoof on. And finally, we also ran the sniffer by doing net.sniff on. So again, I'm just going to type this in here, net.sniff on. So this is actually a nice summary of what we did in the previous lectures. Again, like I said, every time you want to intercept the connections, you're going to have to start BetterCap and run all of these commands manually. You want to start the probe module. You want to enable the full duplex, so you fool or spoof the target and the router. You want to set your target IP, and you want to turn on the spoof and turn on the sniff. So, to make this very easy, instead of having to type this every time we want to run an ARP spoofing attack and intercept data, I put all of this in a text file. I'm going to save this text file. I'm going to put it in my root directory, and I'm going to call it spoof.cap. So I'm going to save this now, and I can close it because we're done with it. And we can go back here. And what I'm actually going to do, I'm going to exit out of this. So I'm going to quit BetterCap, and I'm going to clear the screen. And if I do ls to list all of the files and directories in the current working directory, because right now I am in root. So if I do ls, you can see we have a new file called spoof.cap. And just to confirm, if I go down to my file manager right here, you can see we have a new file again in the root called spoof.cap. And all we want to do is feed this spoof file to BetterCap before we start BetterCap. Now, we don't know how to do this, so we're going to do BetterCap --help to see all of the options that we can set with BetterCap. And what we want to do is use the -caplet option right here. So we're going to run BetterCap like we used to do. First of all, we do BetterCap, followed by iFace to specify the interface that is connected to the target network. And in my case, this is ETH0. So far, this is identical to what I've been doing in the previous lectures. The only difference now is we're going to use the -caplet option to specify my caplet file that I just created. So I'm going to do -caplet, followed by the file that I just created, which is called spoof.cap. And that's it. Now, before I hit enter, just to confirm to you, I'm going to go back to my Windows machine, and I'm going to do ARPA just to show you. And as you can see right now, the router's IP right here has this MAC address. So after I run this, it should automatically start all of the modules that I just typed, and it should run an ARP spoofing attack. Therefore, the router's MAC address should change to the MAC address of ETH0 that is connected to Kali right here. So I'm going to hit enter. And as you can see, we actually got an error, and the error saying the caplet spoof could not be found. So I'm suspecting I made a spelling mistake, and I did. As you can see, I actually named the caplet soof, not spoof. So I actually make a lot of mistakes like this. So I'm just going to rename this to spoof, and we're going to go back here. I'm going to exit and run the same command again. And perfect. As you can see, we got no errors at all. If I do help, as you can see, automatically we have the spoof is running. We have the probe, the recon, and the sniff all running as soon as we ran BetterCap. If you remember, the first time we ran it, we only had the stream running, and we had to do everything manually and set the options manually. So this is a really, really nice way of doing it. Now, let's confirm that everything is working as expected. So I'm going to go to the Windows machine and we're going to do ARPA again. And perfect. As you can see, the router's MAC address has changed to the same MAC address as the Kali machine. And the original router's MAC address, the correct one, was this. So this means that this Windows machine is now spoofed, thinking that the Kali machine is the router, and the router now thinks that the Kali machine is this machine. This will place Kali in the middle of the connection. And just to confirm this, just real quick, I'm already in VulnWeb. This is the website that we tested the login before. I'm actually even still logged in, so I'm gonna log out, log in again, and I'm gonna leave the username to admin, and I'm just gonna put a password again, 1234290, enter. Let's go back, and perfect. As you can see, we wouldn't be able to get this if we were not in the middle of the connection. So the fact that we're getting all of this information means that we managed to intercept the data and see everything the target user sends or receives. And again, we have the username and the password right here. Like I said, this will only work with HTTP. We will discuss HTTPS in the next lectures. But in this lecture, I just wanted to show you an easy way of scripting the commands that you often run with BetterCap, because in the future, we're going to be doing a number of things that rely on us being the man in the middle. So, because I don't want to waste time enabling all of the modules that we're running here, so again, if I right click this and open with a normal text editor, all you'll have to do is just put your commands in a file, give a file a specific name, and then when you run BetterCap, all you have to do is just use the caplet argument followed by the name of your caplet file. Now, everything that we did so far will only work against HTTP pages. The reason why it works against HTTP because, as we've seen, the data in HTTP is sent as plain text, so it's text that humans like us can read and understand. That's why when we're the man in the middle, we're able to read this text, and if we wanted, we're able to modify this text as we wish. Now, this is obviously a problem, and this problem was fixed in HTTPS. So, as you know, most websites use HTTPS. The reason why, like I said, because it's a more secure version of HTTP, and basically the way it works is it adds an extra layer over HTTP, which is where the S comes from. So it's a secure HTTP protocol, and this extra layer will encrypt the plain text data that HTTP sends. So if a person manages to become the man in the middle, they will be able to read this data, but the data will be gibberish. It will not be readable to the person intercepting the connection. Now, HTTPS relies on TLS or SSL to encrypt the data, and this is very difficult to break. Therefore, in order to bypass this, the easiest method is to downgrade HTTPS connections to HTTP. So, since we're the man in the middle, we can check if the target is requesting a HTTPS website, and instead of giving him the HTTPS version of that website, we will give him the HTTP version. This way, the data will be sent in plain text and we'll be able to read it exactly as I showed you in the previous lecture. To do this, we'll have to manually configure and use a tool called SSL strip. And I show how to do this in my more advanced courses. But luckily, BetterCap has a caplet that does all of that for us. I also modified this caplet myself to get it to work more reliably and on more websites. So please make sure you use the custom Kali image that I made for this course because it comes with this modified caplet by default. If you want to use the original Kali, then you're gonna have to manually download this caplet and put it in the right path. I am using the custom Kali in here, so I won't need to do any of that. I can simply run BetterCap and use it. But before doing that, I just want to go to the home directory and modify the spoof caplet that we have been using in the previous lectures. And I just want to modify one thing in this. So I'm going to right click it and open it with LeafPad. And what I want to modify is I want to add an option to the sniff in here. So as you know, this line net.sniff on will turn on my sniffer. But before turning it on, I want to set the net.sniff.local to true. And what this option will do, it'll tell BetterCap to sniff all data, even if it thinks this data is local data. The reason why I set this option to true, because once we use the HTTPS bypass caplet, the data will seem as if it's being sent from our computer. So BetterCap will think these passwords belong to me, to my computer, and it will not display it to me on screen. That's why we're setting it to true, so that we can see all the usernames and the passwords sent on the websites that we will downgrade from HTTPS to HTTP. So I'm going to save this, Control S, and quit it, Control Q. And now we are actually ready to go and use this caplet and see how we can downgrade HTTPS to HTTP and steal passwords from login pages that use HTTPS by default. So I'm going to go to my terminal and I'm going to use BetterCap exactly as I've been using it before. So we're doing BetterCap, the name of the program. We're giving it our interface after the iFace argument. We're using the caplet argument to specify a caplet to run as soon as we run the program. And we're running the spoof caplet, the one that we built in the previous lecture, that'll run the ARP spoofing command and run the sniffer for us. So I'm going to hit enter. And as you can see, everything got executed as expected. If we do help, we'll see all the running modules, and we have the ARP spoof and the sniffer running with the recon and with the probe. So this is exactly what we wanted from our caplet. So first of all, the HSTS bypass caplet is one of many caplets that BetterCap comes with. If you want to list all of these caplets, you can do caplets.show, and as you can see, you'll get a list of all of the caplets that you have and their location on the system. Now, the caplet that we want to run is the HSTS hijack caplet, this one right here. And to run any of these caplets, all you have to do is literally just type its name. And as usual, you can use the tab to autocomplete. So to run our caplet right here, all I have to do is literally type HS and press tab. And as you can see, it will automatically autocomplete for me and type the caplet name. Now, if I hit enter, this will load the caplet with all of its options and it will run it for me. So as you can see, because we don't see any errors, this means everything got executed as expected. So let's go to the Windows machine, browse some HTTPS pages and see if we can sniff data, usernames, passwords, and URLs that they enter on their computer. So I have my Windows machine here. I have Chrome installed. This is the latest version of Chrome at the time of recording this lecture. A really good idea before trying all of these things is to remove your browsing data, because the websites that we're going to try to access might be cached and they might be just loaded from your cache. This will only happen if you're visiting the same website over and over again, mostly when testing. Therefore, it's a really good idea to Control-Shift-Delete and click on Clear Browsing Data. Make sure all of this is clicked. Make sure it's set to all the time and click on Clear to remove all of it. And let's go ahead and go to a website that uses HTTPS. So a good example would be linkedin.com. And perfect. If you look here at the top, you'll see the website is loading over HTTP, not over HTTPS. Therefore, we'll be able to see anything the user enters in these boxes. So let's put a username. Let's set it to zaid@zsecurity.org. And I'll put a password as 12345678890. It doesn't really matter. You can use any password. And I'm going to hit enter to log in. This is wrong, so obviously we're getting an error message. But if we go back to Kali, as you can see, we're capturing all of this data because it's not being sent over HTTPS anymore. It's being sent over HTTP. And if you look in here, you can see we captured login information. It's sent to linkedin.com, sent to this specific URL, a login URL. And you can see the username is zaid@zsecurity.org. And the password is 123 all the way up to 90. So that's really, really good. Let's go ahead and test another HTTPS website. Let's go to stackoverflow.com. Again, you can see on top, it's loading over HTTP, not HTTPS. So I'm going to click on login. And again, I'm going to put my email, zaid@zsecurity.org, and we'll put a password as 12345678890. Hit enter. And let's go to the Kali machine again. Scroll down this time because we're stuck on top. And perfect. You can see we have a post request in here. It's sent to this specific URL. Again, you can see login in the URL. You can see the website itself, stackoverflow.com. And if we scroll down a little bit more, we can see that the username is zaid@zsecurity.org. And the password, again, 123 all the way up to 90. So that is really, really good. Now we can downgrade any HTTPS connection to HTTP as long as the target website uses HTTPS, not HSTS. So this method will work against pretty much all websites that use HTTPS, except for the really popular websites such as Facebook, Twitter, and so on. So let me show you a quick example. If I go here and try to go to facebook.com, you'll see that the website got loaded over HTTPS, not over HTTP, even though we configured our couplet correctly, and even though we're able to downgrade HTTPS connections on a lot of websites such as LinkedIn and Stack Overflow. This is happening because Facebook is using HSTS, which is a little bit trickier to bypass. In the next lecture, we'll talk more about what HSTS is, why it's tricky to bypass, and how to partially bypass it and still get usernames and passwords from the websites that implement it, such as Facebook, Twitter, and so on. In the previous lecture, we've seen how to downgrade HTTPS websites to HTTP, and this allowed us to basically see anything a user does on these websites because data in HTTP is sent in plain text. Therefore, we were able to see the usernames, the passwords, the URLs, and anything they do on HTTPS websites. At the end of the lecture, I also showed you that the method will not work against Facebook, Twitter, and other websites that use HSTS. The reason why it won't work against these websites because modern web browsers come with a list of websites that they should only load over HTTPS. See, what we were doing in the previous lecture, whenever a browser requests a website, we load that website even if it uses HTTPS, but we always give him back the HTTP version. In HSTS, the browser knows that this website, for example, facebook.com, should always be loaded over HTTPS. So even before sending this request to us, it'll always send it in HTTPS, and it'll always only accept it if it comes back as HTTPS. So there's nothing we can do really once we become the man in the middle, because the browser is doing this check locally. It's checking this against a list that is stored on the computer itself. Therefore, the only practical solution at the moment to bypass HSTS is to make the browser think that it is loading another website. To do this, we're going to replace all HSTS links in loaded pages to similar links, but they're not the same links. For example, we can replace facebook.com with facebook.corn. Now, I know this seems very suspicious, but trust me, when it goes into the URL bar, the RN here at the middle, it'll seem very similar to the M letter. Another way of doing this, you can replace twitter.com with twitter.com, but with a single T here instead of a double T. I know this sounds a little bit confusing right now, but let me go and do it practically, and you will see how this is gonna work. So, right here I have my Kali machine, and we're actually gonna use the HSTS couplet that we used in the previous lecture. As mentioned in the previous lecture, this couplet is already installed in the custom Kali. If you want to use it with the original Kali, you'll have to manually download it and place it in the right path in user, local, share, better cap, couplets. I have the couplet right here. Like I said, this is already the correct one because I am using the custom Kali. If we go inside it, we have a file called hstshijack.cap. This is the configuration file of the couplet. So I'm going to right click it. I'm going to open it with other application. I'm going to click on view all applications, and you want to pick any text editor that you have. So I'm going to keep this at LeafPad. You might have to scroll down to find it, but I have it here. I'm going to select. And as you can see, we have a normal text file with all the configurations that we can set. And I've already pre-configured this for you. The main things that you want to understand and maybe change is the targets and the replacements. So the targets are the domains that use HSTS that you want to replace. For example, I have twitter.com in here. And I also have star.twitter.com. Basically, when you use a star, this is a wildcard, and it basically means any subdomain .twitter.com is a target as well. In the replacement, you want to tell the program what to replace this target with. For example, whenever we see twitter.com, we're going to replace it with twitter.corn. Similar goes for Facebook and Apple and a few other domains that I set. You can also play around with the obfuscate and encode options. I've set both of these to false because basically what these will do, they'll obfuscate the code and encode it. But I noticed some browsers like Firefox will block obfuscated or encoded code. That's why I set both of these to false so that the code is left as is. Here in the payloads, you can set any other JavaScript code that you want to inject. Leave this the same. We'll talk about JavaScript injection in a future lecture. Finally, you want to make sure that the DNS spoof domains are set exactly the same as the replacements in here. So I literally copy this line and paste it here. Now I'm actually going to keep all of this the same. I don't need to modify any of it. But like I said, if you're targeting different websites, or if you want to use different replacements, for example, if you wanted to use a Twitter with a single T and keep this .com, you can do that here. If you wanted to use a Facebook with a single O and keep this .com again instead of .corn, you can do it here. Once done, make sure you save and quit this file. And we're ready to run the attack. So running this attack is actually going to be identical to what we did in the previous lecture. You just want to make sure you modify this file properly. So going back to BetterCap, I'm going to clear the screen, run BetterCap with the same command, loading the spoof caplet so we can do all of the ARP spoofing commands and run the sniffer all automatically. And perfect, as you can see, everything is running as expected with no errors. If you run this and you get an error, just do exit and run BetterCap again. Next, we want to run the caplet, the HSTS hijack caplet, exactly as shown in the previous lecture. All we have to do is type HS tab, it'll autocomplete for us, and hit enter to run it. Again, as you can see, no errors, so everything is working as expected. Let's go to the target machine and see how this is going to work. So I have my Windows machine right here. This is Chrome, the latest version in April 2019. And before I do anything, like I said, it's a good idea to always just remove the browsing data. And before I actually load any websites, it is very important to understand that even with everything that we're doing right now, if you try to go to Facebook and type .com at the end here, it will not work. What we're doing right now will not work because Chrome right here has a list that is stored on this computer that says do not load facebook.com unless it is loaded over HTTPS. So if you type Facebook right here like this, it will not work. The only way we can do this is if the user first goes to a search engine, for example, google.ie for Ireland. And then in Google, as you can see, Google doesn't use HSTS. So we bypass this using the normal HTTPS bypass. And then if the user in here searches for their target website, for example, Facebook, then our script is going to run in the background and it's going to replace all links in this page for facebook.com with facebook.corn. So if I actually hover over this, you'll see in the status bar, the website that will be loaded is facebook.corn, not facebook.com. This is fine here. It still says facebook.com, but only in the code of the HTML page, facebook.com got replaced with facebook.corn. So if I click on this link, again, as you can see, we get a normal Facebook page, but if you look here on top, you'll see there is no HTTPS. And if you look at the domain name, you'll see it says .corn, not .com. Again, like I said, you can actually keep this .com and use Facebook with one O, or you can add an extra O. You can be as creative as you want with this. This is just an example that I'm giving you. Now, once we're here, we can log in normally with my username, so zaid@zsecurity.org, and put my password 1234567890. Hit enter, and if we go back, scroll up. Perfect. As you can see, we have the username zaid@zsecurity.org and the password all the way up to 90. Now, like I said, the only way for this to work is if the user gets to Facebook through another website that does not use HSTS. If they go on the URL bar and type facebook.com themselves, we will not be able to do this. That's why this is considered as a partial solution and not a full solution. In the previous lectures, we covered how to sniff and read data from HTTP, HTTPS, and preloaded HSTS websites. We spoke about the limitations of each of these cases, but we did that as we are going through the lectures. Therefore, I feel like some of the details might be missing, and therefore I made this table right here, and I'm going to show you some examples in this lecture just to lay everything down for you so you understand exactly how this is going to work and what are the limitations. So first of all, we spoke about HTTP websites, and an example of this would be a website that doesn't use HTTPS, just loads over plain HTTP, similar to vulnweb.com. Then we spoke about HTTPS websites, and this would cover most websites on the internet. So examples would be LinkedIn.com, WinZip, Stack Overflow, Google, the local Google, so not google.com, but the google.ie or .co.uk or .in, any local Google domain, and netflix.com. Now the list here could go on for very long because, like I said, most websites use HTTPS. And finally, we spoke about the most restrictive and the most secure method of communication, which is preloaded HSTS websites. And the way this works, we said the web browser itself will have a list of hard-coded websites that will only load over HTTPS. And therefore, because the browser has to contain this list locally, it will not contain all websites on the internet. It only contains very popular websites, such as Twitter, Facebook, and GitHub, and so on. Now, we could have a bigger list in here, but it won't be as big as HTTPS websites, as most websites use HTTPS. Now, when it comes to HTTP, no encryption is used, so there's nothing you need to do to bypass. So you can basically use the basic BetterCap, no modifications at all, and it works perfectly with Firefox and Chrome, so you'll be able to read the data and even modify it, as we're going to show you later on in the course. Then when it comes to HTTPS and HSTS, we can't decrypt HTTPS, and therefore what we try to do is we try to downgrade HTTPS to HTTP, and then when the website is loading over HTTP, we will be able to read all of the data that is being sent and received, so we'll be able to see the usernames and the passwords and so on. And as I'm going to show you later on in the course, you'll be able to modify this data. So you'll be able to launch attacks like DNS spoofing, where we redirect the domain to another location or inject code in the loaded website, but all of that is dependent on loading the website in HTTP. Therefore, when it comes to HTTPS and HSTS, the goal is always to downgrade that website or downgrade that connection to HTTP. So for this to work, we used a custom modified Kali that comes with the latest version of BetterCap and a modified HSTS hijack caplet. This is the caplet that downgrades HTTP to HTTPS. And this works perfectly with the latest version of Firefox. So let me show you a quick example. We're going to load BetterCap with the HSTS hijack caplet and then try to load some of these websites. And the goal is that these websites should load in HTTP, not HTTPS. If that happens, that means we can read all of the data and analyze it, and we can even modify it, as I'm going to show you later on in the course. So right here in my Kali machine, I'm just going to start BetterCap exactly the same way as we usually do. I'm selecting my interface and my spoof caplet. And then I'm going to start the HSTS hijack caplet by typing HS tab, and it'll auto-complete for me. I'm going to hit enter, and now it's working. And let's go to the Windows machine. And as you can see, it's telling me that I'm using the latest version of Firefox. And let's go ahead. Before we test, I'm just going to remove all browsing data. So I'm going to press Ctrl, Alt, and Delete. And we're going to tick everything, make sure everything is selected in here, and click on OK. And let's go ahead to the first HTTPS website like LinkedIn.com. And perfect, as you can see, the website is loading over HTTP, not HTTPS, because we can see this cross over the lock. But most people won't notice this, and basically, like I said, that means we can read whatever username and password the user will put in here, and we can modify the data and inject data in this, and you'll see this later on in the course. Now, I'm not going to log in now because we've already seen this. The goal now is just to show you which websites are going to downgrade to HTTP. And even if you don't see the login data now, if I log in and you don't see it in BetterCap, that is completely fine because the sniffer that comes with BetterCap is not perfect. I will show you better sniffers later on in the course. So the main goal when we're using BetterCap is to be able to downgrade HTTPS to HTTP. So let's load another HTTPS website like stackoverflow.com. And perfect, as you can see, it's downgrading as well. And let's do a last one now. Let's go to netflix.com. And again, perfect, it's downgrading, it's loading over normal HTTP. So we haven't done anything different from what we covered earlier. Everything is working perfectly with Firefox. Now, when it comes to Chrome, there is a slight modification that we'll need to talk about. So let's continue testing with Firefox. So moving on to preloaded HSTS website, similar to Twitter, Facebook, and GitHub. Again, for this to work, we're gonna have to use the custom Kali with BetterCap with the custom HSTS hijack caplet. Now, let's go ahead and test it with Firefox. So the way this will work, as mentioned in the HSTS bypass lecture, the target will first have to load a normal HTTPS website. An example would be a local Google domain, for example, google.ie or google.in or google.co.uk, anything but the google.com, because these use normal HTTPS, and therefore we will be able to downgrade them to normal HTTP, as you can see in here. And then, once they are on any website or any search engine that uses normal HTTPS, and we successfully manage to downgrade it to HTTP, if they search for a HSTS website, for example Twitter, the HSTS hijack caplet is going to replace the link for twitter.com with twitter.corn. Therefore, that will bypass the hard-coded list that the browser comes with, because it does not have an entry for a website that is called twitter.corn. So if I hover my mouse over here, you can notice at the bottom, the website that we will go to is twitter.corn and not twitter.com. Now this replacement takes a second or two, so if you hover over it straight away as soon as the website loads, you might actually notice twitter.com, and then instantly it's going to change to .corn. Once it changes, if the user opens this, you're actually going to get a redirect notice like this one that will not work automatically. So this is another limitation with this method. But if the user actually goes ahead and loads the website, you will notice that we will get a website that is identical to Twitter, which we can use to sign in or sign up, but the website is loading over normal HTTP, not HTTPS. And if you note, it's twitter.corn, not .com. So if the user looks in here, they might be able to notice that something is fishy happening, but I would say it'll pass most users. So now that the website is loading over normal HTTP, you can first of all read the data the user sends, for example, usernames and passwords, and you'll also be able to manipulate this page and inject evil code in it, and we will cover that later on in the course. Let's have another example. So let's close these and let's go ahead and look for Facebook. Again, Facebook is another example of a website that uses HSTS. If we hover over it, you can see already it's being replaced to facebook.corn. So let's open it in a new tab and open it again. And perfect. As you can see, Facebook loads normally over HTTP and not HSTS or HTTPS. Again, once the user logs in, you're going to be able to capture the username and the password, and you'll be able to manipulate this page. So that's everything for Firefox. HTTP obviously works with no issues at all. HTTPS also works with no issues at all. And HSTS, you just need to make sure that the target websites are listed in the HSTS hijack caplet. And I showed that in the HSTS hijack lecture. So if you don't know how to do that, please revise that. But as you can see, it's working exactly as expected, as long as the target user accesses the HSTS website through a normal HTTPS website. Now, in the next lecture, we'll have a quick recap for Chrome, because Chrome is slightly different and could be slightly trickier. So that's Firefox covered. Let's go ahead and take a look at Chrome. Now, again, for HTTP, as we mentioned, everything works as expected. It's a very simple scenario. For HTTPS, you still want to use the same configuration as Firefox. So we're going to use the custom Kali, which comes with the latest BetterCap and a custom HSTS hijack caplet. Everything will work as expected in this case. The only thing is, you need to make sure that you input the target website in the HSTS hijack caplet. So similar to what we did with HSTS websites, you're actually going to have to include all of the HTTPS websites that you want to target and you want to downgrade to HTTP in your HSTS hijack caplet. So it's a bit of a limitation, but that's the only way we can do it with the latest version of Chrome. For example, we have Netflix. So as we know, Netflix worked perfectly fine in here. So let me just go quickly on Firefox, netflix.com. And as you can see, it's loading perfectly fine. Now, if I load that now on Chrome with the exact same configuration of BetterCap, as you know, it's already running, it's gonna load over HTTPS and not HTTP. The only way around this is to actually go back to my Kali machine, open up my file manager, and open up the HSTS hijack caplet. So you can do Control L to do that, or you could press in here and press a /, and it's stored in USR local share BetterCap caplets HSTS hijack. And the caplet that we want to modify is HSTS hijack.cap. So it's this caplet right here. We're going to right click it and open it with another application, view all, and open it with my LeafPad with the text editor. So I showed you how to do all of this in the HSTS bypass lecture. That's why I'm doing it fast. Please revise if you don't remember. And what you need to do is simply in here, input the HTTPS websites that you want to downgrade to HTTP. So in this example, we want to downgrade Netflix.com. So we're going to input it in here, and I'm going to select it again. And I'm actually going to put it in the next row and the replacements as well. And finally, we're going to put it in the DNS spoof. We're going to save, quit, and we're going to go up and run BetterCap again. So I'm going to exit, clear the screen, run BetterCap with the spoof caplet, and then run the HSTS hijack caplet. And let's go ahead and test this with Chrome. So before testing, it's always a good idea to remove all browsing data. So Control-Shift-Delete, make sure all time is selected, and make sure you tick all of the boxes. We're going to clear. And let's go ahead and go to Netflix.com. Hit enter. And perfect. As you can see, Netflix is loading over normal HTTP now. So again, if you're inputting any username and passwords in here, you'll be able to capture them, and you'll be able to modify this website and the requests on the fly because everything is sent over HTTP, which does not use any encryption, and we will cover that later on in the course. So the main idea is all you have to do is simply add the websites that you want to downgrade to HTTP in your HSTS hijack caplet. So that's HTTPS for Chrome done. Let's go ahead and take a look at preloaded HSTS websites on Chrome. This will work exactly the same as Firefox. So you're going to need to use the custom Kali with the BetterCap with the custom HSTS hijack caplet. And similar to what we did with Firefox, the targets will have to be in the HSTS hijack caplet. So we're not doing anything out of the ordinary. The only thing is secure DNS needs to be disabled. So secure DNS is a setting that Chrome has. And if it is enabled, the web browser is going to use encryption when it's making DNS requests, and therefore it'll render our attack right here with the custom HSTS hijack caplet useless. Now, the good thing is secure DNS is not always enabled by default. It depends on the country of the target. For example, in Ireland, if you download the latest Chrome web browser, it's actually going to come with secure DNS enabled, and therefore the attack is not going to work unless it is disabled. So if your target is in a country where secure DNS is not enabled by default, chances are they don't even know about this option, and it's probably going to be disabled, and therefore the attack will work. So let me show you where this setting is. In my Chrome, if we go to settings, and we can use the search icon in here to search for that setting, and we want to search for secure DNS. And as you can see, it's telling us it's in the security settings. And if we scroll down, you will notice that use secure DNS is enabled. So if I just turn this off and close this window, and let's go ahead and test the attack exactly the same way that we tested it before. So we're going to go to a local Google domain, for example, google.ie. As you can see, it's loading as normal HTTP, not HTTPS. Therefore, the HSTS hijack applet is going to be able to modify this page, play with it, and change the links to .corn. And let's look for Twitter. And again, if we hover here over the link, you'll notice at the bottom it's twitter.com now, but literally within a second, it's going to go back to being twitter.corn. Let's open it in a new tab. And perfect, as you can see, Twitter is loading over normal HTTP. And again, now if the user logs in, we will capture everything, or because the website is loading over normal HTTP, we're going to be able to inject anything that we want and modify the website and inject evil code in it. And I'm going to show you how to do all of that later on. Now in this lecture, we're going to learn what DNS spoofing is and how to perform it. DNS is a server that converts domain names such as google.com to the IP of the server that is hosting this website. So when you type google.com in your web browser, the request goes to a DNS server. The server responds with the IP where google.com files are stored, and the browser will load the website from this IP. Now, when we are the man in the middle, the request for google.com will pass to us first before it goes to the DNS server. Therefore, instead of giving the IP of the server that is hosting google.com, we can actually give any IP we want. So we can redirect them to a fake website with a backdoor or with evil code, hijack software updates, and so much more. We'll actually have examples on this in future lectures, but for now, let's see how we can run a basic DNS spoofing attack in which we redirect requests from a specific website to our own website or our own web server. Now, before we run BetterCap, let's decide on where to redirect our target to. So we can redirect them to any website we want. For example, when someone requests google.com, we can redirect them to Yahoo. But what I want to do is I want to redirect them to my own website, to a local website that I'm going to start on Kali. So Kali comes with its own web server, so we can actually use it as a website. And to do this, all we have to do is just start the web server. So we're going to do service Apache 2 start. So Apache 2 is the name of the web server, and we're saying that we want to start the service. If I hit enter, we see no errors, which means that the server is working now. And to access this website, to access this server, we have to go to Kali's IP. So as you know, to get our IP, we can do ifconfig, and we can see our IP is 10.02.15. So if I just go to a web browser and go to 10.02.15, you'll see I'll get the default page of this website. Now the pages for this default website is stored in var www.html. So I'm going to open my file manager and I'm going to click here on the title bar, press / to open it, and we're going to go to var www.html. And as you can see, these are the files for this website. So if you want to install a fake website or any type of website, all you have to do is just put its files in here. Now, index.html is the file that gets loaded here by default. So this is what you see in here. So I'm actually going to right click it. I'm going to open it with another application. I'm going to select my text editor, and this will open the HTML code for me. And I'm actually just going to remove this, and I'll just put a smiley face. Like I said, we're just doing this for testing, so just showing you which files get loaded by default and where you can actually put a website if you wanted to host a proper website here. So I'm going to go back here, and if I refresh the page, you can see we get the smiley face in here. Now that's perfect. Right now we still haven't executed our DNS spoofing attack, but what I want to do is, when my target tries to go to a specific website, I'm going to redirect them to this page that shows this smiley face. So let's go to the target machine first, and let's go to our target website. I'm going to do this against my own website, zsecurity.org. So if you load this website, you'll see you will get an actual security website with a number of topics and all that kind of stuff. Basically, the website is working as expected. Now, let's go ahead and run this attack. So I'm going to go to BetterCap. I'm going to run it using the exact same command that we've been using so far. So we're just doing BetterCap with the interface, with the spoof caplet, so we can intercept data and modify it as it's flowing through our computer. And as you can see, it's running with no errors, so that's all good. Now, the module that we want to use is called DNS spoof. So if I do help right now, you can see it right here. It's called DNS spoof and it's not running. And as usual, if we don't know how to use a module, all we have to do is do help, followed by the module name. And in this case, it's DNS spoof. And as you can see, we get all the options that we can set for this module. First option being the DNS spoof address. This is the address that the user will be redirected to. So if you want to redirect them to another website, you have to put the IP of this other website here. In my case, I want to redirect them to my local website, to the website that we have here, which is running at 10.02.15. Therefore, I'm not going to have to modify this because by default, this is set to the IP of my interface. The next thing that we want to modify is the dns.spoof.all. We want to set this to true so that BetterCap responds to any DNS request. So, just like any other option within BetterCap, to change its value, we have to do set, followed by the option name that we want to modify, and in this case it's dns.spoof.all, and we want to set this to true. Sorry, this is all being produced by the sniffer. The next option that we want to set is the dns.spoof.domains. This will specify the domains that we want to target, that we want to spoof. And as mentioned, we can use a comma to separate more than one domain. And as you know, we want to target zsecurity.org and we want to redirect that to our own website running on Kali. So we need to change this option right here, dns.spoof.domains. And again, we're going to do this by doing set, the option name, which is dns.spoof.domains. And we're going to set this to zsecurity.org. As mentioned in the option, we can use the comma to specify more than one domain. And the other domain that I want to specify is star.zsecurity.org. So the star right here is a wildcard, and it basically means that I want to target any subdomain .zsecurity.org. So I'm going to hit enter and we don't see any errors. So everything is set as expected. And all we need to do now is start the DNS spoof. And to do this, we just need to run dns.spoof on exactly the same way that we start any other module. I'm going to hit enter and this should be running right now. And as you can see, it's telling us that it's going to spoof zsecurity.org to this IP, which is again, this is our IP. We verified this using the ifconfig command. And keep in mind, we actually did not have to give BetterCap this IP. It got it automatically. It's also telling us that the other target is star.zsecurity.org and it'll be spoofed to this. Now, let's go to the target machine and test this. And before you test this, please keep in mind, you might need to wait for a minute or two for the changes to propagate. Also, if you just loaded this website, just like I did right now, it's a good idea to remove all your browsing data. You won't have to do this in real life scenarios, unless the target person is constantly loading the same page, which doesn't happen a lot. But if the target person goes ahead and browses a few websites, comes back to zsecurity.org, and perfect, as you can see, we got redirected to the smiley face instead of loading zsecurity.org. Now this will work against all websites, even if they use HTTPS. As you saw earlier, zsecurity uses HTTPS and it loaded over HTTPS by default. The only websites that this will not work against are websites that use HSTS because, again, as I mentioned before, the browser has a list of these websites. The list is stored locally on the target computer, so it doesn't send any requests, and it'll only load these websites over HTTPS. So even though the attack will work, the browser will refuse to load the website that we are spoofing them to. Now, as you can see, what we did so far is not very useful. All we did is we showed a smiley face. But DNS spoofing is very, very useful in so many scenarios. You can use it, for example, when someone is trying to go to a login page and show them a fake page, or if they're trying to go to zsecurity, for example, and then just show them another zsecurity website with some malware embedded into it. You can also use it to serve fake updates. So whenever they have a software that's going to check for updates, we can DNS spoof that request and send them a fake update with a backdoor, and we'll see that later on in the course. So it's a really, really handy skill that can be used in so many scenarios. So far, we saw a number of things that we can do once we become the man in the middle. So we saw how we can see anything a target computer does on the network. So we were able to see the websites, the usernames, the passwords, the images, anything they load on their browser. We also saw that since we're the man in the middle, we're able to redirect them to other websites. So whenever they request a domain, we can redirect them to somewhere else by doing a DNS spoofing attack. Another really cool thing that we can do is modify the HTML, modify the pages as they load on the target browser. Obviously, this is all possible because we are the man in the middle, because we're able to intercept all this data. So we can wait for the HTML code, which is the code that's responsible for loading web pages. And as it flows through our computer, we can insert any piece of code that we want, and the browser will execute this code. Now, HTML is only responsible for rendering the elements that you see on the web page. So it's responsible for the buttons, for the forms, for the text. It doesn't really allow us to do much. But modern browsers can execute JavaScript code. JavaScript is a powerful programming language that we can use to do so many things. We can actually modify the whole page, remove elements or add elements into the page. We can replace links, and this is actually what I did when I modified the HSTS plugin. So I added code that will replace the HTTPS with HTTP, and I also added code that will replace the actual link, the actual domain name, with the spoofed domain name, with the one with the .corn, or to whatever you set it to in the script. You can even use it to hook the browser to other browser exploitation frameworks, which we can use to further exploit the target and even gain full control over their computer. And we'll see that later on in the course. But for now, I'm going to show you how to inject a very simple JavaScript code into the loaded pages, and then we'll build up on that in future lectures and see how powerful and useful this can be. So, right here, I have my Kali machine. And before I run BetterCap and show you how to inject JavaScript, first of all, we need to have some JavaScript code to inject into the target browser. So I'm going to open a text editor and I'm going to write a very, very simple JavaScript code. Like I said, we will see how we can use this to run more useful codes. But for now, we're keeping this simple just to see how we can actually run JavaScript code. So all I'm going to do is alert, open a bracket, quotation mark, and I'm going to say JavaScript test. I'm going to close the quotation mark and close the bracket and add a semicolon. So right here, this code, all it's going to do is it's going to display a warning message, an alert message saying JavaScript code. So since we're going to try to inject this code into all pages, every time we load a web page, we should see a message saying JavaScript test. Now I'm going to save this. So I'm going to go to File, Save, and I'm going to put this in my root directory, and I'm just going to call it alert.js. I'm going to hit enter, and that is saved now in my root. So if I quit it, we can see we have the file right here. So this is the file that contains the code that we want to inject into any web page that loads on the target computer. The next step is to go to our HSTS hijack plugin. So as I showed you before, this was in user, local, share, better cap, caplets, HSTS hijack. Make sure you use the one that I included in the resources, not the one that comes built in with better cap, because the built-in one will not work as you want it. So in here we have the HSTS hijack.cap file. This is the configuration file for the whole plugin. So I'm going to right click this and open it with my text editor. And in here, what we want to modify is the payloads right here. So as you can see in here, it's already injecting a JavaScript file called keylogger.js, but we also want to inject our own code. So I'm going to add a comma here, and I'm going to add star followed by a colon. We added this star right here to say that I want to inject my script into any page that the target loads. If you want to inject your code into specific domains, then you can remove the star and just list the domains that you want to inject this code in right here. But like I said, we want to inject this into all pages, so I'm going to put this as a star, and after the colon, I'm going to put the location of the JavaScript file that I want to inject into the browser. So if we look back in here, this is the file that we just created, which is in root in my home, and it's called alert.js. So I'm going to put in here, I'm just going to say /root followed by alert.js. And that's it. I'm going to save this, Control S, and quit it, Control Q, and we are ready to go. So I'm going to go to my terminal. I'm going to run better cap using the exact same command that we've been using. So we're just giving it the interface as eth0, and we're giving it our spoof file to automatically run the ARP spoofing attack, putting us in the middle of the connection. And as you can see, this is working with no errors, so everything is perfect. What I also want to do right now is run my HSTS hijack plugin. And as you know, all we have to do is just type HS and tab. This will autocomplete. I'm going to hit enter, and everything is running with no errors at all. So everything is perfect. And as you can see in here, it's saying that the payloads it's loading, the JavaScript payloads, are the keylogger. This is the default one that the file already was loading, and the one that we just specified, which is in root alert.js. So now, anytime our target loads any web page, whatever code we put in the alert.js should be injected in the loaded page, and it should get executed. The result of that should show us a simple message saying test JavaScript. So let's go to the target. And as usual, a good idea is just to remove the browsing data, just to make sure that nothing is cached. And I always like to first test with the simplest case and then move on to more complex scenarios. So first of all, I'm going to test it against a normal HTTP page so that there is nothing to bypass, no encryption whatsoever. So we're just going to go to vulnweb.com. And perfect, as you can see, we have an alert message in here telling us JavaScript test. So basically this means the JavaScript code in my alert.js file got injected into this page. So now that we've verified it works against normal HTTP pages, let's go ahead and test it against a page that uses HTTPS. such as stackoverflow.com. Perfect, it's working as expected. Another example would be linkedin.com. Keep in mind, these websites use HTTPS, and as you can see, we're able to load them with no HTTPS in here, so over HTTP only. So even if you log in right here, you'll be able to get the username and the password as shown before. Finally, let's go and test it against a HSTS website using the partial HSTS bypass method that I showed you. So for that to work, we'll need to go to Google first of all, and we need to go to a Google domain that does not use HSTS, similar to google.ie. This is actually the local Google website for Ireland. And as you can see, the code works. This is fine. Google only uses HTTPS anyway. But let's look for Facebook. Now we know Facebook uses HSTS, and because HSTS is used, we should not be able to inject anything on the website because the browser will only load it over HTTPS. But using our partial bypass method, if I click on Facebook from here, as you can see, the code gets executed because what we're loading right now is facebook.corn, not facebook.com. And as you can see, we get a normal Facebook page again that looks identical. And if you log in, you'll be able to get the username and the password. So as you can see, this will work against HTTP and HTTPS pages, and even HSTS if the target searches for that website, not if they put the domain name in here. So if the target comes in and literally types facebook.com manually and hit enter, the browser will force the HTTPS connection, as you can see in here, because like I said, it has a preloaded list of websites that it can only load over HTTPS. And because the browser is establishing a HTTPS connection, the data will be encrypted, and therefore we won't be able to inject anything in it. In the previous lectures, we learned how to use BetterCap to do a number of cool things. But everything we did it through a text or a terminal interface. There is also a web interface or a graphical interface for BetterCap that we can use to do everything that I showed you so far. The reason why I started with the text interface, because first of all, I actually prefer using it and I use that instead of the graphical interface all the time. I think it's faster. You can use it to achieve your goal and launch the attacks much faster. It also requires less resources and less modules. Therefore, it's less likely to fail and it's less buggy. Not only that, but by learning how to use the text interface, I also showed you how to manually modify the caplets and the scripts, where they are stored, and how to use them properly without the need for an extra plugin, which is the plugin that runs the web interface. With that being said, some people still think the web interface is more user-friendly, and that's why I'm going to cover it in this lecture. So I'm going to start BetterCap by typing BetterCap. And I'm going to do -iface to select my interface, which is ETH0. And I'm not going to specify a caplet this time because I simply just want to start BetterCap on the interface that is connected to the target network. So we're going to hit enter and that will run with no issues as usual. Now, if you're using the custom Kali image that I made for this course, then you can simply start the web interface by typing http-ui. But if you're using the original version of Kali, or if you're using BetterCap on a different distribution, then you're going to have to install the web interface. So you're going to have to do ui.update to install it. And then once it's installed, you can simply do http-ui. Now, like I said, because I am using the latest custom Kali that is made for this course, I can simply run it by typing http-ui without having to install anything. And if I hit enter, you'll see that it's going to run with no issues on this URL. So I'm going to copy this and we're going to go and open it in my web browser. And perfect, as you can see, we get the login page for the web interface. So the default username is user and the default password is pass. I'm going to click on login to log in. And as you can see, we have a very simple and easy to use interface. There is no more commands that we have to run, even though we can run commands here through the command line. Right here, we have the event log. So this is similar to what you see in here in the terminal, but it's in a much nicer interface. You can use the search bar here to filter if you're looking for a specific log or for a specific event. And you can actually click any event type to mute it, so you won't see any of that event on screen. All of this is happening in here in the events menu. The next useful page would be the LAN page right here, which will show you all the devices connected to the network. So this is similar to when we used to do net.show. As you can see right now, we only have the router, which is at 10.0.2.1, and my current computer, which is 10.0.2.15. This is Kali. Now, as you know before, we had to start the net.recon and net.probe to discover all of the devices on the same network. So in here, instead of writing the commands, all you have to do is click on this play button to start the net.probe and click on this play button to start the net.recon. You'll get nice notifications in here. And as you can see, we managed to discover all of the connected devices. You can also see in here we have a nice tag to tell us that this is the gateway and a nice tag telling us that this is our computer. And the devices that we discovered are these two devices. And you can see this is my MS Edge device, the Windows machine that we have always been targeting. Again, because this is a very simple web interface, you won't have to type anything. You can click on this little arrow right here beside the machine, beside the IP. You can either scan this machine for ports or add it to your spoofing targets. So you won't have to set arpspoof.targets to this IP. All you have to do is literally click here and it's automatically added to the ARP spoof. Not only that, but we'll see a nice little window in here to configure our ARP spoofer. And remember, we used to set this option to true, the full duplex. So all I have to do now is just click here to check it. And to start the spoofer, all I have to do is click on start spoofing and done. Now we should be spoofing the target. As you can see, we also see a nice icon in here beside this IP to tell us that at the moment we are spoofing this IP, telling it that we are the gateway. So now if I go to my target and just do ARPA, you can see that the router's MAC address has changed to the MAC address of the Kali machine, which is this one. So that means that we are properly spoofing this device, telling it that we are the router, and we managed to become the man in the middle. Now, I've actually showed you how to do all of this before in details, so if you don't remember any of this or if any of this feels strange, then please go back and revise the lectures where I covered these things. Now, I also showed you how to bypass HTTPS and partially bypass HSTS using a caplet. Again, we have a nice menu here for caplets. And as you can see, we have all of the caplets currently available with BetterCap. And all you have to do is just click on the caplet that you want to run. And in my case, it's the HSTS hijack caplet. Also, if you remember, when we were modifying this caplet, we used to have to open the location where the caplets are installed and then open the caplet in a text editor and then modify its options. Whereas in here, you can literally modify any options you want within this menu. Click on the disk icon right here to save, and then click on play to run this caplet. And as you can see, you get nice notifications telling you that everything got executed as expected. And right now we can go ahead and test this. So if I go here and just clear the browsing data as usual, and then if I just go to a normal HTTPS page, such as stackoverflow.com, you'll see that this will load over HTTP. So we can log in and we should be able to get the username and password as I showed you before. And we can test the partial HSTS bypass. So if I go to google.ie and search for Facebook, click on the first result. And perfect, as you can see, it's loading over normal HTTP here again. So if I log in, the information will be captured by my sniffer. So as you can see, it is very, very easy to edit caplets and even run them through this web interface. You can also run all of the other plugins through the advanced menu in here. So for example, if you wanted to start the sniffer, all you have to do is just scroll down here looking for the sniffer. And we have it right here, net.sniff. If I click on that, as you can see on top, it's telling us it's not running. And right here, instead of running the commands, all you have to do is just click on the command that you want to run. Not only that, but if you wanted to modify any of the options, again, all you have to do is just type whatever you want to modify in here, click on the save in here, and then run the command that you want to run. So if I wanted to start the sniffer now, all I have to do is just click on net.sniff on, and this will start the sniffer for me. Now, the sniffer combined with the nice events that we can get in here makes it easier to filter through the data that we capture, but it's still not the best way to filter through the captured data. I will cover how to properly sniff data and filter it using Wireshark, which is the best tool for sniffing and filtering data. But again, this web interface right here provides a nicer way of interacting and using better cap. Now, I didn't show you how to use the Wi-Fi, the BLE, the HID, and the Poison menus because we actually did not use any of these modules previously, so I just wanted to focus on showing you how to do everything we've done so far using this interface. Like I said, it is easier to use, I agree, but once you get used to the terminal interface, it will be just as easy as this one. To me, it's more organized, it can be used to achieve my goals much quicker, it uses less resources, and it's faster. That's why I prefer using it over the web interface, and if it wasn't for showing you how to use the web interface, I wouldn't even install it. But at the end of the day, I wanted to show you both options, and obviously you're free to use whatever is easier for you. In this lecture, we're going to talk about a tool called Wireshark. Wireshark is a network protocol analyzer. It's not designed for hackers and it's not designed for hacking and spying on other people on the network. It's designed for network administrators so that they can see what's happening in their network and make sure that everything is working properly and that nobody's doing anything bad or doing anything suspicious on the network. The way that Wireshark works is it allows you to select an interface and then logs all the packets or all the traffic that flows through that interface. So you're selecting an interface, it could be a wireless card, it could be a wired card on your current computer, and then it'll start logging all the information that flow through that interface. It also has a really nice graphical interface that allow you to analyze this traffic. So it allows you to filter these packets based on the protocol using them, like HTTP, TCP, and all that. It also allows you to look for certain things. For example, if you're looking for cookies or if you're looking for posts or GET requests. And it also allows you to search through these packets. You can search through the information that's stored in the packets and find the things that you're looking for. It's a really, really big tool and you need a whole course for it. So in this course, we're actually going to use it in a few lectures, just covering the basics or the things that's related to us. So the main idea here is Wireshark is not a hacking tool. It only allows you to capture the traffic that flows through your own computer, through your own interface. I'm going to use it now and it's going to become more clear to you. So I'm just going to go to Kali and we're going to start Wireshark. You can run Wireshark from the command prompt or you can just go on all applications and type Wireshark and it'll show up right here. I'm going to click that and that's going to load the program for me. This is just a normal error. Just ignore this error. And this is the main interface of Wireshark. So first of all, you can actually just go to the file and go to the open. And in here, it'll allow you to open a file that you've already captured. So for example, if you captured packets using a different sniffer, using Aerodump, or using Man in the Middle F, or using T-Shark, which is the command prompt part of Wireshark. So if you captured packets using any of these programs and you stored it in a file, you can just come in here, open it, and start analyzing that file. This is really handy because sometimes you don't really want to analyze the traffic on the fly. So sometimes you just want to capture it. Sometimes you're capturing from small laptop, or you're capturing from your phone, and you're not even at home, you're in somewhere else doing your pen test, and then you go back home and then you want to analyze what you captured, then you can store that in a file and then just come here, go to the file open, and open the file that you want to analyze. So what I want to show you here is the idea that Wireshark is not a hacking tool. It's not going to capture things happening in another device. It will only capture things that flow through your own interface. So right here, we can see that we have all the interfaces in my computer. So we can see that we have ETH0, we have any, which is just any, and we have all the other ones that some of them are created by VirtualBox. So the main one here is ETH0, which is the virtual interface connected to my NAT network. And you can see that there is no traffic flowing through this. So you can see that this is constant and nothing's happening. So what I'm going to do now is I'm just going to make this a little bit smaller. And I'm going to open my browser here. And I'm just going to go to a normal website. I'm just going to go to google.com. Now, as you can see right here, you can see the traffic in ETH0 is spiking up. So there was some traffic generated through ETH0. So if we're sniffing on this, we'll be able to capture these packets that were sent over ETH0. Now, what I'm going to do is I'm going to go to my Windows machine just to prove that point. And I'm going to browse the website here. And you'll see that ETH0 will not be affected. And the traffic that's generated on this Windows machine, which is in the same network as the Kali machine, it will not be captured by the Kali machine. So if I just go to Google again here, you'll see that nothing happened in ETH0. So there is no traffic flowing through this. It's still constant. And we can only capture packets that go through ETH0. So now you'll probably ask then why Wireshark is so useful. Why are we even talking about it if we can only see things that go through our own computer? Why are we talking about it? Well, we're talking about it because we've seen there is a large number of ways that you can become the man in the middle. We learned how to do this using ARP spoofing, and in future lectures, I'm going to show you how to do it by creating a fake access point. So when we are the man in the middle, if we start sniffing on the interface that's used to become the man in the middle, we'll be able to capture all the traffic generated by the people that we're targeting in our man in the middle attack. So if you started a fake access point, you can start sniffing on the interface that's broadcasting the signal, and you can capture all the packets sent or received to anyone who's connected to that fake access point. If you became the man in the middle using ARP spoofing, then just select the interface that you used when you launched your ARP spoofing attack. So for now, I'm going to become the man in the middle using ARP spoofing. You can use ARP spoof or bettercap as I showed you earlier, but I'm going to use bettercap using the exact same command that we used to do. So we're literally just doing bettercap, followed by the interface that is connected to my target network, which is ETH0, and I'm launching my caplet, the spoof caplet, so that it configures the ARP spoof module and runs it for me to put me in the middle of the connection. So I'm going to hit enter. And as you can see, it's working as expected. So right now I should be in the middle of the connection, intercepting anything the target Windows machine sends or receives. Now let's go to the Windows machine and see if I do anything here, if it's going to affect the traffic in ETH0. So we'll see if Wireshark will be able to capture traffic generated by this computer. So let's write anything here. I'm just going to Google, or I'm just going to go to a different website. I'm just going to go to Bing. And if we come back here, you'll see that we have traffic being generated here. And we can see that ETH0 is actually capturing whatever that's happening in a completely different device. This is happening because when we are the man in the middle, all the packets that's generated by the Windows device is actually being redirected to my own computer right here, to the Kali. And then Wireshark is sniffing that from the Kali machine. It's sniffing it from my own local machine. It's not sniffing it from the network. It's not sniffing it from the target computer. So again, if you're doing this with the fake access point, then just listen on the interface that you're broadcasting. If you're doing this with a real wireless network, if you're connected to your home wireless network using LAN 0, then you can just do this with LAN 0. But with ARP spoofing, you have to first redirect the traffic, then you can use Wireshark. Now, this is just to show you what Wireshark is and how it works, and I just wanted to stress the idea that Wireshark is not a hacking tool. It's only a program that allows you to log packets flowing through a certain interface and then analyze these packets. So in the next video, we'll see how we can sniff and analyze packets using Wireshark. In the previous video, we seen how we can launch Wireshark, and we said that we can actually just open a file that contains packets that we already captured, and we can start analyzing them using Wireshark. In this video, I want to start sniffing packets and then generate some traffic in my Windows machine, and then we'll see how we can analyze these packets using Wireshark. So I'm already the man in the middle. As I said, you first have to be the man in the middle to use Wireshark. And then the traffic that's generated in the Windows machine is actually flowing through ETH0, as we've seen in the previous video. So before I start capturing the packets, I want to go to the options, and I just want to show you what options we can set. So first, you can see all the interfaces that you have, and you can see the traffic generated on them. And you can see ETH0 is actually generating some traffic every now and then because it's actually coming from the Windows machine. So in here, you can select the interfaces that you want to start capturing on, and you can actually select more than one interface, and all you have to do is just hold the control and then click other interfaces that you want to listen on. For example, we can just click them like this. But for now, I actually only want to sniff on ETH0. Now, if we go on the output, you'll see that you have an option to store these packets somewhere. So again, if you only want to sniff and you don't want to analyze things, then you can just go on the browse and you can store the packets that you're gonna sniff somewhere, and then you can analyze them whenever you have the time at a different time. You can just open them with Wireshark like I showed you in the previous video. You can just go on File, Open, and then open the packets and start analyzing them. Now, I have ETH0 selected, and I'm just gonna click on Start. And that will start capturing packets. Anything that's going to flow through ETH0 will be captured, and it will be displayed in here. Anything. I mean, images, pictures, messages, cookies, anything that computer does on the internet will flow through ETH0 and therefore will be captured by Wireshark. So it's not like Man in the Middle Life where it was only showing us the important information. Right here, you'll see anything, all the traffic that's generated. Now, I want to go and generate some traffic on the target computer so we can analyze it here. But before I do that, I'm going to go back to BetterCap. And I want to start my HSTS caplet so I can downgrade HTTPS to HTTP. Because if everything goes over HTTP, we won't be able to see or read anything because, like I said, everything will be encrypted. So I'm going to hit enter. This will work as expected. We'll go back to Wireshark and let's go to the target computer. I'm going to go to google.ie and let's search for something. So for example, let's search for Z-Security. And keep in mind, everything is loading over HTTP in here. So that's why we'll be able to read and analyze everything that we're loading right here. Now, let's go back to Wireshark and see how we can filter this information and discover the websites visit by the target, see the requests and all that. So I'm going to click on the stop button to stop this. Now this is the main interface of Wireshark, and you can see that the first thing we have is each one record of this is a packet. Now you'll see here the columns. First of all, here is the number of the packet. So you have this one is number 1, number 2, number 3, number 4. In the time, you'll see the time when this packet was captured. So 0 is when we first started sniffing, and then the time increases as we go down, and it shows when these packets were captured, when they were sent basically. You can also see the source. So this is the device that the packet was sent from. And you can see that this one is not sent from our target. It's actually coming from the internet, from a server that has this IP, and it's going to our target computer, which is 10.20.14.206. You can see the protocol. So it's TCP for this one. You can see that it's ICMP in this one, and you can see that it's ARP for this. You can see the length, which is the size, and you can also see info about this packet. Now you can also notice that these packets have different colors. Usually green is TCP packets, dark blue is DNS packets, and if we go down, we should actually be able to find some of them. And you can see all of these are DNS packets. Light blue usually is UDP, but we don't have any UDP packets at the moment. And you can also see that we have some black packets, and these are TCP packets that had a problem, that had issues. Now I know what you're thinking. There are so many packets in here, and a lot of them might not be useful to you, depending on what you're trying to get. But don't worry about this. In the next lecture, I'm going to show you how to filter these packets to only display the relevant ones, and then analyze them to extract the useful information. In this lecture, I want to spend more time with Wireshark, showing you how to filter all of these packets to only display the useful packets, how to trace them, what do they mean, and how to display more information about each one of these packets. Now, what we did on the target computer so far, most of the traffic that we generated was HTTP traffic. So to get rid of all this information that's hard for us to read, we're just going to type in here in the filters, we're just going to type in HTTP. Hit enter. And as you can see now, that filtered all the packets to HTTP traffic only. So this is the traffic that was basically sent by the browser and is usually sent by web browsers. They always send traffic over HTTP or HTTPS. And since we're downgrading HTTPS to HTTP, you want to use the HTTP filter to see everything that a target person is doing on the browser, regardless of what they're doing, whether they're browsing websites, whether they're watching a video, whether they're looking at images, whatever they're looking, it will be loaded over HTTP. So, looking at the first record right here, we can see that this request is sent from this IP, which is the IP of my target, to an IP on the internet. So we can see that this is not a private IP, this is an IP on the internet. So it's sent to a server. And if we double click this record, we'll get much more information about the packet itself. So we have the information about the frame, which includes the size of the packet. It includes the interface that it was sent on, the time, and all that. In the Ethernet, we have information about the source MAC address and the destination MAC address. So where did this packet go from and where did it go to? Remember when I first spoke about packets and how they always travel from a source MAC to a destination MAC. So this information is all stored in here. In the Internet Protocol, we have information about the IPs. So in the Ethernet, we had information about the MAC addresses. In the Internet Protocol, we have information about the source IP and the destination IP for this particular packet. In the Transmission Protocol, we have information about the port. So we can see that this went from this source port to port 80. This is usually the default port used on web servers. So in most cases, whenever data is sent to a website, it will always be sent to port 80. But the most important part in here is the Hypertext Transfer Protocol, which is basically the data sent over HTTP. Clicking on this will give us information on whatever that has been sent over HTTP. And like I said, this would contain everything that was sent to and from a browser. So right here, we can see that this particular packet sent a GET request to a website called google.ie. Now, this is literally when we typed google.ie, we didn't search for anything. We didn't really do anything. You can also expand this to see more information about the actual request. And you can even see the HTTP header sent if you want to get more information about this particular request. Now, this whole method of getting information follows with all types of packets. So you can double click any packet you have and you'll be able to read the data sent within this packet. Now, you can also in here see an arrow, which basically means that this was a request. And the arrow back here marks that this was a response to this request right here. Now, moving down, you can also see requests for images. What you can also do is click on any of these packets. For example, again, back to this GET request, right click it and go to follow HTTP stream. And this will basically follow the stream that this request has caused all the way down to the response. So if I click it, you'll see the response for this particular request was this right here. You can see that this was a PNG. And literally the binary content of this PNG image is right here. So as you can see, we're literally getting the raw data in here. Now I'm going to close this and go back to what we had, which was HTTP. Now if we keep going down, you literally see everything that has been sent and received by the target. So for example, again in here, we can see this was a JavaScript file that was loaded by Google. Then in here, we can see another GET request. And this GET request was what we searched for Z security. So you can even see the search term in here. So let me double click this to show you in more details. Again, this automatically went to the hypertext protocol part. Like I said, this is the HTTP part, whatever that gets sent to the browser. And you can see that this was sent to google.com first of all, and the URI, so whatever went after google.com was search, and what we were searching for was that security, which is exactly what we typed in here. Again, in here, you can see the full URL with the search term. This is literally what the user gets in their URL bar in here. So as you can see, Wireshark literally shows everything that flows through the interface. In this lecture, I wanted to show you a quick overview on how we can filter data. And don't worry too much about this. We'll actually be using it more in the next lectures, and we'll see how we can easily use it to filter data and discover useful information. Now in this lecture, I want to show you how to use Wireshark to discover data sent through forms whenever someone fills up a form. And obviously this will allow us to get usernames and passwords if people log in to their accounts. So I'm already running BetterCap, so I'm already the man in the middle. And in Wireshark here, I'm just going to start a new capture. So I'm going to continue without saving this one. The filter is already set to HTTP, so it's only going to show me HTTP packets in here. And I'm going to go to a target website in here. So let's go to vulnweb.com. Now keep in mind, like I said, you have to be logging into a HTTP page, but that's fine because we already learned how to bypass HTTPS and even partially bypass HSTS. So I'm going to be logging into a website that just uses HTTP here because it's just simpler, and we've already learned how to bypass HTTPS and HSTS, so there's no point of repeating that. We're logging in with a username that is set to admin. I'm going to set the password to 123ABC. I'm going to click on login, and this should have been captured by Wireshark. Now let's go ahead and actually try this with a website that uses HTTPS. So let's go to stackoverflow.com. Again, as you can see, as long as the website gets downgraded to normal HTTP, then we'll be able to capture the data sent to and from this website. So we're just going to log in, put the username, we'll put it to zaid@zsecurity.org, and then we're going to put the password. So we'll just do 123 ABC. And let's go back to Wireshark and see how we can discover the username and the password. So first of all, I'm going to stop the capture. And what we want to look for is post requests. So you see in here, this request right here was post, for example, and here it was get. Now forms are usually sent over post, especially login forms. So if you're looking for login information, you want to look for post in here. So going down, we can see we have a post request in here. Now I'm going to click here to actually show less information so it's easier for us to see. So we can see this post was sent to Google. We're not interested in that. We're looking for stuff that was sent to VulnWeb. So I'm going to keep going. We can see we have a post request here to a login page. So this is definitely interesting. Now if we look down, let me just make this smaller. So if we look down here and look at the HTML form data, you can see that we have a username here submitted to testhtml5.vulnweb.com. The username is admin and the password is 123ABC. Now if we scroll down again looking for post requests, you can see we have a post request for a page called users login. So again, very, very interesting. If we click on this, you'll see, if we scroll down, you'll see we have the email, zaid@zsecurity.org, and the password 123ABC. Again, this just goes to show you that with Wireshark, you'll be able to capture everything. Now, this can actually be very, very useful because I noticed that BetterCap is great at sniffing passwords, and it pretty much gets you the passwords all the time. But in the odd cases, sometimes it was failing to filter the username and the password for me. So with Wireshark, you'll actually be able to get everything that passes through your interface. So what you could actually do is you can just go to your caplet that we always use, the spoof caplet, this one right here, open it with a text editor. And as you know, in this caplet, we turn on our sniffer in here. So we set the sniff.local to true, and then we turn it on. But before turning it on, you can actually set the net.sniff.output to a location for a file that will contain everything that BetterCap captures. So you won't actually have to start Wireshark while BetterCap is working. You can just in here specify a place. So for example, let's say root capture file.cap. And then when you run your spoof caplet, it'll turn on the probe, turn on the recon, run your spoofing attack, putting you in the middle of the connection. It'll run the sniffer as well, and it'll store everything that BetterCap captures in a capture file. Then all you'll have to do is come here, go to File, Open, and open the file that you captured and analyze it as I'm doing right now. So this can be very, very useful also if you don't have a lot of resources on your computer, or if you had a small laptop or even a phone and you capture data with it. Store everything in a capture file and then just open it in here in Wireshark and analyze it. Now finally, before I finish this lecture, because all we're talking about right now is filtering data, a really, really useful feature when filtering data is the Control F feature, the find. So you can just press Control F from your keyboard. This will open this bar right here, the search bar, which you can use to find anything within the captured packets. So first of all, I'm going to set the search to search within the packet details. I'm going to keep this to narrow and wide. In here, I'm going to set this to string so that it looks for normal text. And for example, let's say I'm looking for logins that a person named Zaid has attempted. All I have to do is just type Zaid. And if I hit enter, and as you can see, it's taking us to the login attempt when I logged in to Stack Overflow. Or let's say you're looking for login attempts by a person named admin or for a user named admin. Again, if I hit enter, it's going to take me to the first time an occurrence of the word admin happened, which is in here. It doesn't really contain any useful information, but I can just click on find to find the next packet that contained the word admin. Again, this packet doesn't really contain anything useful. We can go next. We'll actually have to go to the end of the file and go up because that was the first thing that we logged in. So I'm just going to keep clicking on next. And right here we have the post request for the admin. And if we go down again, as you can see, we have the username as admin and the password as 123ABC. So this feature can be very, very useful to help you find what you're looking for. Whether you're looking for a specific login name, whether you're looking for a specific tag, a specific file, and so on. Now, from the previous lectures, we know once we connect to a network, it's game over. Because once connected, we can run an ARP spoofing attack to redirect the flow of packets so that they go through our computer. This allows us to become the man in the middle, and once we're the man in the middle, we can run so many dangerous and effective attacks. So we can spy on all the users, steal their passwords, redirect them to different websites, and this is all just a small taste of what you can do. You'll actually see us build on this in the client-side attacks section, where we're going to completely hack into computers connected to the same network as us. And if you go and do my advanced network hacking course, then you'll see more advanced attacks that'll allow us to do so many cool stuff on the network. Again, all of this is possible because once we connect, we can run ARP spoofing and become the man in the middle. Now in this section, I actually want to show you another method that'll allow us to become the man in the middle. And once we're the man in the middle, we'll be able to run all of the attacks that you've seen so far and all of the other man in the middle attacks that you'll learn in the future. So let's go back to the first diagram that we learned in this course. When we were talking about how networks work in general, we said the only device that has access to the internet is the access point, and whenever a client wants to access something, they send the request to the access point goes to the internet, gets the response, and send it back to the client. Now, what if we replace this access point with our hacker computer? So what if we can use our machine to create a Wi-Fi network that actually has internet access, so people will actually try to come in and connect to our network to access the internet, and then when they connect to our network, by default, we will be the man in the middle because we are the router. So we won't really need to exploit anything. We are automatically the man in the middle, and the clients will automatically send us any requests because they want to access the internet, and we will see these requests, obviously, go to the internet, get them what they want, and give it back to them. This way, we'll be able to launch all of the attacks that I showed you previously without the need to exploit the ARP protocol, so without the need to run ARP spoofing. All we'll have to do once our network is running and we have clients connected, we can just start sniffing using Wireshark or BetterCap. So, for this to work, you need a computer, and we already have our hacker computer with Kali Linux. You also need internet access, and you need a wireless device that's going to broadcast the Wi-Fi signal and tell all the neighboring devices that I am a network, you can come in and connect to me. So, you will need, first of all, an interface that has internet connection. This interface, it can be a Wi-Fi interface connected to the internet, it could be an Ethernet interface connected to an Ethernet network, it could be a 3G or a 4G dongle, And it even can be a virtual interface, and this is what I'm actually going to do. It's going to be my ETH0, the virtual interface that is connected to my NAT network. So this can be any network device as long as it has internet access. The next interface that you will need, like I said, it's gonna have to be a Wi-Fi interface because it needs to be able to broadcast the signal for the network. And you can't use any Wi-Fi interface. This interface needs to be able to act as an access point. So it needs to be capable of acting like a proper access point, like a router. Now, all of the Wi-Fi adapters that I recommend support this mode, and I've already included a video in the resources before when I first spoke about wireless adapters, but I'm also going to include this video in the resources of this lecture. So if you're going to buy one, or if you're not sure how to pick the right one, then check out this video. It should be helpful for you. So once we have this set up properly, we can use our computer to start an access point, and it's going to act exactly like a router. So people will be able to see the network when they look for Wi-Fi networks. They'll be able to connect to it and get internet connection. But when they connect, they will have to send us all of their requests because we are the router, we are the access point. So by default, we will be the man in the middle. Therefore, you'll be able to execute all man-in-the-middle attacks that you learned so far and any other man-in-the-middle attacks that you will learn in the future. So basically, ARP spoofing is one method of becoming the man-in-the-middle, and what I'm going to show you right now is another method of becoming the man-in-the-middle. Now, you can see that in order to use our computer as an access point, we need a number of components to be configured properly. So first of all, we need our wireless interface to broadcast the signal as if it's a real network. This will allow other clients to connect to it, but that's not the end of the road. The wireless interface needs to know when these clients are requesting websites. It needs to be able to forward these requests to the other interface that is connected to the internet. Then again, it will need to be able to know when the responses come back and forward all of this to the right client. Now you can configure all of these things manually, and I actually cover this in my advanced network hacking course, and I cover a lot of advanced things that you can do with the fake access point, like launching an evil twin attack, hacking into WPA2 enterprise, and so on. But this would take at least 30 lectures, and this is not a network hacking course. This is a general ethical hacking course. Therefore, that would be out of the scope of this lecture. If you're interested in learning how to do this manually and how to run advanced attacks using the fake access point, then check out my advanced network hacking course in the bonus lecture, the last lecture of this course. For now, for this course, I'm going to show you a great way of quickly creating a fake access point that will allow us to become the man in the middle, similar to what's shown in this diagram. Now, before doing anything, I want to show you the network settings of my Kali machine. So I'm going to select it here. I'm going to go to Settings, Network, and as you can see, it's set to use a NAT network. So now if I go to my Kali machine and do ifconfig, we'll see we have an interface called ETH0. This interface is a virtual interface created by VirtualBox because we set this machine to use a NAT network. You can also see that this interface has an IP address, which means that it is properly connected to this NAT network, and it will provide the Kali machine with internet access as long as my host machine right here has internet access. So now on my Kali, if I go and let's say if I just go to bing.com on my browser, you'll see that I can successfully go to the website because Kali is connected to the internet through this virtual interface that is called ETH0. Now, if we go back to our diagram that shows what we need to create an access point, you can see that we need an interface that is connected to the internet. We don't care what type of interface this is, as long as this interface has internet access. So in our example, we're going to be using ETH0 to provide our fake access point with internet access. The other interface that we need, we said that this needs to be a wireless adapter that is able to act as an access point. Again, if I go back to the result of my ifconfig, you can see I already have a wireless adapter connected to this computer. It's called LAN 0. Keep in mind that this is in managed mode. It's not in monitor mode. And it is not connected to anything. So you can see it does not have an IP address. This is very, very important. It needs to be, first of all, in managed mode, and second, not connected to any network. So even if we go at the network manager in here, you can see we have wired connected. This is my ETH0, and Wi-Fi not connected. Once we have everything configured properly, we can go ahead and start the fake access point. The program we'll use is called Wi-Fi Hotspot. It's pre-installed in the custom Kali Linux that we made for this course. So all you have to do is simply click on Show Applications in here and type Wi-Fi, and you'll have the application in here. Now, if you're using the original Kali, I'm going to include a link in the resources that you can use to download and install this tool. But right now we can simply click on it right here to start it. And as you can see, it has a really nice graphical user interface that is self-explanatory, but I'm just going to walk you through it real quick. You can see, first of all, it's asking us for the SSID. This is the name of the network that the clients will see when they look for Wi-Fi networks around them. So I'm going to keep this as internet. Next, it's asking us if we want to have a password on this network. So I checked the open box, which basically means this will be an open network with no password, because it makes more sense in our scenario so that we can attract more people and spy on their traffic. If in your scenario it makes more sense to have a password on the network, then you can uncheck this box and put the password in here. So I'm going to check it back in because I want it to be open. And next, it's asking us for the Wi-Fi interface. This is the interface that will be broadcasting the signal. So this will be this interface right here. And in our case, this is my wireless adapter and it's called LAN 0 as we seen earlier. And next, it's asking us for the internet interface. This is the interface that will provide the fake access point with internet access. Again, going back to the diagram, this will be the interface in here. And we said it doesn't matter what type of interface. It could be a wireless card or a wired. It doesn't really matter. In my case, I'm actually getting my internet access from ETH0. So it's already selected correctly. And that is my virtual interface that is connected to my virtual NAT network. Now, before starting the access point, let's click on the advanced just to have a look on the other options that we can set. So you can see you can select the frequency band. You can set it to auto or 5 gigahertz. You can set this network to be hidden. You can use a pre-shared key. You could set the MAC address of the network. You could configure it to not use any virtual interfaces. This might be useful to try if it's failing to start, but we're going to keep it the way it is. You can specify the channel that you want the network to broadcast on. You can check this box to use MAC filtering and then specify the MAC addresses that you want to allow to connect to this network in here in this box, so that only the specified MAC addresses in here are allowed to connect to this network. Again, we don't want to do this in here. And you can also select the standard in here for the N and the AC. we're just going to keep everything on the default settings in here. We really don't need to change anything in our specific scenario, but I just wanted to go through it real quick just so you have an idea in case any of these options make sense in a future scenario that you'll find yourself in the future. So the main things that you'll really need to set when you're starting a fake access point is the name, the Wi-Fi interface, and the internet interface. And once you're ready, click on Create Hotspot. And perfect, now it's running, as you can see, and it's giving us the process ID that it's running through, just in case it freezes and you need to kill it through the terminal. But now we have a fake access point that looks like a real Wi-Fi network with internet access that is broadcasting within our range, and the name of this wireless access point is Internet. So let's go to the Windows machine and see if this access point is working as expected. So right here I have a Windows machine. It's another virtual machine, but I have another wireless adapter connected to this machine. Do not test this from your host machine because the fake access point is getting its internet access from the host machine through the NAT network. So if you test this network from the host machine, the network will not work. So either test it from another virtual machine with another wireless adapter, or if you don't have another wireless adapter, then you can test it from your phone or from another laptop or any other computer within range. But do not ever test it from the host machine. So right here, I'm going to search for networks to connect to. And as you can see, I have a network called Internet. It does not use a password, so I'm just going to connect to it. As you can see, I'm connected now, and I'm going to open Firefox just to check if I have internet connection. So I'm going to go to bing.com. And as you can see, bing.com is loading, so now I actually have internet access. So now anything I do on this computer will have to be sent to the access point. If I want to access any websites, if I enter any passwords and usernames, everything is going to go to the access point. And the access point is the hacker machine, so the hacker machine is already the man in the middle. So now you're at the same position that you would be after running an ARP spoofing attack. So you can go ahead and use Wireshark to sniff packets and analyze them, or you can go and use Bettercap exactly as I showed you before. The only thing that you need to keep in mind when using Wireshark or any other tool, you need to set the interface to the interface that is broadcasting the signal. So this is the interface that you set in the PHY option, not in the upstream. So in my case right now, this would be LAN 0, not ETH 0. Once you're done and you want to stop this access point from running, don't click on the X. Make sure you click on stop first to stop it properly. And then you can exit the program and continue whatever you want to do. Right, so let's talk about how we can detect ARP poisoning attacks. First of all, let me show you the ARP table. So in our Windows device, which is the device that we always attack, I'm going to run a command, ARPA, to list all the entries in the ARP table. So each computer has an ARP table, and that table associates IP addresses with MAC addresses. So we can see the IP address of the router, which is 10.20.14.1, is associated with the MAC address 52.54, and it ends up in 35.00. So this is the MAC address for the IP for the router. So the way that ARP poisoning works, like we discussed before, is it works because each request is trusted and clients accept responses even if they didn't send a request. So what the hacker does is he sends a response to the client telling them that they are the router. So the client will accept that, it will trust it, and it's going to accept the response even though it didn't send a request. Then we'll send another response to the router telling them that we are the client. So what this is going to do, it's going to modify the entries in the ARP tables in both in the router and in the client. And for the client, it's going to contain the hacker's MAC address, and it's going to associate that with the router's IP address. So what's basically going to happen is it's going to modify the MAC address here, and it's going to change that to the attacker's MAC address instead of the router's real MAC address. So when that happens, then the hacker will be in the middle of the connection, and they'll be able to read, analyze, and modify the packets because they're going to be flowing through the hacker device. So let's run the ARP poisoning, a normal ARP poisoning attack like we always do it. And when I go back here, I'm going to execute the same command. So I'm going to do an ARPA again. And note how the MAC address is going to be different. So the MAC address for the router, it used to be this one. And when we ran the command, then the MAC address changed to this one. And this MAC address right here is the MAC address of the network card that the attacker is using. So if I come here and just do an ifconfig, you'll see that this is the MAC address, the same MAC address that is displayed in here. So this is the easiest and the simplest way to discover ARP poisoning attacks. It's not the handiest way though, because you're going to have to keep doing this command and keep comparing the entries if you really wanted to check if you're being ARP poisoned. So there's a tool called XARP, and it does that automatically for you, and it's available for Linux and Windows. So I already downloaded. You can just Google XARP and you can download it. Very easy to download and install. And I'm just going to run it. I'm actually going to stop the attack first, and then I'm going to run the tool. Now notice when you stop the attack, the IP address is going to go back to what it was. So you can see that the MAC address of the router is back to its default right value of the router. So I'm just going to run XARP now. And you can see that everything is good. And you can see that the entries are very similar to what we did when we did ARPA. So we have the IP addresses and the MAC addresses associated with it. What the tool basically does, it's just going to automatically monitor this. And whenever something changes, it's going to know that something's wrong is happening because each IP address should have a unique MAC address. There should be no duplicates in the network. So I'm going to do another ARP poisoning attack exactly like we did it before. And when we come here, you'll see that XARP is giving us a notification and telling us that something's happening. It's telling us that the MAC address for the router, which is the 10.20.14.1 IP, has changed from this to that. And if we look here, I'm going to click OK. And if we look here, we can see that the affected machines are the router, my own machine right now, and the attacker. Sorry, that's me, and that's the attacker. So basically, we know that the machine at 10.20.14.203 is trying to do an ARP poisoning attack because it's the one that the router's MAC address has changed to. Therefore, we know this is the attacker machine. So this tool is really handy because it does the monitoring automatically for us, and it'll tell us whenever someone is trying to ARP poison the network. Okay, so now let's see how we can use Wireshark to discover suspicious activities in our network. And before I do anything, I'm going to go to the preferences. And I'm going to go to protocols, ARP. And I'm going to enable the option to detect ARP request storms. What this will do, it'll actually discover if anybody is trying to discover all the devices on the network, and it's going to give me a notification. So I'm going to click on OK, and I'm going to start my capture. And now I'm going to go to my Kali machine, and I'm going to use Net Discover. So I'm not going to do ARP poisoning. I'm only going to try to discover all the connected devices to my network. So we're using exactly the same command that we used before, Net Discover, interface, and the range. I'm going to hit enter. And we can see that Net Discover finished. It discovered all the devices that we have. So if we come here, even before we look at the output of the notifications. Let's just look at the packets that have been generated. You can see that there's a device here. This source is broadcasting, so basically it doesn't have a destination. It's asking all the other devices in the network, and it's inquiring about each possible IP. So it's basically asking who has this IP and tell the 67 IP. And then it's asking who has the 241 IP, tell the 67. Who has the 251, tell the 67. And it's doing this for every possible IP. So it's basically checking if any possible IP in the range exists, and it's asking to return the response to the IP at 10.20.14.67. So from this, we can deduce that someone is trying to discover all the connected devices, and that someone is at 10.20.14.67. Now, if we go on the Analyze and Expert Information, you'll see that we detected an ARP packet storm. So basically it means that there was a single device sending a very large number of ARP packets. So they're probably trying to discover connected devices or trying to discover connected ports. So it's telling us that this person is trying to do something suspicious. Now let's go, and I'm gonna do a ARP poisoning attack, and we'll see if we can get any notifications or warnings in Wireshark. Now I'm gonna go to Analyze and Expert Info again. And if we look, we'll see we have a warning here. And the warning is telling us that there is a duplicate IP address configured. So again, this is telling us that the IP address of the router had two different MAC addresses. What this means, basically, it means that someone was tampering with this and tampering with our ARP table, trying to place themselves in the middle using an ARP poisoning attack. Now, we've seen a number of methods to detect ARP poisoning. Let's discuss how we can prevent it or protect ourselves from it. Now, I'm just going to run an ARPA, and we're going to look at our table. There is switches that will monitor this for you as well, and they'll notify you or even prevent ARP poisoning attacks. Another way to do that is, if you look at here, if you look at your router, you'll see that this entry in the table is dynamic. So the type of this entry is dynamic. What that means, it basically, this can change. It's the system allows this value to be changed. You can see right here, you have static values, which basically means the system will never allow these values to change. So you can use static ARP tables, which basically means that you'll have to configure each IP address. So you have to actually configure your ARP table and map each IP address to the MAC address, to the relevant MAC address. But once you do that, even if someone tries to send a response to your computer trying to change it, the system will refuse to change anything because you configured your ARP table to be static. The only problem with that is every time you connect to a network and every time there is a new device connecting to your network, you'll have to manually configure that device to work with your network. So it's not a very useful solution if you're in a big company or if you're in a big firm, but maybe in a small house or in a small company, then this would be a really good solution to prevent ARP poisoning attacks, because everything is going to be static. You're going to have to set it up manually. But when someone tries to do an ARP poisoning attack, even if their attack is successful and they use the best tools they can, your table is set up in a way that it's fixed. It can't be changed. So the system will always refuse to change the values of the MAC addresses, which will basically mean ARP poisoning attacks will never work against you.
In the previous lectures, we learned how to detect ARP spoofing attacks by manually analyzing the ARP tables. We also learned how to install tools such as XARP to automatically detect ARP spoofing attacks without having to manually check the ARP tables. And we even learned how to detect other suspicious activities using Wireshark. Now this is really good, but still has a few problems. First of all, we're only talking about detection. So even when we detect that someone is intercepting the connection, we can't really do much. All we could do is simply disconnect from the network, maybe change its password if we can, if we own the network, to something that's more difficult, or if this is a public network such as an airport, a hotel, or a college network, then all we can do is simply just disconnect and use a different network because we can't change its password. The other problem with the previous methods, like I said, they're only detection methods. Therefore, they'll only work if the target managed to become the man in the middle using ARP spoofing. But what if someone is able to intercept the connection using another method? For example, if someone is running a fake access point, like I showed you earlier, and you connect it to this fake access point. Or if you connect it to a hotel, a college, a public Wi-Fi network, a cafe network, and the admin of that network is actually collecting data, or someone or a hacker gained access to the admin's computer and again is analyzing the data. Because by default in fake networks and in any network, the admin is able to see the traffic because the traffic will have to go through their server or through their router. So the detection methods that I showed you earlier won't even work against this. Therefore, in this lecture, I want to discuss two solutions to this problem. So the idea is you use these solutions if you discover that you're being attacked, or if you're connecting to a network that you don't own and manage yourself. So if you're connecting to a college network, an airport network, a cafe network, or any other network that you yourself don't have control over. The solution to all of this is to encrypt your traffic. If you encrypt your traffic, we don't really care if somebody is able to intercept this traffic because our traffic is going to be encrypted, therefore it'll be gibberish and it won't be useful to anybody that is intercepting our traffic. So there are a number of ways to do this, and I'll explain how they work as we go through it. So let me show you this in action. Right here, I'm already running BetterCap, and as you can see, it's already getting information. And right here is my target, and we're already on VulnWeb. And if we just click on anything just to show you, you'll see the domain is going to be detected in here. And then let's just quickly log in. You'll see this login attempt will be detected. So we have the username is admin and the password is test. Again, if we try, I'll just open a new tab and go to Stack Overflow. You'll see it'll load over HTTP, not HTTPS. So again, if I go ahead and log in, I'll be able to log in and detect the password. And the HSTS method that I showed you earlier, again, it'll work and we'll be able to bypass that and steal the password. So right now, this Kali machine is able to intercept all the data that is sent to and from my Windows machine right here. So the first method to prevent these attacks, so we don't care if we're being attacked. Again, I'm not running XARP, I'm not managing my ARP tables. I don't care if someone intercepts my data. What I'm going to do is I'm going to install a plugin on my browser called HTTPS Everywhere. So I'm going to be installing it on Firefox. I'll include its link in the resources of this lecture, but there is an equivalent of this plugin for most browsers such as Chrome and others. All you have to do is simply click on Add to Firefox or Add to Browser, whatever browser you use. We're going to click on Add in here. And that's it. The plugin is added in here. As you can see, we're going to click on OK. And we can manage it here from its icon on the top right. So as you can see right now, it's set to off. And if I click this, I will turn on this plugin. And basically what this plugin will do, you can think of it as if it adds HSTS support to more websites, pretty much to any website that uses HTTPS. Therefore, for example, when I tried to access Stack Overflow in here, I was able to downgrade it because my browser does not know that this website should be loaded over HTTPS, and BetterCap was downgrading the HTTPS requests to HTTP. Like I explained in previous lectures. What this plugin will do, similar to HSTS, it has a list of websites that support HTTPS, and therefore, when we try to downgrade the HTTPS connection of this website to a HTTP connection, it'll tell the browser, no, don't do that, and it will upgrade it again back to a HTTPS connection. So let me show you. I'm just going to delete the history, and I'm going to load Stack Overflow again. And perfect. As you can see, it's loading with HTTPS in here. Therefore, now if I go and log in, my information will be encrypted, and therefore the hacker won't be able to see my username and password. So that's really, really good, but not perfect. Let me tell you why it's not perfect. First of all, if we go back to a HTTP website, again, similar to what we have in here in VulnWeb, so I'm just going to log out. And we'll log in again with another password. I'll just put the password now to 12345678990. We'll log in. And if we go back here to the logs all the way down, you'll see we are still able to detect the username and the password. So this plugin is really good for websites that support HTTPS. It'll force us to load HTTPS on websites that support HTTPS. But if you access a website that only uses HTTP, such as VulnWeb, I know there aren't a lot of websites that do that, but they still exist. So if you access any website that uses only HTTP, then that website is still open to the hacker. So the hacker can still see this information. They'll still be able to steal usernames and passwords if you send usernames and passwords to them. Not only that, but they will also still be able to replace downloads, serve you fake updates, or inject JavaScript code like we seen earlier and get you hooked to beef. HTTPS everywhere also does not prevent the hacker from seeing the websites that you access and running DNS spoofing attacks. Let me show you. So if I just go to bing.com, for example, and then let's go to duckduckgo.com. Keep in mind, HTTPS everywhere is still working, and let's go to the hacker machine and just look at our logs. So as you can see, we can still see that our target went to DuckDuckGo. We can still that the target went to Google. We can see that the target went to Bing. So we can still see the domain names, but we can't see the data that gets sent because that will be encrypted with HTTPS. So there is still some data that the hacker is able to get. If you want to take your security to the next level and completely encrypt everything you send and receive, then you should think about using a VPN. Therefore, in the next lecture, I'll explain to you what a VPN is, how it works, and how it can protect us from hackers or anybody that intercepts our connection. In the previous lecture, we discussed a good solution to protect us from man-in-the-middle attacks, and that solution was to use HTTPS Everywhere plugin. With this plugin, as seen earlier, we were able to force all HTTPS websites to always load over HTTPS. Therefore, if anybody intercepts our data, it'll be useless because it'll be encrypted with HTTPS. So this solution is really good. It's free. The only problem is, as you know, it only works with websites that use HTTPS. So we seen earlier, if you log in or use a HTTP website, your data is still exposed. Hackers or anybody that intercepts your data is still able to read your usernames, your passwords, or inject JavaScript code, serve you fake updates, and so on. Also, as seen earlier, with this plugin, the hacker or anybody that intercepts your data will be able to see the websites that you visit. Not only that, but they'll also be able to manipulate DNS requests, and therefore they'll be able to run DNS spoofing attacks. At the end of the previous lecture, I said if you want to take your security to the next level, then you should think about using a VPN. Let me show you what happens when we use a VPN, and then I'll explain it in more details to help you understand what's happening. So I'm back here at my hacker machine. As you know, it's already the man in the middle. I'm going to clear the screen, And I'm actually gonna even turn off HTTPS everywhere. Now, it's a good idea to use both at the same time, but I'm just gonna turn it off just to show you the difference. You can use any VPN provider you want. It really doesn't matter. Most of them use more or less the same technologies. We at Z Security provide our own VPN service called ZSVPN. So I have it right here. It comes with no logs. We support all operating systems, Linux, Windows, OS X, Android, and iOS, and even Tails, which is a privacy-focused Linux distro. So, like I said, you can use anything you want. They all use more or less the same technology. What I want to highlight right now is what happens when you actually go ahead and use a VPN. So, I'm going to open my client and I'm going to connect to a server, one of these servers right here. And what this will do is it'll establish an encrypted tunnel between my computer and the VPN server that I just connected to. Therefore, right now, let me show you. Let's just start. I'll delete everything. And let's start by going to some websites. For example, we'll go to google.com. Then we'll go to bing.com. And then let's go to Stack Overflow and make sure it loads over HTTPS. Now keep in mind, I am not using HTTPS everywhere, but you'll notice that it'll still load over HTTPS. As you can see, we're not able to downgrade it. And let's take this even one step further. Let's go to vulnweb.com and just log in. So again, this is a website that only uses HTTP. It simply does not support HTTPS. But let's log in and see if we can still capture the data. So I'll just put my password now, 0987654321. Log in. And let's go back to our Kali machine to see if we detected anything. Now, as you can see, we're not able to read any of the traffic sent to and from the target. So with the case when we used HTTPS everywhere, we were able to see at least the domains, the websites that the target visited, and we were able to see data sent over HTTP when we logged in to vulnweb.com. But in this case, as you can see right now, we can't see the username and the password even if they're sent over HTTP to vulnweb, and we can't see the domain names that the target visited. And the reason for this is because we are using a VPN, and like I said, a VPN creates an encrypted tunnel between our computer and a server, and all of our data will be sent through this encrypted tunnel. Let me explain this to you with diagrams to make it simpler. So in general, let's say you try to go to google.com. Your connection will pass through a number of hops, but at the end, it's going directly to google.com. Hence the red arrow indicating that this connection could possibly not be encrypted, therefore your data might be at risk. Now, when you use a VPN, you connect to a VPN server in a certain country, and when you do that, you create an encrypted tunnel between your computer and the VPN server. So let's say you want to go to google.com. That request will first be sent to the VPN server. Now the VPN server will be able to read this, but the data is sent in an encrypted tunnel. Therefore, if anybody intercepts this data, they will not be able to see what you are sending to your VPN server. That's why we don't even care if someone manages to intercept our connection, because our data is simply gonna be gibberish to them, as you can see in here. Then, once the VPN server receives your request, it will forward it to the destination that you're requesting, and the response will follow a similar route. Now, because of this structure, because of the way that the data is always encrypted between you and the VPN server, using a VPN can be useful in so many scenarios, because it adds an extra layer of encryption. Therefore, it improves our privacy and anonymity in general. It allows us to bypass censorship because let's say your internet service provider is preventing you from accessing certain services or certain websites. They will not be able to know what these websites and these services are because again, the connection is encrypted and they won't even know what you're doing. All they'll see is that you're connecting to a server in some country. And last but not least, it'll also protect us from hackers or anybody that intercepts our connection, again, because all of our data is encrypted. Therefore, we don't really care who intercepts this data. The data will be gibberish. Now, also because of this structure, you need to be careful when you pick a VPN provider because this structure introduces the VPN provider as a man in the middle. So as you can see, we send everything to the VPN server first and then it goes to the internet. And the VPN server is able to decrypt this data because the tunnel, the VPN encryption, is only used between our computer and the VPN server. So if the admin of the VPN server wanted to analyze your data and see what you send and receive, they will be able to do that. Therefore, you need to make sure that you pick a reputable VPN provider, a company that you can trust. You want to stay away from free providers because providing a VPN service is very expensive. Therefore, if someone's able to give it to you for free, they must have another angle or another reason of why they are giving this for free. You want to make sure that the VPN provider keeps no logs. And with all of that, you can use HTTPS Everywhere plugin with the VPN. If you do that, you will actually fix the problem of the data leaving the VPN server because your data will be encrypted between your computer and the VPN server with 2 layers of encryption. First, using the VPN encryption, and second, using TLS because of HTTPS Everywhere. Then, data leaving the VPN server will be encrypted with 1 layer of encryption, which is the encryption enforced by HTTPS Everywhere. Therefore, even though the VPN provider is able to see your data and able to decrypt the encryption used in the VPN tunnel, they will still not be able to see your data because it will still be encrypted with TLS. So this basically solves the problem of the VPN server being able to see your data because at the VPN server, your data will still be encrypted with TLS. So to summarize the 2 methods that we covered to protect our data from man-in-the-middle attacks, with HTTPS Everywhere, it's great, it's free. The only problem is it only works with HTTPS websites. The person intercepting the data will still be able to see the websites we visit, and they will still be able to run DNS spoofing attacks. Then we spoke about using a VPN, and with using a VPN, everything gets encrypted, so that's even better. None of the attacks that we talked about and that we covered in this course will work because everything gets encrypted. The only problem is it's not free. There are free services, but like I said, they're not great, so you shouldn't use them. Just don't use a VPN if you don't want to pay for it. The other problem with the VPN is that the VPN provider can see your data, so you're introducing a man in the middle. But we can take this one step further and use HTTPS Everywhere with a VPN. And with that, we're getting all of the benefits of using a VPN, so everything gets encrypted, protect us from all man-in-the-middle attacks, but without the problem of the VPN provider being able to see our data because our data will be encrypted with 2 layers. Therefore, even the VPN provider will not be able to see what we send or receive because it'll still be encrypted with TLS. So the only downside to using HTTPS Everywhere with a VPN is the fact that you have to pay for the VPN service.